right, good morning, everybody, and welcome to the first Open Virtual Assistant Workshop. And this is the first event that we are holding as the Open Virtual Assistant Lab. It is a brand new lab, and we just got started. And we're glad that I'm glad to see all of you here. We've been sending messages to each other for the last month or so, and here we are. And thank you for coming. And so this workshop is a little bit rushed in terms of a preparation, and we didn't give a lot of people a lot of notice, but I'm so glad that many of you can make it. There are a lot of people who couldn't make it, and then the workshop is also oversubscribed because we have a relatively small room, and that is why we are now making it available on YouTube. It's like being live streamed and recorded, so please go tell your friends and colleagues. So I'm Monica Lam. I'm a professor in the computer science department. I'm also the faculty director, and I'm organizing this workshop with James Landay. And so we're glad that we pulled it off, and I think we have a really incredible group of people here. We learned a lot in this journey of putting this workshop together. We found that the response has been overwhelming, and we learned that there are a lot of different kinds of companies who are interested in this kind of an initiative. And we kind of rushed this preparation because we felt like the virtual assistant is a space that is moving really fast, and there is really just no time to lose. So we found that there are a lot of absolutely exciting research in this space, and it is going to go on for a while. And this is an exciting time for researchers. We found that there are a lot of companies. There are companies besides the obvious large virtual assistant providers from Apple, Microsoft, Google, Amazon, and so forth. And there are a lot of companies who are interested in also creating virtual assistants. A lot of companies are interested in voice interfaces with their customers. We've also seen a lot of interest from open source organizations. A lot of them are interested in the privacy issues. There are also nonprofit organizations who are very keen to make sure that the technology is available to them. And then we also discovered there are a lot of people from many different companies, from many different countries. They are interested in making sure that virtual assistants technology are available for their languages. So what I think we have gathered together is just it's just a representative of a large group of people who are interested in this space, and we've gathered a lot of exciting, visionary people here, and I hope we can together do something very interesting, and I'm sure that everybody will be learning a lot from this workshop. So we have a very, very crammed schedule, and there are lots of interesting speakers, but unfortunately we can give each person just a small amount of time, so I hope that people can stick around and we will have time to interact with each other in the reception at the end of the day. So, James, would you like to also speak and say hello?
So I'm James Landay. I'm a faculty member also in computer science. I work in the area of human-computer interaction, and I'm one of the co-founders and associate directors of the Stanford Institute for Human-Centered AI, which is helping sponsor this, and some of you have been here at our conference for the last 2 days. I just wanted to thank Monica. She says we co-organize this. She's done all the work here and a lot of it. And I think what's really exciting for both of us is this project that we've started is really kind of in reaction to this realization that the interface of the future is finally starting to come here, and that it's speech and language, and maybe even we'll get to multimodal and other things at some point. And now it's really important for the research community to come back to this area that many of you have been breaking your pickaxe on for the last 30 years, but a lot of people have left because it just never was going to work. And but now really it works, and how are we going to shape it to be useful to people, and our interest in making sure we do this in a way that preserves people's data. It allows innovation to happen in an open way. So I'm pretty excited about what we might accomplish today at pushing this agenda forward. So since the schedule is tight, we should just start. And Monica is our first speaker. So Monica Lam.
I'm back. So what I would like to do is to give you an intro to the work we are doing at the Open Virtual Assistant Lab. It's OVAL. If you've been to Stanford, you will not forget the name because that's the oval we have at the front of our campus. We have gathered together a group of faculty from various subdisciplines in computer science. From HCI, we have James Landay, Michael Bernstein. In AI, we have Fei Li, Chris Manning, and Chris Ray. And from the systems group, we have David Mazieres, distributed systems, blockchains, as well as Dan Bonnet, who is an expert in security. We also have Jen King, who is the director of consumer privacy and the law school. And we got together, and very recently, in about half a year ago, we got an NSF grant from to work on this project, and we're very lucky that John Markov wrote us up in the New York Times, and here is a picture of the team. And he calls us the Stanford team that aims at Alexa and Siri with a privacy-minded alternative. It is just to launch the project. We really have a long way to go to make this happen, and I hope that a lot of you can join us in this journey to make it happen. So let's start by talking about the goals of OVAL. This is a really exciting time for computer science research because I think we're seeing three paradigm shifts. The first one is that we have a shift in human-computer interaction, right? I mean, we have been on the graphical user interfaces forever, since the beginning of the PC days. And now we're talking about natural language. We're now talking about the human language, I mean, the preferred mode of communication. And wouldn't it be wonderful if we can just talk to the computer? It'd be so much faster, and it's so much more flexible. And at the same time, we're also seeing a new web. Right? Instead of going to your browser to browse the web, we can now just talk to your virtual assistant. You can get information about the public web. You can get information about your personal accounts, all the different accounts from all the different web services. All the IoTs are out there collecting all kinds of information about ourselves, and now we can also get access to that using a single interface. So the virtual assistant is a very powerful agent, and especially with the access to all our private accounts, it has a lot of private information about us. So that leads to the third issue, which is what is going to happen to privacy? The virtual assistants could be your enemy, but it can be also your best friend, because if we are able to build a virtual assistant that we can trust, then we can use this virtual assistant to help us with a lot of different tasks and different things that we want to do. For example, take sharing. Sharing is fundamental to people. I mean, we are social animals, we need to share. If we have a trusted agent, then we can have the virtual assistant help us share anything digital without having to give up our data to a third party that owns our information. And so what we are seeing here is the beginning of three new shifts in paradigm: HCI, web, as well as sharing. And what we see here is that these are the technologies that have to be done in the open and be made available to all the companies and everybody in the world. And we're not interested in just doing the research. We want to make sure that this technology gets out there. We want to play the role of a neutral party that brings companies together like we have today, to try to really create a new ecosystem based on this open source research. And we want to take it all the way from the collaborative research to industry deployment. And that's that's the mission of the lab. So let's take a look at where we are today. There are a couple of really very, very helpful and powerful assistants today. I would say Alexa and Google being two of the front runners. And if you just take Alexa, today it has 100,000 skills on its platform. And the way it works is that people enter the information about how to interface to their different websites or skills. And all the AI is done in-house, but it is only available to Alexa. So in a sense, what we are saying to all these companies who are putting skills on Alexa is that you get access to all the users that are using the Alexa speaker, but at the same time, you are also sharing your customer relations with Alexa. And to some extent, as Alexa gets access to your passwords and your account information, you can potentially be also sharing your intelligence that is embedded in the data of your customers' accounts. And this is a tricky trade-off for some of these companies that may find this to be threatening maybe to their business. And so there are some pretty worrisome issues there. And what we are really witnessing is the beginning of the emergence of these proprietary linguistic webs. Will there be one web from Alexa, one web from Google, and one from every other company? What does that look like, and what does it mean to the open web as we know it? And the question that comes up is, will there be an oligopoly, a couple of companies, one or two or three, that control the web access and see the billions of users' data? So there is a question of open competition as well as privacy that we are dealing with here. But let's step back for a minute. Does it really make sense to think that all this technology of this linguistic web is going to be built by one or two or three or four companies? Okay, let's take a look at the scale. Today we have 1.7 billion websites out there. All right. And there are all these different websites in all these different languages, and there are representing many, many companies, for-profit and non-profit. How do we scale to take all this information available on the internet and make it available via voice or via language? Okay, that's a lot of work. And then the second question is the cost and privacy. Okay, if you think about the virtual assistants with voice, today we are relying on deep learning. Deep learning relies on getting real user data. And that is very, very expensive if you have to collect a lot. First of all, you have to have access to the users. It is also very expensive because you have to annotate it. And in the meantime, if you're taking real users' data, there is a question of privacy. There are a lot of news stories lately about large companies annotating private conversations, and consumers are feeling, maybe this is not what they want. All right? So that's cost and privacy. Finally, we also have to consider the complexity. Today, a lot of the assistants I keep helping you with with the simpler commands like turning on the TV, turning on the lights, answering simple questions. But if you imagine this virtual assistant has to grow up, it has to be providing more functionality, handling more complex commands, and eventually you're going to be talking about interactive dialogues. There is a lot of work to be done here. If you look at the technology right now, at the language, at the at the AI level, intent classification is one of the most common technologies. It is really not that powerful, but if you look at how we handle dialogues today, you have the dialogue, rewriting dialogue trees and so forth. It is extremely time-consuming, and it's also very, very brittle. So what do we do? So we see that there is a question of scale, cost and privacy, as well as complexity. And our solution here is that we really need to have newer, better technology that helps with the language interfaces. And we want to focus on tools. We want to make a lot of tools, make it available to a lot of people so we can empower the entire industry. And by working together, we can put the entire internet on this linguistic web. Okay, so that's really the vision and the goal of what we are trying to do here. So what I want to do today, in this short talk, is just to give you an overview of the work that we have done, and then there'll be more details that will be provided in the rest of the talks, and some of the talks from our group. And So the key idea that we are pushing for this work is what we call natural language programming. What we imagine is that the user says something in natural language, and then it is directly translated into code. If you look at how assistants are built today, we usually take the natural language and translate it into some intermediate representation that closely matches the natural language in semantics. And that is a lot of work, and you imagine that you have to do that for all the different natural languages potentially, because the languages are different. The way we look at it is that we can approach it in a different way. Okay? After all, this is human-computer interaction. A computer on the other side is just a program. Okay? The best a computer can do is to execute a program. Okay? So what we say is that why don't we just go straight end to end from natural language to code. And in between, we put a neural network that will help with the natural language part and have it directly translated into a formal representation. Because after all, that's the only thing the computer can do. And as we increase the power of the virtual assistant, we increase the power of the formal language. So with this translation, you get nothing less and nothing more than exactly what the computer can do. So this is a very different approach than how a lot of virtual assistants are built. So here's just a simple example. If you take a sentence like this, show me the top-rated Spanish restaurants, say, in the area. That sentence itself can be translated into a formal sentence like the one we have shown on the right. And if we map it if we map the problem of virtual assistant into this natural language programming formulation, we are able to do various things that today's assistants cannot do. Here are just some examples of queries that are really pretty natural and things that you may want to find out. So for example, if I want to find a restaurant, it's like, show me restaurants that are rated at least 4 stars. But you know that restaurants that don't have a lot of ratings, the reviews are not trustworthy. So you may want to qualify it by saying that, it's 4 stars, but with at least 100 reviews, okay? So this is a very simple statement. But unfortunately, if you take some simple statement like this, it's already doing multiple joins in the databases, and it actually has to do a little bit of computation. And if you ask this question from the commercial assistants we have today, they can't answer those questions. They can't answer this one, and they can answer 1 or 2 of these examples of queries that we have put up here. Whereas for us, we have a research prototype, and we're able to answer all these different questions because we are using a different technology, which is based on natural language programming. So let me go back to this concept, and I want to break it down a little bit. I want to show you the major tools that we need in order to make this happen. And it is just an overview, and the details will be presented later. So let's take a look at this sentence again. Here is the natural language, and that is the code. And we take this, for this formal language that we're using, we have to invent our new programming language. It is not just Python or JavaScript, because that's unsuitable for the purpose of natural language translation. Our formal language has 2 parts. There is the construct. We called the language itself is called ThingTalk. How things talk to each other. So the constructs are provided by ThingTalk. They are domain independent. And then you put, for these constructs, put all the different operations together. And these operations correspond to all the things that you can do digitally in the world. Okay, all the information from the web, all the IoTs that you have, these are the operations. So a small, very small number of constructs that connects all the different things together. And that's how we model the formal language. So for example, if you take this particular sentence, primarily this is a sorting of the values of a bunch of fields from a table in a descending order. That's what that sentence actually says. And if you substitute the field with the rating value and table with the restaurant, then you get that particular sentence. Okay, so ThingTalk, first of all, includes a bunch of operations or constructs that you typically see in query languages. But it can do a lot more. So here's another example. When it comes, so the example I showed earlier is about querying the web. But we also have a lot of IoTs. And there are a lot of tasks that we do that involve putting information from different IoTs together. We would like to be able to have an assistant that helps us connect these devices to solve a problem that we have, instead of just executing simple commands like turn on the light or open the garage door. So here's an example, right? Suppose that people have security cameras now in their homes a lot. And people like me or like you, we do a lot of traveling. And what we would like to be able to say is that if my security detects motion, if I am not home, then take this information and share it with my dad. So my dad can go check up on the house for me, okay? So that's a very useful command, and we would like to be able to just say this in English and have the code be automatically generated using this concept of natural language programming, and have this be run by your virtual assistant that you trust. Okay, so that's the basic idea. And for that, we have created another ThingTalk construct. Here, these are three lines. When something, get something, do something. We map it into a language on the right-hand side, which says the first line is monitor some event that is generated by the IoT. You get some more information. You compute the result. Take a look at the location. I am not home. Then in that case, go send the message to my dad. Okay. So now here's an example of how we take a sentence, turning it into code. And this is the construct is very, very simple, but the strength comes from the fact that my Thingpedia, the encyclopedia of all the things I can do digitally, can be very rich. And when you put them together, you can do a lot of interesting things. So here's an example. This is the when, get, do ThingTalk grammar. When something, get something, do something, and anything that you get in terms of the values, you can do filter on them, and you can personalize it to refer to the actions that you want. Here are just various sentences that you can put together with a very simple grammar, simple construct. And this is the kind of thing we want our assistant to be able to do. And we have a fully working system that is able to do this kind of things. So we said that we have very simple constructs, and by the way, after doing some research in this space, we think that there will probably be less than 100 constructs, okay, that we can put together, and it will be good enough for us to be able to, manage or automate the tasks that we do digitally. So now the next question is, how do we put all the operations that you can do digitally into this encyclopedia so I can refer to them all right? That's the question of scale. So the good news is that there are lots of abstractions out there that we can already take advantage of. So let's start with the web queries. If you look at the web out there, 40% of these websites are using this abstraction called schema.org. Okay, this is a standard that has been created over the years, and it is intended to be used to help the search engine in answering questions. Okay. And so schema.org contains a lot of, these are abstractions. This is restaurants. Restaurants have ratings, locations, and opening hours, and so forth. So it's a standardization that a lot of these websites follow. So what it means is that if we take schema.org and then put a natural language translation to schema.org, now you can access all the websites out there that are using schema.org. And we have created a semi-automatic technique that converts the schemas into natural language ways of invoking these, of getting this information. Not a lot of, it's like not everything on the web is in schema.org at this point, but what we see here is that if we can enable the conversion of information from websites into voice commands or queries with schema.org, we expect a lot more people will be participating and be putting information up. So they don't have to put up their information in any specific skill repositories. They put the information up on the websites, and now we can have algorithms that automatically make that information available. And so this is a direction that we can scale a lot of information and bring it online in the linguistic form very easily. So we're very excited about that possibility. So that's the data on the websites. Now there are a lot of APIs that are beyond the websites. And we kind of classify them into 3 different categories. The first one is these unique web services. Facebook is unique, Twitter is unique, and so forth. These are the websites that a lot of people are using today. There are no abstraction for it, and you pretty much have to manually take each one of these and create a natural language interface into these APIs. And we have done about 50 of those, and this is work that we have crowdsourced and performed, and we expect that a lot more people can be doing the same with these public APIs, and we can crowdsource this information. So we expect that to grow. But the good news is that a lot of other services have these standardized protocols. So, for example, newspapers, information, a lot of information that is put on these RSS protocols. Email servers, they use the standard IMAP and SMTP protocols. So by us adding a natural language interface to the primitives that are carried by these protocols, we're able to talk to many different email servers and many different newspaper agencies and so forth. And finally, there's a group of these IoTs. And recently we have connected with the Home Assistance community. It's an open source community. And they have like over 1,400 brands of IoTs that have been organized into a very small number of abstract primitives, abstract representation. And now we are in the progress of opening it up and getting the open source community to attach natural language to these abstractions. So we are pretty excited about the possibility that if we work together, we can put a lot of information on this linguistic web. So far, what we have said is that there are constructs, the formal constructs, like when something, get something, do something, or queries, very close to SQL. And then there is the library of primitives. Now we have to put them together. So if we are able to remember exactly the words that we use to put into Thinkpedia, then you can use a simple algorithm that match the sentences into code. Okay. So for example, if I say when my car is at home, that corresponds to a primitive, and it is not plugged in, another primitive. Send me a reminder email, a third primitive. Okay. If you say the exact words, we can match it, and we are done. But in real life, we're not going to remember those words, and now we have a natural language understanding problem. Okay, so for that same rule that is obviously useful because you don't want to get up in the morning and find your car not plugged in, you can say all these different sentences, and this is where the challenge is. We need to be able to pick up these natural language sentences and say it's the same thing as that simple sentence. And that's where the neural network comes in. So the problem with neural networks is that it takes a lot of data. We talked about the cost and the privacy associated with annotating lots of personal data. So what I'm going to show you is a tool chain that actually generates a neural network parser that uses no real user data in training. Okay? So the basic idea is that we take, for example, the schema.org abstraction. We take a sample of the data in the web today. We semi-automatically generate all the entries in Thinkpedia. We now know the natural language phrases to refer to all kinds of things on the web. The next thing we do is that we send it to Genie. Genie is a new tool that we have created. It's a semantic parser generator. It takes the Thinkpedia entries, it takes new constructs such as the program high-level constructs like ThingTalk, and we also require the programmer to put in templates of how to connect things together. So we are asking the developer to basically program how to generate the training data, okay? And we will explain that in a little bit. So once you program this, we synthesize millions and millions of data. You can keep improving the template, and so we can get better and better sentences. So that helps to teach the system compositionality. And the next thing is that we take 1% of the data and we send it to the paraphrasers in order to learn natural language. And using that, we are able to create a neural network that translates natural language into code. You take the code, and now you can apply it to the web, and it will give you the answer of what's out there on the web. So that's the flow. So it's Thinkpedia, Genie, LuiNet, and ThingTalk. And these are all the tools that we have created. And they address the issues of complexity through the concept of natural language programming, cost and privacy, because we are really not using real data, and we are talking, and we have a chance of scale because we are using the existing abstractions. So what we are hoping is that by putting the tools out there, we enable a lot of companies to build linguistic interfaces for themselves, put them on their websites, in their apps, in their phone services, and make it available to all the assistants all at once. Okay, the existing ones, the new ones, and more, more assistants that people can build. And as a group, we have been building a virtual assistant, an open source virtual assistant called Almond. Let me tell you about Almond. It's an open source private assistant. It is all open source. That means that you can run it on your own devices. You don't have to share your credentials with anybody, with any cloud service if you don't want to. So today, your natural language needs to be translated in the cloud. And that is because we need to do the training. But we imagine in the future, we can do the inferencing locally. So you can translate the natural language into code. And I want to point out the difference between this and the existing assistant models. When we translate the language, we are just saying, is like, suppose I say, what is the balance on my checking account? It is translated in the code that accesses a bank for its account balance. But actually, it's not executed. The execution of this code is on your own Almond device. So Almond is the only system that knows the credentials, and it executes the code, and it gets the checking account. So we are separating the translation from the actual private data, and the private data is completely owned or by you on your own assistant, on your own Almond assistant. Okay, so it is all open source. We imagine in the future that there will be web service provided, and potentially for a couple of dollars a month, you can have a virtual assistant in the cloud that you pay for, and nobody reads the data. And more importantly, Almond is the first assistant that can communicate with other assistants, okay? And this is very important because we want to enable sharing without a centralized service that sees all the participants, okay? So the idea is that I have my own Almond, you have your own Almond, and we can communicate with this protocol. We have a very rich protocol. It is actually the ThingTalk protocol itself. And what it means is now that I can communicate using very high-level semantics. I can say it, there is natural language, and then there is code that corresponds to it. And so, for example, now you can combine the concept of natural language programming and communication. Here is a use case. So imagine a doctor wants to monitor the blood pressures of his patients. Different patients requires different kind of monitoring. By using natural language, he can prescribe the program that the patient needs to execute. It's like, and you have to check your blood pressure 3 times a day. And I need to know if it goes above 200 and 120, okay? And he can just say this instruction, make this command, translate it by the natural language on Almond, from natural language into code, and send it to Anne's assistant, who can help with the communication. Here is a model where now 2 people can be communicating with the help of their assistants, and the data are shared without having a third party seeing all this information because the protocol is secure. So what I hope I have convinced you here is that we have kind of laid a new foundation for potentially, for all these 3 topics: HCI, web, and survey, and sharing. There's a lot of work to do, but I felt like this is, we have enough of a basis to open it up for more collaboration. And that's why we are launching this lab. And this is the goals that we have for this year. It's pretty, for the coming year, it's pretty very ambitious. So to start, we are launching this OVAL Open Virtual Assistant Lab affiliate program. And we are in the process of identifying the key partners that can help make this happen. Our main goal in the coming year is to put open virtual assistant technology on the map. So far, we have been doing the research and doing the implementation. What we have done is the Thinkpedia, ThingTalk, LuiNet, and Genie, they're all released. Almond is available as an Android app. It's available on the web. The iPhone version is in progress. We are starting collaborations with companies like Home Assistant and as well as Microsoft on their bot framework. And what we want to do is to create a minimum, is an MVP, a minimum viable product this year. We need to integrate with speech to text. We haven't done it yet. I hope that some people here can help us with this. What we want to do is to put top 10 skills in Thinkpedia. For example, music, news, or restaurants information, and so forth. All right. We want to make it available to every assistant, and we want to make sure that it runs on Alexa, on Almond, our own, of course, Bixby, and Google. And in the meantime, we also want to build up the community. We are organizing workshops, tutorials, hackathons, and we hope to be able to provide tech support so that a lot of people can help build upon our technology and collaborate. And we also want to start working on the next topics. We want to collaborate on research and create new standards. And what we see in the next round is, how do you represent dialogues? How do you implement dialogues? Multimodal interfaces, standardizing on the communication protocols across assistants, and we also want to get new ideas. So there's a lot of work to do, and we hope that we can get a lot of people here to participate. This is the next year. What we see a couple more years down the road is that we want to be able to start an open industry consortium. And the way we are approaching this is basically the model that was taken by the project software-defined networking. How many people have heard of that term? Okay, then I don't have to explain that much of it. It started as a research project at Stanford about 10 years ago, funded by NSF. It turned into an affiliate program with a lot of major industry, major companies helping to create a standard that is industry strength. And then after that, they have formed an open consortium. And today, there are 150 companies in that consortium, and it was projected to reach about $100 billion industry by 2025. So they have absolutely opened up the space of hardware networking, which was once dominated by just Cisco. And so it's very exciting in the hardware networking space. And we want to see the same here. So we've got the NSF research funding. We are starting the affiliate program, and by 2022, hopefully, we can start this consortium. We see the need for a consortium because we have to, for example, do security audits for the Thinkpedia entries. We have to continue to create the new standards, and we want to be able to truly support, provide industry-level support to make sure that everybody can build on top of this open source software. Okay, so it's a lot of things here, and I'm hoping that a lot of people here in this room can help us get there. So that's what we have, what I have. So thank you for listening. Almost on time. So maybe we'll take 2 quick questions, if there are any. Or we can talk later, because I'll be around, and hope to see you for the rest of the day. So maybe we can just get going and stick to this and keep to the schedule. So the next thing on our agenda is that we have invited a number of supporters for this initiative and friends to talk a little bit about how they see, to give their opinion, their ideas about the vision and challenges of open virtual assistants. And to start off, we want to hear from Santander. Unfortunately, Michael Hart cannot make it, but we have Carrie, and who can talk about, who can talk to us about the vision. Thank you.
Hello, I'm from Michael Hart's team in Santander in the UK. We'd just like to share with you a few of our thoughts on Open Virtual Assistant, because we've been communicating and collaborating with Monica for a number of months now. I think for us, virtual assistants offer a significant opportunity for inclusion and engagement, because it very much puts warmth into the technology-human interaction and connection. I think people seem much more connected with technology when they're comfortable with the interface, and for the majority of people, voice is very clearly a way to do that. But I think we've begun to have drift towards a binary trade between convenience and privacy, which is very much hot on the agenda, because ultimately all of these things are all about data. And what we would like to see with more open approaches is the ability to have a more negotiated, equitable view of privacy and how our data is used as consumers, for our consumers and businesses. Because I think there's 2 key things here. The consumer, and what this technology offers, is the consumer wants a really personalised service. We all are individuals, and we want to feel unique, and we want to feel unique in how we engage, and that's what we at Santander would like for our customers. But then the privacy angle is absolutely key to us, because how our data is being used and what it's being used for is of paramount importance to people. And it's not binary. It depends on the circumstance. For me, as an individual, if it's a consumer good, I'm pretty open about what you want to do with my data, because, like most of us, it's about a good deal. But if it's something far more personalised, and Monica gave an example in her introduction, that's about my medical records or my health, that's a very much more closed conversation. And in order to achieve this big ambition, you absolutely need what Monica's just outlined in the last 2 slides. You need a very open collaboration. You need to create a network and an ecosystem that's not just about open technology, it's about open collaboration and open minds. Because for us, the goal of this work as well is to be able to put our customers back in control of their destiny, their data, and very topically, their voice. And so that's why we're really supportive of the work Monica and her team are doing. Thank you.
Yes. Next up, we are very happy to have Larry Hack. And you have a Samsung developer conference going on at the same time, and he's taking time to come and talk to us about his vision. And Larry is the CEO of the Samsung Viv Labs, and that means that it is the Viv Labs is the labs that brings us Bixby. And Larry has been involved in so many different companies working on so many projects. Maybe you can kind of tell them a little bit about
I don't wanna
where you
bore
come
them
from
with
and
I know many
what
people
you do.
around the room.
Yes, I know.
At different companies. So this, I have some videos in here, and I don't think this, so we don't have sound, so I'm going to try to,
There's sound, but
oh,
there's
there
sound.
is.
We have arranged it,
Oh, perfect.
and it's
Oh,
here.
great. Awesome. Let's see if it works.
Oh, this is something you can probably put this in directly.
Oh, it needs
What do you
the
have?
translate, the
Which one do you have?
USB-C.
Oh, you have USB-C?
Yeah,
That's
so I
good.
think that-
Okay,
I think
sorry.
that worked.
That's good. Can you reach?
Okay. Thank you for getting the sound. That's awesome. Okay, so let's, I'm going to show several clips of videos, and these are.
You gotta stay by the microphone.
Oh,
That's
okay.
for the-
Oh, for the, okay.
for the live stream.
Oh, for the live stream, okay. So I'm going to show several clips of videos, and I'm not going to have time to go into a lot of details on each of them, but the videos are probably most important because what I'm trying to show is what I'd like to see in the near future, not necessarily only working on the core technologies. We all need to do that and continue that. And I'm not saying that we should stop working on the core technologies, but I think we also need to be working on the higher levels, on the ecosystem part of the virtual assistants to get them to scale. So of the three things that Monica talked about in terms of goals, we're definitely supportive of all three, especially the sharing piece. So you'll see the sharing part of this in the first video. So let me start the first video. This is kind of how I'd like to see things in the near future, at least the start of them. So let's see if the sound works here. Nope. Sound's not working. Oh,
So it's supposed to have max volume already.
okay,
you
so
have
maybe I
make
have
sure
to-
you turn on your mic, your speakers.
yeah, that's probably. There we go. Maybe one of these. Let's try it. Okay.
Did you pass it on?
Yeah, it's probably my lack of
To the headphone jack.
do the headphones.
Yeah,
Is this the headphone?
yeah.
Yeah, that's what it was on, but maybe.
They said they-
Alexa, help me plan my
Thanks.
anniversary. Sorry, I don't know that.
Okay, Google, help me plan my anniversary. Sorry, I don't know how to help with that yet. Hey Siri, help me plan my anniversary.
Sorry, I can't do that.
Hi Bixby, can you help me plan my anniversary?
I'm not sure how to do that. Can you teach me?
Okay, so notice that I didn't show Bixby that we solved that problem. What I'm trying to show here is an unanticipated task. In this case, it's a higher level task where, in this case, we want to bring the user into this problem-solving mode that collaboratively between the assistant and the user will solve that problem. So there's a design philosophy that I think we should be following, which is always helpful. And always helpful is not just an aspiration that someday, we get all the core technologies problems solved, the systems will just always work, it's always perfect. I don't mean perfect. What I mean is that the systems will always provide some benefit, maybe getting you part of the way there towards your task, and then let you, with the assistant, complete the rest of the task. So saves you some time. So that's what I mean by always helpful. And of course, the best example of that is web search. I think that web search in the 90s, if it had a design principle that's similar to what we're doing with virtual assistants, which is you either get it perfectly or you just say, I'm sorry, I don't know how to do that. I don't think web search would have taken off like it is today. I think the reason it took off was even if you subtract away 20 years of relevance improvements to the search engines, it was still always helpful. It would get you part of the way there, and then there were other mechanisms to let you collaborate with the search engine, and it still is today. You know, refining your queries and clicking through and that. So it's interesting that in the virtual assistant community, we've sort of gone away from that. I think we should come back to this kind of notion. So what would it look like in the virtual assistant space? You know, something, let's say the request is something like, hey, I'd like back row seats to Guardians of the Galaxy tomorrow at 7 p.m. Most systems a few years ago would have said, I have no idea what you're talking about because of the back row seats concept. Now, many of the systems will just ignore that you said back row seats and get you all the rest of it. So it'll do all the rest of it. And then if you then come back, yeah, but I want back row seats, and the systems will say, well, I don't know how to do that. I'm still learning, right? So imagine that staying within the conversation, within the assistant, you could actually complete that task where the assistant is watching what you're doing and helping you do it, but probably most importantly is learning how you actually completed that task and what that concept was, in this case of back row seats. So we facilitate learning by demonstration. And I think this is a major area of, obviously it's already a major area of research, but it's a major point of connection, I think, right now for personal assistants and that research community on learning by demonstration. So at the individual level, in addition to the system's learning implicitly from your interactions, with the assistant, we empower the end user to provide explicit feedback by saying, let me show you how to do this. Buy me back row seats to the theater. Okay, go to Fandango. Okay, there's the widget. Okay, I'm going to touch on the back row seats. Okay, remember that next time. Learn that concept. Now, for an individual, remember that it only has to work just for the individual. So there are certain ways that you're going to be saying things or referring to things so that distributions can be relatively tight. But of course, we can think about sharing. And this is the part about sharing. We can start thinking about sharing between the users such that you could benefit from, let's say, the effort that somebody else put into their assistant. So if I taught my assistant this concept of how to find back row seats, or let's say I want to check the grades for my son at Los Altos High, and I have to go through 7 steps to do that, well, okay, there's a task that's been learned that I've taught my assistant about how to do that generalizes, let's say, to other schools. And let's say later, you don't know me, we're not associated, you're in a different part of the country or the world, and you want to, get back row seats, or you want to check the grades, and it just works for you. And you think, oh, must have been anticipated, inside of Bixby that I wanted to do that. But what was really occurring was that there was another user that actually showed by example. So we start setting up this sharing network effect, and obviously privacy is a huge deal here. Very much playing to what Monica was talking about. We don't want to be, learning how to get access to your bank account and share that information. So the current approach to scaling within the different assistants is very much focusing on the developer. And so I was at Samsung Developer Conference yesterday, I gave a keynote, and I very much focused on, we still are, let's make it easier and easier for the developer to build out these kind of capabilities. And so I think that's right. That's definitely the right path, but I think we need to go further if we really want to scale up the number of skills that we're talking about. We need to involve the user and the user community as part of the development of this AI. So that there's a number of technical challenges that's associated with that we have to solve if we're going to do that, so that we're effectively sort of crowdsourcing this AI skill level. So how do we start this? So let me play another little video clip to show what it might look like.
Hey, Bixby, help me find an anniversary gift for my parents.
How about flowers?
Nah, traditional one.
I'm not sure what a traditional gift does. Can you show me?
Go to Wikipedia, search traditional wedding anniversary gift.
I found wedding anniversary on Wikipedia.
Okay, scroll down. Scroll down. There.
Okay, I'll remember that. Since it's your parents' 30th anniversary, how about a gift of pearl earrings and mother of pearl cufflinks?
Perfect.
Here's a selection of earrings and cufflinks.
Start.
Bixby learns new capsules from everyday interactions with millions of users on every kind of device, from Family Hub to all of Samsung's products. Bixby brings the multi-device experience to life.
By the way, at the very beginning, I showed, the system not knowing about wedding anniversary, and so each one of these clips is different aspects that different people are teaching. So I'll show a few more, and then at the end we'll put it together. But this notion of reading tables and understanding semantically, Alon's here. I mean, there's been a lot of work in the search community, web search community, for a lot of years on this problem to be able to make that kind of structured or semi-structured information discoverable from search engines. And so there's a lot that can be leveraged there and plugged in. This for personal assistants, this idea that you can show the assistant, hey, this is what I mean, this is the content, in this case, the definition of wedding anniversary gifts per year. I want you to know that, and then, okay, now I want to be able to talk to you about that and help me complete the task, given that you got this new information. The same thing, there's many sources of structured information out there, and I know Sujit's been doing a lot of work on this as well at Google, and Dilek and I have done a lot of work on this. A lot of things to be leveraged. Forms is another example, all the way out to computer vision. There's a lot of structure in the computer vision or grounding that you can use, particularly with the advances in the computer vision algorithms these days. And then all of that connecting into a knowledge graph representation. We call it a conversational knowledge graph. It's essentially an extension of a knowledge graph with mining for conversational relations between entities. So on the computer vision side, I think that, so the video just showed, tables, and I think you get the forms. Let me show you what I mean by, or what this might look like with computer vision.
Hi Bixby, help me find a vase that matches these.
I think these are crystal candlesticks, but I need more information. Can you tell me the brand?
They're made by Waterford.
Okay, I found several Waterford vases. Here is the Lismore 8-inch vase.
Is there a larger one?
Okay, here is the Lismore 14-inch vase.
That's perfect. Show it filled with flowers. Andrea prefers white roses. Nice. Where can I buy it?
The Waterford Lismore 14-inch vase is available with 2-day shipping for $495 from Neiman Marcus.
Add it to my cart.
Bixby combines voice and vision to make both work better. Bixby is always helpful and always learning.
So in every one of those clips so far, you've seen there's actually a fail. The assistant did not know how to complete the task, and right now it would just bail. But you've seen that we're leveraging a combination of different technologies to allow the user with the machine, with the assistant, to complete the task. So there's a lot of key challenges. I'm just listing 5 here. But when you have something like that where you're trying to leverage the structure and the grounding that the user sees when they're interacting with it, of course, one of the first tasks that you have, or one of the first technical challenges you have to deal with is, how do you learn by this task demonstration? So if I show you on an app a sequence of steps, or I point you to a table, or how do you actually do that and learn that kind of information? So the second one is learn the interface to the service backend. So if there is, as Monica was talking about, a query kind of language that you've gone from NL to the query language, or you've programmed it more directly to, back in the app side for, let's say, app indexing kind of accesses into backends. You still need to be able to learn that connection. And then the third is, once you have that, you learn by demonstration and you have this backend connection, and you have the structure, can the system automatically induce this conversational interface to that structured content? And there's been a lot of work done on that over the last 5, 6, 7 years. The fourth is interoperability. You need to be able to, first of all, cluster. Let's say we're getting contributions from all these different users and developers of different AI skills or capsules. You have to be able to identify that, oh, these are the same kinds of things. We can generalize. These are distinct. Some of these things you have to recognize, which you'll see in a couple of minutes on the video, that you need to compose together so that you can actually complete this broader level task. So this interoperability between these AI skills or capsules is super important. And then finally, if all this works, we've created another problem, which is we have way too many skills to deal with. The user starts to interact with their assistant, and how does the system find that there's actually something already there that some user, produced? So we'll talk about that, but I'm just going to talk about that a little bit. I mean, effectively, that puts us back into a search paradigm. So I'm mainly just going to talk about these three right here. So there's been a lot of work done on programming by example or program synthesis. And so the purpose of this slide is just to make that connection, to point to that. A lot of great work, especially at Microsoft in this area. This notion that programming by example is more of a learning of the logical steps. It's complementary to machine learned methods in the sense that you don't need a tremendous amount of data to be able to learn those kind of concepts. But it's complementary because you certainly want to be able to refine what you're doing with data after you get that kind of those construct of the task. And the combination of work that's being done by developers and data that you get that you're learning that is kind of a hybrid model, this idea of logic plus data. And like I said, Sumit has done a lot of work on this over the years at Microsoft. It's actually in products like Microsoft Excel, at least the programming by example side. What he's working on now and what I'm inspired by is this combination. So this is just a sampling of work that's been done on this space. There's lots of other work. Alon's work, and that's continued. Sumit's work I just referring to. There's a lot of work right now at CMU, PhD student there, that's working on building conversational bots for mobile apps, and then how to actually, learn this kind of tasks from demonstration. And then at Samsung Research America, Bixby, in my team there, we've been doing a lot of work on this recently as well. So the third step on this is automatically inducing a conversational interface. And so let's say you had a form, this idea that you have many forms and you can organize these forms by these domains. And it's pretty intuitive that, if you know Southwest Airlines, your assistant knows Southwest Airlines and is able to drive a dialogue over that form, and you have British Airlines, that if you go to KLM, that you shouldn't have to start from scratch. You ought to be able to leverage that information at all levels. There's the form itself, but all the way up to the natural language understanding of the dialogue. You ought to be able to borrow that. And so we did a lot of work on this at Google and showed that not surprisingly, going down the columns here, you can borrow a lot. You don't need much data at all once you have a few of examples from the domains, the verticals. But the surprising part was that there was a lot of benefit by going horizontally across these domains. And it turned out that we started to believe actually there's some finite set, kind of like what Monica was referring to, this finite number, relatively small number of these examples and these different domains, that if you learn that space, you pretty much have it. You need a little bit of data outside of those core things that you learn, maybe, I don't know, hundreds, not that many. But it greatly simplifies the task for the developer or the end user eventually. A lot of work that's been done at Microsoft Research and Google Research, and these are the places I've been. So I've been working on this for a while with Dillick and others.
Hi, Bixby. Can you help me plan my anniversary?
Okay, sorry, I'm going to actually set that up. So this is the last video. So this is where all of the different people that don't know each other have contributed to components or different pieces. Those pieces have been composed together. And now what I'm going to show you is the same query that we had at the beginning, but this one other user benefiting from everybody else.
Hi, Bixby. Can you help me plan my anniversary?
Sure. Since it's your 15th anniversary together, would you like to see some options you and Olivia might like on the living room TV?
Yes. Let's see favorite getaways.
Capsules created by millions of individuals are searched, combined, and composed to make Jack and Olivia's anniversary the best ever. When Bixby learns from many users, powerful network effects benefit every user across all our products. By empowering our users to create their own personalized AI experience, we build user engagement and loyalty, enrich our platform with data, and enable Bixby to become exponentially smarter.
Now, of course, that could be the Oval platform. It doesn't have to be the Bixby platform. Sorry, just one second.
Hi, Bixby.
All right. Well, okay. So let me just say a couple words about the search problem. You know, one of the things that I think is going to happen if we're successful here is that there's going to be a new emphasis on search. But in this case, rather than just going from data to information, we're going to the next level, which is information to the AI skills, which sits on top of and is a superset of web search as we think of it today. And I think a lot of the same kinds of techniques and approaches can be used. There are also the same kind of monetization opportunities, if you think about it, get built that. So it's the difference, though, is that instead of it being a two-way person to search engine with a browser, it's a three-way conversation because you're talking to your personal assistant. The personal assistant is searching for you and then guiding you through dialogue to what you need. And the personal assistant remembers what you did and learns from that from every interaction. Okay, so where are we today on this scale vision? We are focusing very much on the third party, the developers, the 3P. It takes relatively high skill for a third party developer to build these AI skills or capsules. What we're trying to do is drive down that level of expertise while maintaining the quality of these skills. And so our strategy is to get to what I'm talking about to the users. We go through the developers, basically cut our teeth on developers, make our developer experience just easier and easier and easier until the point where power users can start to do this. It's so easy. And eventually we can get this out in situ, in dialogue as well. And then ultimately we have capsules or AI skills writing other capsules because in some situations we don't even need to have the interaction. That's it. Thanks very much. Yeah.
So you talk about skills, but some of these skills involve just learning language. So for example, when you say back row seats for the show, that's a language. If the system will understand the language, it could assemble the action easily. So some of this learning is skills, but some of it is just language. And
Yeah.
how do you decide where?
Yeah, exactly. In that case, the skill couldn't be completed because. Sorry. The skill couldn't be completed because of the one language concept And I would say that most failures are happening because of this. It's not so much that the task wasn't described properly or the skill. It's just that there's a new parameter that wasn't anticipated. And so the reason I put that in there is I'm trying to show that this level of collaboration with the user can be used to learn at that base level, these new concepts, slots, all the way up to composing these things together and learning, tasks. But that's super important. Yes.
I think we probably need to move on.
Okay.
Okay, great. Thank you.
Catch him later.
Yeah.
All right, thank you. All right. Next, we have Jayesh Govindarajan from Salesforce. And we've been chatting for many months about this initiative, and I have to say that Jayesh is the reason. He's the one who encourages us to get this workshop going, even though we are very, very late in the preparation. We didn't have enough time for preparation. Well, thank you.
Thank you. I think I need to connect this puppy, which I'm on the old one here. Do we have an adapter? Maybe. No.
Yeah, it's the other adapter. It's the, what do you call it? Display port. You don't have the.
It's not
I think it's not this one.
HDMI.
You have HDMI?
Yeah, I think this
you
is
don't need HDMI. What do you have?
No, I don't have HDMI. I need an HDMI to this
You have
one.
a non-HDMI? Why do they have dongles for non-HDMI?
Are these your slides?
Yeah.
Can we just, they're on Google Docs?
Yeah.
Let's just use the laptop.
They Google Docs?
Where's the other laptop?
I can use mine. Use mine.
Yeah, let's just do that. Send the link tomorrow.
Okay, I'm just gonna email it to you so it's easier. Sorry about that.
Giovanni. Is this the thing?
Okay.
Go back to the one I have. I hope you don't have sound.
No, I'll make do with this. This one, but HDMI.
Oh, VGA. Don't you
Yeah,
have VGA also? Sorry? Don't
Actually,
you have
not
VGA?
VGA. I think
for
it's
projector?
the Thunder.
You need the mini.
We need a HDMI to this. I did, yeah.
Let's just
Email?
use Monica's laptop.
That's fine.
Email?
Yeah.
I haven't got it.
Refresh one more time.
Is everybody offering connectors?
Yeah, it's gone.
He needs a,
Lightning bolt to HDMI. So there's an HDMI. I can plug that in. So an HDMI to lightning bolt.
I got it.
Got it? Let's just use yours.
It's a PDF file?
It's a PDF file, yeah.
Oh, that's easier.
Thank you, Monica.
Oh, no problem.
Okay. I should upgrade my laptop. Thank you. Sorry about that.
No problem.
All right. Sorry about the delay. Sorry about the delay, folks. So I want to talk a little bit about a slightly different point of view on these conversational systems. And this is the point of view that comes from sort of working on the enterprise side, less on the in-home assistant side. And as you can tell, the kinds of conversations we hear and track are quite different from what one might be talking about with their in-home assistants. Specifically, the structure of the conversation, the length of the conversation, the complexity of calls that you make to your internet service provider, for example, the fact that it's not something that is entertaining. People don't really want to talk to their ISP for getting a problem fixed, but do so anyway. Want to get answers quickly. These are sort of areas where they're different, but there's lots of similarities to, I think, what we're seeing in the rest of the evolution of virtual assistants as well. So on the Salesforce platform, most customer service conversations, this massive scale, of course, about 16 million conversations a day. And there's a canonical structure to these conversations. At a high level, there's an opening, there's a body of work that happens as humans interact to solve a problem, and then there's a closing element to it. We study this because we want to be able to design fully automated agents for scenarios that can be fully automated and assistive agents that can assist the workforce in the whole resolution sort of workflow. In the customer agent conversations, there is further structure that we see. For example, this is a canonical structure that we see in a lot of retail scenarios. There's a greeting, there's a confirmation of intent by an agent. There's a step where there's a back and forth to do with the collection of data. There's a resolution that emerges, and there's a back and forth on the resolution, and there's a closing as well. And this is sort of completely derived from data. And going back to, I think, what Larry was saying, as well as Monica, I think there is a structural element to this that sort of cuts across scenarios. You can bet that there is a similar structure that emerges in great sales conversations, for example. And the key takeaway is that these are topic agnostic. So you might be talking about getting information about an order, or you might be talking about returning an item, or you might be having a conversation with a mortgage agent about getting a new rate for your home loan, and these all sort of go through a structure which is similar to this. And this is no surprise because well-trained agents follow this structure to get and guide to a resolution, right? So that's about the structure, and there's a sort of archetype of structures as well. There's about, I wouldn't say 100 in the enterprise space, much lesser actually, we believe. And the next thing that we looked at in addition to structure is sort of the topics of conversation and what that looks like. This is probably a bit of an eye chart, but essentially what this is us trying to figure out what are the top types of conversations across industries, going back to what Larry was saying. So if you look at retail, consumer goods, cable ISP, banking, insurance, these are sort of 5 top industries that Salesforce operates in. We have access to these conversations. There's always like a top 3 that emerges, which accounts for about 60% of the conversational traffic. In retail, it wouldn't surprise you to know that checking your order status or returning an item are the 2 top ones. There's similar examples in consumer goods, cable and ISP, and banking and insurance. And the takeaway, again, is that these are agnostic of the structure. So if you follow the structure of conversations that I talked about earlier, you can change topics, but be able to get to a successful outcome regardless. And this is great news for designing virtual assistants, obviously. Now I'm going to go into the details here, but skip through this a little bit. Basically shows there's a long tail. If you solve the top 3 scenarios, you're in good shape. Okay, so what we've learned is that across topics as well, there is sort of 3 main areas that emerge in terms of what these conversations look like. One is sort of informational, the other one's confirmational, and the third one's transactional. And this is, of course, important in designing, agents as we want an agent to be able to do all 3 well. Informational, fairly straightforward, sort of where's my order, what's the monthly payment for this basic policy, really doesn't need a transaction to be executed. There's information in the back end, and you want your virtual assistant to be able to answer that question effectively. The second one's confirmational. This is more like a lookup in that, are you eligible for an upgrade? Has that order been shipped? These are also simpler ones, but we see this coming off a lot where where users have something they're expecting, and they need to actually talk to a system to be able to do it. Completely automatable. The third one, which is the tougher one, is the transactional bit. This is, a lot of the examples and videos that Larry showed and Monica talks about are, fall under transactional. And I think this is where there's a lot more work to be done in terms of building systems, task-oriented systems that each of us are sort of trying to build in the full stack. And this is sort of the point of my talk here, is that if you break open any of the systems that are in production today, be it Amazon's Alexa or Google's, Salesforce's own bots framework, Bixby as well, there's sort of the question answering problem, which solves the informational conformational type of scenarios, and a task-oriented dialogue sort of system problem, which solves the transactional one. And the big takeaway is that there's structure and topics across this, but these are three big areas that if we solved, I think we'd be in pretty good shape. Monica said that we should talk a little bit about challenges. I think the big challenge I see is to Larry's point, is the ecosystem. I think the fact that every single company is building this is a problem for the ecosystem. And that problem is that if you're a developer, you're going to have to build one each and be deeply tied to a system if you want to do a good job of building a task-specific virtual system. For the platforms, this ends up being a bit of a zero-sum game, right? I think for those of us that were around when Java kind of got started, this goes back to sort of write once, run anywhere assistance. We are far from it, and this is probably the reason why the ecosystem hasn't really taken off. And I'm not talking about the 1,000-odd simple skills that are being put out there. I'm talking about like sophisticated systems that work. The reason it's not out there is because it's expensive to build one, and then it's tied to one domain. So I think that's a problem which we will see eventually roll out if we don't solve this problem. And I think the third thing that both Monica and I think Larry you referred to as well is that there is a need to unbundle these elements, right? Because this is sort of a monolith. We have device capability, which is the very lowest layer. In our case, those translate into APIs that we build on top of. From a developer's perspective, it's a skill that they're producing in the form of an API. And everything on top is being able to compose that into higher order tasks, and then a front end, which is essentially a conversational front end. These are sort of kind of a layered cake, if you will. And I think the big takeaway for me is, at least, and the reason we need to sort of align on this is that there's areas of collaboration that we need to unlock so that this ecosystem can be built and thrive. In the interest of time, I think I'm going to stop, but I'm open to questions as well.
Maybe we can take it offline.
Offline, yeah?
Yeah. And then we have Frank. Hi. And Prem Natarajan is the Amazon Alexa AI ML VP. That's a lot of work.
NLP.
NLP.
I think Jayesh is the AI ML.
I see. So AI
VP,
NLP VP.
Yeah,
All right.
yeah.
Well, thanks for talking.
Thanks. So good news is I don't have slides. Bad news is I can still talk. Right. So I thought. I was thinking about comments that would be relevant for sort of this forum for the Oval Workshop. What we think we can get out of it, and what kinds of problems might be useful to address through this forum. The first question when I had a chat with Monica a few days ago, she asked was, why is this a good thing for a place like Amazon, or why would we support it? And I go back to things like Kaldi or Stanford Core NLP things, or even going further back to CMU's Sphinx and Janus things. I think it's important to have even if it's not deployable strength, industrial grade, state-of-the-art platforms in academia, so that the research that's being done on these platforms is also state-of-the-art, and it's advancing the state-of-the-art. And then the PhDs come out, those who go into academia are also at the leading edge, but those who come to industry, which, as you know, vast majority of PhDs, it's not like the social sciences or the arts where a PhD is a path to an academic career. Most PhDs come to industry, they come ready to contribute. So I'm very hopeful that this will create, as conversational AI as a field has been evolving as a field, we've had speech recognition, you've had NLP, you've had machine translation, you've had these component technologies. There is a science emerging that we'd like to see come to fruition as a field of conversational AI. The phrase has come. The general science in that field, it would be good to see it develop out, and I think that's the contribution that Oval can make, and that's why we're in support of this initiative. God knows if we had 100 scientists standing here right now, we'd interview right now and make at least 40 offers, right? So there's no dearth of opportunity for talent that will come out of these initiatives. In terms of the problem space, these AIs, as we like to call them colloquially, are super useful in the home today, but they're not so far up the AI stack. If we think about the AI stack with starting from phenomena modeling, or moving next to some kind of intelligent decisions, moving next to reasoning, and then autonomy. And then I tend to think of automated general intelligence as sort of beyond top of stack. It's a stack that I don't find practically inspiring or useful to me for my lifetime or my kids' lifetimes, right? But within that movement, I think we've made the transition from the phenomena modeling, which I think of as the sensors are picking. Of course, there's a sensor layer, but sensors are picking up speech, or you're getting in text, and you're inferring some things from them. And then we've gone up to the stage of intelligent decisions. But getting to the step of reasoning, a common paradigm is, I think of, is search. We do search in a particular way in the browser world. We don't know what it looks like in other kinds of interfaces. Even experiences like shopping. There's the opportunity to actually interact with the user in a way gives you an opportunity to exercise your reasoning about certain things. And what do we reason over? We reason over context, right? What's the personal context of the user? What's the world context? So I think as these AIs are to become more capable, one area I find interesting is how do we bring in more and more context, whether it's personal context, the ambient context of the user, or the world context and what's happening in the world, and how do you better do things. A second thing I find interesting is, or will be super useful, is continuous learning. We build, we deploy, but we'd like these systems to sort of, at least as a lower end of our aspirational scale, maintain their performance post-deployment. Being able to do more things post-deployment and learn new things post-deployment would be awesome, and that's a very sort of noble science goal, and one that we're also interested in. But just maintaining it so that you don't degrade from the day you deploy is an important thing. So a simple example of what we've deployed on that front, my colleague Ruhi Sarikaya's team has deployed, is this thing called feedback-based learning that operates at the front end of the system. So it does corrections automatically with no human in the loop. So if you say, Alexa, play SiriusXM chill, and Alexa doesn't know what chill is, you'll have a frictionful experience because she won't respond. She says, I don't know how to respond to that request. If 100 people say that, 95 of us may walk away, but 5 of us are like my youngest daughter. They keep trying, right? And so what happens is there's enough signal there to learn and say, 5 of them, maybe 4 of them said, Alexa, play SiriusXM channel 53. you can observe over time, and when you can aggregate over data, this is a little bit of a peek into reasoning. It's not like really the exciting thing, but a little bit of a peek. You now learn you automatically learn an equivalence class. That SiriusXM chill is channel 53. You can also learn other corrections like send me Lopper is play Cindy Lauper. It just happens to be a very common kind of error that happens, and so you do that too. So at the front end, you can fix some of this frictionful experiences for the user and make that experience better very rapidly. We can do this sometimes within hours, often within a day. We fix all of these friction. But what would be interesting is how do we bring back some of those concepts further up the chain? Because once I've learned that chill is the same as channel 53, I'd like to be able to answer questions in a completely different domain. I don't want just to know that this question is equivalent to this question. It'd be good to know this concept is equivalent to this concept, but then to be able to reuse that concept in a different context. Like if I say, who's the founder of SiriusXM Chill? That's a completely different kind of domain and context. We'd like to be able to answer that question without, again, having to rely on saying, I don't know, and then somebody else then says, hey, who's the founder of SiriusXM Channel 53? So there are problems like this where you can detect behavior-based signals at the very tip. You can fix the friction at the very tip, but then how do you bring that stuff back all the way up to the chain? So I think that's super interesting. There's always a lot of talk of reinforcement learning. It'd be good to see a deployable version of something that actually does something for users. So I would say that should be a grand challenge task for Oval. Certainly if students and faculty at Stanford can't do it, there is a reason to not be optimistic about it. So I would say that's something to look at. There are limited areas in which reinforcement learning works, but the big notion that we can learn to do new things through reinforcement learning by involving the user would be good to look at. There's a bunch of other things, how to expand the conceptual space that these conversational AIs operate in without requiring the kind of annotate, train, and deploy approach we have. Unsupervised learning, not just as a way of improving the performance within the space we operate in, but expanding the space that we operate in, et cetera, would be interesting. So with that, I look forward to coming back next year and seeing all the awesome work that the students who are involved with this lab are going to talk about. Thank you.
I can use yours.
You can, yeah.
Yeah, here,
Do you
use
have
yours.
your autoplay?
Yeah.
You have your autoplay set up? Oh, then it's okay. Just go
Okay,
ahead.
where's the
Right.
adapter? Oh, this one, okay. Okay, so what we're going to do now is a little different. Let's see if we can display it actually. Do it on this monitor. Okay, we'll just leave it like this, I guess. So we were going to try to do a quick introduction to everyone here. Some of you may have done this before, and hopefully the network will stay up here since we're using Google Slides. So maybe I should just try mirroring this to make this actually work. Well, it's the Google Slides says loading. Which is, you want to try your laptop? Because mine's, no, it was, but now it's not. Yeah. Giovanni, you want to use yours? slides. You can't rely on that. Well, it's not down. It's not downloaded.
I know.
No, it's the Stanford Wireless Resources.
Right. I'll need to plug myself as well because whatever. Power.
So the idea is that every person will give you a slide in advance and you filled it out, giving us a little background on who you are, but then also what you think.
Like the sticker, that was not useful.
Well, we're not going to use the mic actually. So, because not everyone's going to come up here. You're going to stand up when your slide comes up. Yeah, yeah, great. We'll be the privacy. This is where you do a stock tips. So everyone's going to, when your slide comes up, stand up, speak loudly so we can all hear you, and introduce yourself, and you can tell us what you thought about the questions in terms of what you think the future for virtual assistants are, what are the key problems for us to get there. Or you can sing a song, whatever you want. But you have 60 seconds, so please stop when the next slide comes up so that the next person can have their time, and that's why we can get through this thing. And so we will model it with Monica's going to go first. So she's going to stand up and.
Hi, everybody. I've already said enough, and I look forward to
Is it
meeting
set
you
up?
outside this room later. Next.
Okay, so as I said, I'm James Landay. I'm here at Stanford. I work in using human-centered AI to support people in what I call long-lived human activities. So things like high level, like aging in place, or things that involve the physical world with your body, things that are dynamic, like learning, education, tasks that are social, they're done in the real world, they're natural, and they're always at hand. And so for me, I'm really interested in the virtual assistant that handles multimodal, natural, multi-turn conversation that people interact with others in the real world. There's a lot of algorithmic work to be done there, as well as tools. And also, what are good examples of applications that take advantage of this so we can learn what some more technical issues are to get forward on this. Okay, is Nurte here?
Yeah. So my name is Proprietary. I came far from the country named Kazakhstan, from Astana city, and I represent a company called TTS Digital. So what we are interested in today and in developing some local products and local IT solutions to empower the lives of citizens in our country, because we believe that a lot of things are happening throughout the world, and we really want to create a connection between the developments in technology, developments we see in the internet, with the lives of actual real people in our country. That's what we do. And as far as the virtual assistant is concerned, we believe that one of the shortcomings of the technologies today, of IE, of NLP, and speech recognition, is that languages such as Kazakh language, for example, which is a very rarely spoken language in the world, requires a lot more separate investment on our side, a lot more efforts for us to develop the same levels of recognition, to develop the same levels of language recognition technologies, and therefore we are very interested in the solutions like Oval, where we could probably try to reuse LuiNet or reuse the technologies which are available here to support the development of, let's say, IE and development of speech recognition and assistance for our languages as well. So this is why we're interested here. We'll be happy to meet you and talk to you if you're interested in anything. Good to see you.
Okay, we're going to try to actually use the mic. So what that will require is you to pay attention where you are in the order and kind of cue yourself up here in time to be able to come up to the mic. That way people can hear remotely. So it is alphabetical. So take a look at the slides, but by last name. Oh, well.
Jimmy, you're out of order, but we'll let you go. You can come and talk.
Oh, that's actually, I had updated all that.
Well, just come and introduce yourself.
Everything else, I think everybody else is in order.
There you go. There you go.
Wow.
So my name is Jimmy Garcia Meza, CEO of CloudPlugs. I work on advanced edge-to-cloud industrial IoT, edge computing, and digital service delivery platforms. What I want from a virtual assistant is part of that, but actually I had an update to that, and I want everything. I want it to be smart, fast, reliable, accurate. It has to be able to run anywhere, on anything. And what I think is preventing it, things to move forward is the fact that a lot of the industry today is very closed. Everybody has their own virtual assistant, proprietary, closed. Everybody has their algorithms tied to the chest. Nobody wants to share anything. I think that's a real problem. So I think what we need to do together is to build a wider open community that can actually build a common base for virtual assistants that then companies can take and build individual vertical applications that it can be commercialized and therefore become a differentiating factor for that company so they can actually monetize their investment. Thanks.
Yeah, come on up.
Hi, I'm Ranita Aronov from IBM Research. Until very recently, for 4 years, I've managed IBM's AI Grand Challenge called Project Debater, which was a system that had a live debate with a human champion in February. And I've just now moved to IBM Research in Almond from Israel. And I'm working on developing natural language processing technologies for understanding. As for virtual assistants, I'm hoping that eventually we could converse with them naturally and keeping an eye not to let them keep us in our own echo chambers, which I think is something that's happening with social media in general. And I think basically we have to do what we're doing here today, and that is continue to develop, research, and have open discussions. Thank you.
Hi, I'm Wendy Belwamini. I'm also from IBM Research, Almaden. What is my dream virtual assistant is one that can actually take on a lot of the tasks that we have to deal with, like scheduling and organizing and planning in a way that actually works. Most of the experiences I've had with virtual assistants are quite frustrating, and I'm sure most people share that. And then the second part is around data privacy, and if I'm going to do that, if I'm going to try to create an assistant that I can really use and saves time for me, how much of my personal data do I have to give over to do that, and what is going to be the result of doing that? Who can get access to my personal data? So I think there's a lot of work to do around creating assistants that are able to use your private data without making that data available to an entire ecosystem. Thank you.
Okay, Michael Bernstein will not be here till later. Giovanni.
Hello everyone, I'm Giovanni. I'm a fourth year PhD student here at Stanford, advised by Monica. And I'm very excited to see all of you. I'm very grateful you came. And my research interest when I started my graduate career were mostly programming languages, although nowadays I move towards other kinds of languages. And I'm also the lead developer in the original, I started the Almond project in 2015 and I keep moving forward. And I'm a big believer in open source because I believe that open source is immortal. Whether it's the Berkeley software distribution, which is now from the space station to your iOS phone, or whether it's Linux on the fridge, my goal is to build the best open source virtual assistant with Almond. Thank you.
So Arun here.
Hi folks, I'm Arun. I am the AI lead at the Conversations team at Square. You may not have heard of Conversations at Square before, but we were a conversational AI startup, Eloquent Labs, that was acquired earlier this year. And now we're working on building chatbots for small businesses to more efficiently communicate with their customers. So it's similar to the enterprise case that we saw Jayesh talk about, but for much smaller businesses. On a more broad theme, what I'm excited about in terms of a virtual assistant is something that helps bridge both getting us more nuance on the information we get in the sort of digital virtual world, but also things that can help connect us to small stores and businesses in our physical world. So this is more than an Internet of Things and Internet of Stores and businesses around us. I will move on for the next person.
All right. Thank you.
Hello everyone, my name is Rob Chambers. I'm an architect and engineering manager at Microsoft. I've been working on speech and natural experiences for a very, very long time, mostly because they all stink in the past and I want them to be much, much better in the future so I can live in science fiction. What do I want out of a virtual assistant? I don't want one virtual assistant. In fact, I want a ton of them. I'm not even sure really I want a bunch of virtual assistants. I think I just want to be able to do a lot of awesome things with my devices. And so I'll talk a little bit more about that this afternoon. But one of the key problems is we're not looking as an industry at how hard it is to actually build these systems and make it easier for, as Larry was talking about, making it all the way to the end user, to get the end user to be able to do what they want and helping us learn when we can't do that. We need less expensive options for development, and that's in terms of the time that developers spend, the money they spend, and the complexity that they have to learn. So thanks, glad to be here, nice to meet you all.
My name is Edward Chen. I work also with HTC Healthcare. In the last few years, we try to connecting internet devices and sending signals to hospitals to do the analysis. So we really want to turn reactive healthcare into proactive. So information security is really critical. Therefore, we also work on multi-level secure blockchain to be able to make sure data privacy is preserved and also at the same time accountability can be also ensured. My dream about virtual assistant is virtual assistant today is really like a machine. I would like the virtual assistant to be just maybe like my spouse. Okay, thank you.
Lynn.
I'm Lynn Chase. I work in Seoul, Korea at SK Telecom, and I'm super jet lagged. It's great to see you all. James and I are old friends. We went to graduate school together. I'm super concerned about the API problem, the complexity of handling all the different products, services, and solutions that we need to connect our users to on the back end and doing it at scale. That's my number one concern.
Joshua. It's good for exercise.
Yeah, hi, my name is Josh Chase, and I'm Chief Strategy Officer at ComScore. ComScore is probably best known as digital audience measurement. We're also now in the TV audience measurement space. Our CEO, who not coincidentally is a longtime colleague of Monica's, has kind of tasked me with looking into different, right? In other words, things that are very different from the businesses that we're in, but that are maybe tangentially related, and also looking down the road in the future. So we become very involved with information, with the way consumers interact with media, and with privacy, because with the big media companies that we work with, privacy is of paramount importance. So we are interested in determining or understanding if there is an opportunity for us in the virtual assistant space, and in particular in maybe helping consumers manage their data, helping sitting between consumers and multiple sources of data. There may or there may not be, but we are very much interested in finding out.
Hello everybody, my name is Marc Duranton. I work at CEA in France, and I'm involved in neural network and artificial intelligence since 1988, so it's why I have a gray hair now. So now I'm working more to bring artificial intelligence more near the user, both from the hardware, so local processing power, and from the software. What is my dream virtual assistant? So it's really an assistant that could help me to interface with the cybersecurity cyberspace in a safe and secure manner so that it will protect me from leaking my own information, but also protect me from the hackers or from the fake news and things like that. So what is preventing now from happening? So it's multidisciplinary work that we need. And we have a proprietary stack. So we need to break all of this. So one other challenge is the complexity of the orchestration of all these skill capsules together to bring higher level of intelligence. And of course, we need computing and storage to do it locally. And what do we need to do? Well, working together. I think that's, if everybody is working in the same direction, then we could bring to at upper level. And we need a common framework on API, and just a teaser for my presentation this afternoon. Thank you.
Hi everyone, I'm a PhD student here in computer science with Monica. Thank you for all coming out. I have two simple dreams when it comes to virtual assistants. The first is that they don't communicate just with voice. So right now, if you want to communicate with a virtual assistant, it has to be all through voice, but it can be somewhat of a limiting factor. So one of my research projects is using AI to automatically lay out graphical user interfaces so that it can communicate with screens as well. And then my second dream is for people to want to use their virtual assistants. So right now, a virtual assistant connects you with other devices, but no one looks forward to using Alexa or Siri, but people do look forward to using like Instagram and Twitter and Facebook. So I think virtual assistants need to do a better job of not just connecting us with other devices, but also with like other people. Thanks.
Double. Is Nicholas here? There we go.
Hi, I'm Nicholas Gay. I'm a software architect at Salesforce. So what I'm working on, Jess is my manager. He talked about the problems we're trying to solve, so it becomes my problem to solve them. In terms of Dream Virtual Assistant, I'm looking for something that's natural sounding, easy to create new skills, works on multiple platforms, and respects my privacy. In terms of what's preventing that from happening, I think we need more open standards so that we can work together and make it easier to develop new skills for virtual assistants. And what we need to do to get there is to work together collaboratively, and sessions like these definitely help this whole process. Thanks.
Show it here. Oh. Okay, Kathy's coming on up.
Hi, I'm Kathy Jory from Mozilla, and I'm a colleague of Joe Fish's in the Emerging Technologies Lab, but my focus is primarily IoT. But one of the things I've discovered is using my voice to control smart home devices is really useful and satisfying. And I just want to mention that Mozilla, that does all open source software, if you go to iot.mozilla.org, you'll see our project. A gateway runs on a Raspberry Pi. This one has a touchscreen interface as well. And I can talk to it, and my voice processing is run locally on this device, right? So the language model of IoT devices, of smart home, is small enough that we can run it on device, never has to leave the cloud. So I can do workshops, people can create their own IoT devices, give it a name, and I can still incorporate that dynamically into the language model, and it just works. So if you're interested in, Mozilla is not a hardware company, but purely open source technology that respects people's privacy and personal agency, we'd love to collaborate with the companies that are producing the products that will, deliver that privacy model to consumers.
Hi, I'm Kerry Godwin. I'm Director of Growth and Advisory in Emerging Technology at Santander UK.
Mine and my team's role is to consider the assets of a bank and how they can be better deployed for the use of our customers, consumers and communities. So my ideal virtual assistant is one that completely democratizes access to technology in a more natural way. But at the same time allows customers an informed choice over their privacy and their use of data in a very supportive way, because it's complex and we need to demystify it for individuals and companies. And how we will do that is by an open collaboration and working together, and projects like Oval are a perfect mechanism to do that.
Hi, I'm Antonio Gomez. I work also for Santander as part of the emerging technology team. So we are trying to see how the latest technology can be used to help our customers. My dream virtual assistant would be something that helps me to have more free time. So something that can do things for me in an easier way. What I think is preventing us that from happening, I think the virtual assistant that we have at the moment can help us with very basic activities, but not with those activities that will add real value to ourselves. What do we need to get there? I think we need to keep investing, and hopefully by working together we are going to be able to get better things. Thank you.
That's me again. Jayesh, I lead AI and ML at Salesforce. My dream virtual assistant is a completely personalized, trust, context-aware, multitask agent and multimodal. Increasingly, I'm thinking that it has to be a wearable. It needs to see what I see. It needs to listen to what I listen to. What's preventing that from happening? I think we are sort of at the stage where there's lots of foundational work that's happening on the research side. I think we need a framework that can bring it all together and accelerate taking these systems into production, and a common framework where we can share data in a trusted manner and share algorithms as well. What do we need to get there? More of these meetings and conversations.
Hi, everybody. I'm Ann Grimes. I'm with the Brown Institute for Media Innovation here at Stanford. I'm interested in how virtual assistants can be used for news and the problems that come up with that around context, bias, personalization, privacy, and echo chambers. Is this just going to contribute to the current problems that we have now? I'm also interested in gender issues and how we might make Alexa a little more like Alex or something more gender fluid. Thanks.
Hi, I'm Tom Gruber. I was the co-founder and CTO of Siri. It's a little over 10 years old now, the project. And I'm here partly to help see if we can get to the next generation, which I think is more about personalized and proactive intelligence. And I'd like to change the narrative on the narrative about data privacy from a fear of Big Brother into an embrace of Big Mother. And what Big Mother is, it's AI that nurtures, helps you grow, it protects you, right, from the bad guys, and it also helps you, all of its goals are aligned with your goals of living your life the best. So every single piece of technology that it helps you with is around your goals, and that's what I like to see happen. Thanks.
Hi everyone, I'm Sonal. I work at Facebook and I'm leading the team over there to work on natural language understanding and research projects on it. I've been working on virtual assistants for the last 4 to 5 years now, and what drives me to work on it is it's the new paradigm of communication. People just expect the devices to talk back, and we need to do better, to understand better. And I think the challenges from the technical viewpoints is we need lots of data to train these virtual assistants. So there's a big lack of generalization. They have to be trained on domain-specific stuff, and you have to keep collecting data sets. And learning the context and learning when to forget the context is really hard. And what we need to do is come together and talk more often. Thank you.
Hi everyone, I'm Dilek Hakkanitur and I work as a researcher at Amazon Alexa AI. My research is basically enabling conversational machines. I've been working in this area for longer than I want to code, but I started working in natural language processing first, then my interest shifted towards speech processing, then machine learning, and now multimodal interactions. These are all needed, I think these are all fields that are needed for enabling real, actual conversational agents. And I'll be talking this afternoon, so I'll cut this part short. Thanks.
Hi, I'm Alon Halevi. This is what I looked like 10 years ago. I just joined Facebook 2.5 months ago, so don't ask me what I'm doing there because I don't actually know. I've actually spent a big chunk of my career working on tools for helping people find data, whether it's in different databases or on the web, and sharing data easily. So I'm actually a really big fan of what's being discussed here. I think, so I've dedicated my career to facts, finding facts. With all due respect to facts, we humans are emotional creatures, and all our desires and our requests for information are somehow driven by emotions, and the way we interact is driven by emotions. And I think we need to think about the emotional layer of our interactions from the very beginning in order for this to be really successful. So that's what I'm excited about.
Hello, I'm Marcely Hancock, and I'm with MediaX here at Stanford, and I'm also with IEEE. I chaired the Child and Student Data Governance. So I appreciate that mental image of the big mother. So my concerns are currently the big brother issue, particularly around children's health and wellness and the impact of our B2B data-driven practices. And when I met Monica earlier this summer, I went, this has the potential to not only become a big mother, meaning help me to understand how to live better because you can know more about me and I can have choices. It allows for, you can lift off of computing in a way that respects privacy and have a big teacher. Your smart speakers and your virtual assistants can not only help you manage the details of your life that are important but not, you can say they are sufficient but not necessary but not sufficient, and have a voice assistant that really helps you learn to live better. And that means health, so manage my health information, my health learning. It means my education experience, and it means anyone, any mother in any world, location, in any language can create an experience that improves the life of their child. And also, it is the really great step in moving to a data marketplace where we've been B2B with data and data models and business models, because the overall big picture, if you know the complexity of identity and what that means, and you know the complexity of interoperability, and then if you know the complexity of data models or data standards, being able to bring them all together and then execute by separating, it gives us an interoperable, open potential for a data marketplace within a completely new set of revenue models that also can enhance and improve our lives. So I am a huge fan.
So Viv Labs was founded by a couple of the guys that founded Siri with Tom. And that was in 2012. About 3 years ago, Samsung bought Viv Labs. And in May of this year, I went from Samsung Research over to become head of Viv. So Viv now is the core of Bixby just in the past year. So we're still ramping. So this is the summary of the things I talked about. What are you working on? Empowering developers and users, emphasizing that collaboration with users to create the broad AI. What's my dream virtual assistant? Always helpful in the way I defined it and always learning. What's preventing it from happening? All or nothing kind of queries or conversations that just stop when the systems don't know one little thing. So rather than saying, can you teach me? And then what do we need to get there? We need an open ecosystem and advanced AI to create this AI network effect I referred to. Thanks.
William here? No. Joe Fish. I didn't see. Do you want to introduce yourself?
Yeah, sure.
Please also note where you are on the slides so you can come up.
Sorry, I did not fill here the blanks, but my previous startup was Balgram. I was founder and CEO. We were solving the problem of it was a conversational assistant. The idea is to capture all the conversations from phone calls and video conferences, transcribe them, make them available for search, but also, more important, is surface recommendations during the conversation. So imagine like a salesperson or a business person during a phone call, they have a very limited time in order to pitch their value proposition. So imagine if you can, even a very small hint can make or break this conversation. So if you can service those recommendations during a conversation, that's a huge benefit for any sales or business person. So I'm very interested in this space. Obviously, we started earlier. I think it was prematurely, but then I think now time is ripe to be able to benefit from from all the development in the AI space. Thank you.
Thanks, James. Hiya, my name is Joe Fish. I'm Principal Research Scientist at Mozilla. And I'm really excited about the conversation that we keep having these stories around open, right? I think open is really important because it's good for innovation, right? It's not just because it's a nice thing to do, right? It's actually the right thing so that you get innovation, you get new products coming out in the world, right? There's this problem that we're in this data-driven world in which if you have data, you can create innovation. And if you do not have data, it's very hard to create innovation. And that stifles innovation from small companies who don't have access to that data. And so I think making that available is really crucial. We're seeing that the current oligarchy is not even good for the big companies, right? Look at the number of skills on Alexa right now and how many of them actually gets used, right? Those repeat usage rates are really, really poor, right? We want to have that innovation, like across the whole industry. We need that opportunity. And there's questions we need to answer, and I think the people in this room are the right people to answer it. Do we have one assistant? Do we have an ecosystem of assistants? Is my assistant going out there and talking? Do I say to my assistant, hey, go ask Alexa to put cat litter on my shopping list. Go ask Google what's next on my calendar, right? We don't know where those points of intersection are and where the loyalty of those assistants lie. So I'm doing a lot of work on voice, and I'll be talking more about that later on. There's this problem that nearly all voice input and output right now is basically a keylogger, right? You can choose which large company you send all of your voice data to. And that doesn't seem like a long-term solution that's going to work very well. So we're doing a bunch of work around both text-to-speech and speech-to-text to make that better. We're doing that in a whole bunch of languages, including Kazakh. You and I should talk later. We're getting pretty good at Kazakh languages and ways to learn from languages where we have a small amount of data. And we're also doing a bunch of work thinking about what comes next. Are there multiple consortia, right? We've talked about whether there's a consortia around the work going on in this room. I know that John Stein has something that he's working on around open voice stuff. Is there just one of these? Are there multiple of these? What does it mean to actually have a consortia that can move an entire industry forwards in the same way, if you think about something like the Alliance on Open Media has done with Open Codecs, or even the LAMP stack. So I think there's a lot of exciting stuff. Thank you all very much.
Hi everyone, my name is Irwat Hasanov. I'm from Kazakhstan, Institute of Smart Systems and Artificial Intelligence, Nazarbayev University. So my background is mostly on speech recognition, domain notation, language models for speech recognition, and I'm here to learn about virtual assistants. I'm actually new to the world of virtual assistants, and I want to learn from the world experts, from you. And for about the dream virtual assistant, I don't have any yet, so hopefully at the end of the day, I will have one. Thank you.
Good morning, everybody. I'm Jen King. I am the Director of Consumer Privacy at the Center for Internet and Society at Stanford Law School. However, I should say I'm not a lawyer. I'm actually a human-computer interaction scientist, and I am on Monica's team, collaborating here at Stanford. So my vision is really an open assistant that not only respects privacy, obviously that's my bread and butter, but I'm very concerned about creating these virtual or voice systems that really comprise all human interaction within a commercial context. So I'd like to see these systems open and much more broadly than just shopping machines. And hopefully I'll be talking a little bit later about the impact of the law on these systems. Thanks.
Hello everyone, I'm Zornica Kozareva, engineering manager at Google. So I lead multiple teams that are handling G Suite search and assistant. But one of the things that we're really handling today is like how do you build on-device models for NLP and ML. We want those models to live entirely on your smartwatches and phones and never leave it. We want the same high quality, just like server-side applications. I'm going to talk about this in the afternoon, but really where I want to challenge people is like, can we start building multimodal assistants that understand, interact, reason with us and other assistants. And as you see, there's like tons of challenges there, like how do we even map, fuse, transfer information between those modalities, even to execute a simple command like show me recipe for a souffle, given that I already melted the chocolate. So can I get to that specific video frame, which is going to tell me what do I do next? So how do we get there? I think we're very comfortable working on the same problems over and over again and just trying to change our models. But I think we should stop. We should start like failing faster, trying to do multiple things and bring different communities together to make bigger innovations. Thank you.
Hi everyone, I'm Jian Li. I'm a visiting student in Monica's group and I'm from Chinese University of Hong Kong. So my dream virtual assistant should be able to conduct fluent dialogues and should be fully personalized and most importantly, it keeps my data safe. But current AI models cannot perform well on memorization and reasoning, so they're actually not intelligent enough. So to get better virtual assistants, we need more data, better natural language understanding techniques, and also collaborative effort for standardization and regularization. Thank you.
Hi, everyone. Good morning. My name is William Lee. I'm an engineering manager at Apple in Siri. Hi, Tom. How's it going? Thank you very much, Monica and James, for organizing this today. As I mentioned, I work in Siri natural language understanding. In terms of what my dream virtual assistant is, I think that it's a technology that is helpful, that gets things done as quickly as I want to do them, and that one that's aligned with my values of maybe privacy and productivity and well-being. I think what's been interesting for me working on a product like Siri is that I go to work every day and think about building the most useful virtual assistant. Maybe less about how such a system needs to sell products or market things or use my information and so on. I think what's preventing this from happening in general in the virtual assistant space is I think we need to continue to address open research problems in machine learning and natural language processing, in human-computer interaction, in information privacy and security, and in public policy. So I'm really excited to work with many of you today on this, and what do we need to do to get there? I think we need people who are working on these problems, who are really interested in engaging with them, which might be just a polite way to say that I'm hiring, and or that we're hiring, or if you're ever interested in internships, full-time positions, but really just coming to visit, seeing the spaceship, or continue. I think the best way to address these problems is to work together and to think deeply and work on solving these problems. So thanks very much.
Hi, good morning. My name is Yolin. I work for a small company called Smart News. Probably not many people have heard about this. This is actually a Japanese startup that's actually specialized in high-quality news informations, now also including non-news informations, to personalize discovery for end users. One of our dreams certainly have a virtual assistant on news. I think that's currently the Alexa and the other personal devices has some room for improvement on news experiences, right? So just play NPR news, it's not very personalized, also not conversational. So I think that it'd be great if this virtual assistant can answer my questions. Like, okay, is the Trump impeachment, why is he impeached? What's the view from the left, what's the view from the right? What's the timeline? So I can ask a lot of questions to the assistant and give me the knowledge about these things. So what's preventing from happening, I think, is the understanding of the semantics. Also, there's a cold start problem because the news is so new, so fresh. There's not much structured information out there for us to extract. So we had to use some very, very deep technologies to able to quickly summarize these new informations and give users the best informations. So how do we get there? I think that's a good thing that we're actually very close to Stanford, our offices. So we hope to really collaborate with OVAL and also other industry experts to work together on these challenging problems. Because I think that's we do want to solve the problem for polarization, for echo chambers, and also deliver a balanced news for all the users. Thank you.
Hi, everyone. My name is Victoria Lin. I'm a research scientist at Salesforce. My research interest is semantic parsing and natural language interfaces, especially to databases nowadays. Our company offers customer relationship management software. So in terms of my dream virtual assistant, I expect something which can not only communicate with human fluently, but also enables people to operate with extreme efficiency in certain professions, such as sales, scientific research, and writing. So in terms of the current obstacles, first of all, so a lot of virtual assistant nowadays handles only limited natural language patterns. So in terms of how could it actually accept diverse natural language patterns and communicate with you like a real human, clearly lots of NLP research still needed. And also to solve complicated tasks for lots of domains, the knowledge infrastructure is simply missing. So we are taking baby steps, starting from the more well-scoped domains and to more complicated tasks. And in terms of how do we get there, I think more from the technology perspective. So we should leverage the more powerful learning paradigms nowadays, such as pre-training to help you reduce the amount of data annotation you need, and also imitation learning, reinforcement learning, human in the loop to help it continuously learn from human beings. Thanks.
If anybody's name starts with M, come on up over here. There are 3 or 4 of you, so come into that corner so you're ready. Go ahead.
Hi, my name's Scott Love, and I'll keep it quick. I'm here because of Monica and James. You gave me a presentation, I think it was about 6 months ago, and I was bouncing off the walls. I just thought this was really cool, mainly because of the early sort of thinking about creating an ecosystem. And what I liked about it was there's plenty of places for people to innovate. And I'm part of a new startup. It's called Consilient Labs. And we have a very modest vision. I think we're thinking about the same problems, the same opportunities. We're taking a little different approach, which is we're going to build some tools. We think they're really important tools centered around a different model for memory. And I think everything I'm going to learn here today, I think a lot of the work will depend on sort of remembering. So our goal is to build a system that can remember, but remember at the edge. So that's our goal. You can read everything up here. I was being slightly funny about my agent having humor and wit, but I think that's important. We want something that, it's not the machine, it's just, it's more reflective of who we are individually. So that was my goal. Okay, thank you.
Hello everyone, my name is Arindam. I work in Alexa AI in Amazon along with Prem and Dilek that you already heard from. My team works on conversational AI efforts in Alexa, and I run two programs there. One is a new way for developers to build skills using a AI-driven dialogue manager. The name of the platform that some of you may have heard of is Alexa Conversations. And the other program is AI Grand Challenge that academics participate in called Alexa Prize. So what's my dream virtual assistant? I want virtual assistants like Alexa and others to be able to anticipate and enable completion of complex goals for customers. So you could start a conversation with Alexa by asking, what's the weather? And you should be able to continue on to buy event tickets that day, someplace that the weather is good. And, we don't complete those goals today. What's preventing from happening is it's incredibly hard for developers to anticipate those needs and to actually write the dialogue management, infrastructure to complete such goals. So we need to invest in infrastructure and technology capabilities that reduce the burden on the developers for creating such dialogue experiences. And we also need a framework where these ecosystems of different developers allow us to share information so that these cross-developer experiences can be realized. So that's it. Thanks.
May around here? Liz?
Hi, I'm Liz Murnane. I'm a postdoc in computer science here at Stanford. I'm very fortunate to work with James Landay. At a high level, my research designs, engineers, and studies the impacts of technology aimed at supporting well-being of both people, but also the natural environment on which all life depends, largely focusing on applications in health, education, and sustainability. Virtual assistants certainly play a role and have a lot of promise in this sort of work. I'd love for us to realize a vision where they help enable not only task automation and information consumption, but also production and practices that are creative in nature. I think to get there, one thing we need is to move beyond trying to replicate human-to-human style interactions and dialogues and really embrace innovating entirely novel paradigms for engagement with these sorts of systems. And then I'm, of course, going to advocate for human-centered research to really deeply understand people's mental models and preferences and needs when it comes to these systems, use those insights to inform the design of their characteristics and roles, and then test them in the real world to understand how they actually impact people's lives. Thanks.
Okay, so NP and R people, be ready. Brown. No?
I don't have anything more to say.
Okay. Lucian.
Hello everyone, I'm Lucian. I work at IBM Research in Almaden. My work is focused on building human-in-the-loop AI tools that aim to bring data closer to domain experts. So our team works quite a lot on various combinations of techniques for document understanding in the enterprise, information extraction, combined with entity resolution and other techniques to curate data. So since I work a lot with data, my dream assistant would be one that would understand that and fulfill the data needs of a domain expert, even when these needs are complex, with minimal teachings and examples. And I think we are still very far from that. and I may be working on this for a long time. Thank you.
Hey, how's it going? I'm Alex. I'll keep it simple. I work on a project called Snorkel, which is an open source platform for letting users, especially domain experts, even those who don't know how to code, programmatically build and manage training sets. I guess brief introduction, it's currently being, it's an open source project, Apache license, it'll stay that way. Currently being supported by a company in Palo Alto, about 15 of us, including the majority of the core team that was at Stanford up until recently. And I'm also going to be heading up to University of Washington as a CS professor there in 2020. So there's a bit of open source, a bit of academic research that's still ongoing both here and soon up at UW, and then a bit of cold-hearted capitalism. So the basic idea of what I'm interested in is somewhat orthogonal to the particular application. Maybe I'm like, this is a horrific example building off of my my capitalist riff there, but if people, this is a conference about building shiny new cars. We're kind of the oil refinery, and we're focused on how do you actually let people build training data for all sorts of tasks. So if you go to snorkel.org, you'll see that we've worked on text data, video, done a lot of two recent Nature Communications papers on medical monitoring, so over time series, EEG, radiology, stuff like that. But a lot of it has had to do with enabling people to rapidly build training sets for domain-specific tasks, tasks that involve privacy. A lot of our collaborators and users actually care very much about the eyes-off setting, where ideally no human would actually look at the majority of the data, so that programmatic labeling enables that. And also where data and objectives change. So both the input to your model and the output schema are possibly rapidly evolving, and so you don't want to spend a couple months creating a hand-labeled training set that then has to get thrown out the second that something small changes. So we work on techniques for that broadly within the area of weak supervision, and I'll tell you more about that in the next talk spot. So really excited to engage, and yeah, thanks.
Hi everyone, I'm Sujeet from Google AI. So I lead a few different teams. We do a lot of work in neural structure learning, semi-supervised learning. So one of the core issues is how do you learn with minimal data? And so at Google, we've been doing a lot of work on the research, and also this has been applied in like almost every Google product that you can think of. We work in both language and vision. So I have the fortune of also doing multimodal because we work with like both types of problems. And in addition, with like Zornitsa and other folks, we've been collaborating on on-device machine learning. I must say this is an extremely challenging area, and for privacy-preserving AI, this is important. 3-4 years later, we're at a stage where we can actually say, hey, this is actually viable, right? We can actually do this, right? And we might want to consider this as the alternative than what we're doing right now. In terms of virtual, I'll talk a little bit more later this afternoon about that. Virtual assistant, like dream virtual assistant would be, of course, it has to be intelligent, privacy preserving, easy to use, right? I don't have to, like for complex tasks, like change how I, like interact with the assistant every single time or as the task complexity changes. And moreover, it should be able to reason and continuously evolve and adapt and learn from relationships both in the physical world and the digital world, right? So we have a lot of rich information, both whether it's from knowledge graph, like Larry touched on a few of these things, or interactions with like people that we interact with, right? It could be virtual assistants for them. And how do we make sure that all this information is distilled into like the knowledge that my assistant has and perform efficiently. So one of the core aspects like which I haven't heard, like or somebody mentioned earlier is it has to go beyond intents and slots and getting tasks accomplished or even simple generations. We should be able to understand things like emotions of the users that are expressed within conversations because your response from the assistant might change based on that. So there's some work that we are doing in this aspect as well. What do we need to get there? This is a great first step, I would say, this forum, but also like interactions between different research communities. Just for privacy preserving, we need the hardware and software, ML communities to come together. Just like that, we also need sociology and other disciplines working closely with the industry and academia, right? So hopefully we'll get there. It shouldn't take like another 5 years to get to a better state than where we are today. Thank you.
Yeah, hey, my name is Paulus Schoutse. I'm the founder of Home Assistant. Home Assistant is an open source home automation platform. We collaborate closely with Almond and we are integrating with it. I'm going to talk more about that after the break. My dream virtual assistant is really one that helps me do my stuff that I want to do without actually limiting in what it can, what I want to do because of the technology constraints. And for me, we work in open source. Things like Almond, we want to have more things that are open source to have people run at home. And the problems that we're running into is that there's not enough data available, especially if you move beyond English. It gets there's almost nothing available. And so what I really want to see is just more data sets, more people that just once you have data sets, you can start building on top of it. You don't have to reinvent the whole wheel. So that's really what I like to see.
Is Abby here? No. Is William here? John?
Good morning, I'm John Stein, and currently providing leadership to what's known as the Open Voice Network. And just a quick word of thanks, Monica, James, for bringing people together and this opportunity. The Open Voice Network, what is it? Industry nonprofit, forming currently with support from major tech companies as well as consumer-facing enterprises, dedicated to complementing efforts like this, as well as accelerating, encouraging, supporting openness in voice, and certainly the growth of the developer community and the use of voice worldwide. And how will we do that? The focus will be on the exploration and pursuit of standards. We've talked about standards in this room, the Open Voice Network, that is our core mission. What will be those standards? What might we be exploring? We're in early days, and we certainly invite your support and participation. But on that list could be such things as a DNS for destinations, a voice name system. We could be exploring such issues as privacy, commercial and consumer, looking at such things as identification, authentication, looking at such things as privacy. And certainly, Jen, to many of you who are working in the ethical legal space, we've been asked by a number of organizations to be offering suggestions, support, to be exploring the ethical and legal issues that are surrounding all this. The Open Voice Network, launching, knock on wood, in weeks. I look forward to speaking with you, and again, Monica, James, thank you for the opportunity.
Is Faye here? Anybody with T, be prepared to come up.
Good morning, everyone. My name is Fei Cao. I'm from Uber AI Lab. Actually, in Uber, we are dedicated to improve the user experience for actually rider and the driver. Actually, that's why actually the conversation assistant is so important for us, because actually you can imagine that for the driver, we can provide some hands-free interfaces or interaction with the cell phone or machine, so that it can improve a lot of the safety. And also we can have some visual information to improve the security of the driving environment. And also for the rider, we also, as a customer myself, actually, I always feel actually it's more convenient for me to use voice to search for the information, especially for Alexa. Personally, I also use Alexa, Siri, and also Google Voice Search. I found it's way more convenient than just to type something, even though we have very smartphone, iPhone, or actually Firefly phone and the Android phone, but still actually voice control is way more convenient. That's why actually we would like to deploy the conversation assistants in our product. And I personally doing speech processing system, including a lot of recognition problems. I think actually speech is like a very front end compared with like the conversational dialogue manager, like those kind of stuff. And I also know a lot of people here doing like multimodal information stuff. We also know like text, visual. It's like the input signal is also very important for the whole ecosystem. When I say ecosystem, it's kind of like the assistant. So I hope people here we can talk to each other. We can try to push the whole community to a how to say a higher state of the art, so that we eventually can have a assistant like my dreaming assistant Jarvis. And I also would like to thank the organizer and thank you everyone.
Daniel, I just want to remind people, try to keep it 1 minute.
So, good morning, everyone. I work for Telefonica. We have an office here in Silicon Valley to look for companies and projects like this one that can be interesting for the telco business, to develop our business. Prior to that, I work in Aura, which is the virtual assistant in Telefonica, from Telefonica. So we created our own virtual assistant. We also created our own speaker with a screen, and we are expanding this vision to create experiences at home for our customers, right? So one of the challenges we find is like context, right? So in the home of our customers, there are several people, families, and they are talking. They can be talking, and we need to distinguish who is talking, which are the preferences of each person, and the home as a whole, right? So yeah, we are glad to be invited to collaborate in this project in Noble. So thank you.
Is Ken here?
Yep.
Great.
Hi, good morning, everyone. My name is Ken Tai. I lead the product team for Banco Santander Digital Group and responsible for building an open platform with the mission of inclusive banking, inclusive financial product and services, to the masses, to all the digital products. One of the key things I think are thinking about the online virtual assistants, really the lower the threshold. How do we actually onboard more customers and merchants to online banking solution products? It's not necessarily just the technology, but it's the interactions, and we're always looking for new ways of looking at different set of lowering that threshold. So looking forward to collaborate with everybody. Thank you.
Hi everyone, I'm Spark from TreeMicro. TreeMicro is a 30 years old cybersecurity company. So we are looking for virtual assistant to help us and also help our customer. And I lead some AI research in TreeMicro, and at the same time, I'm the father of triplets. So when Monica asked me, what is my dream virtual assistant? My dream virtual assistant is the digital triplets. One is me, one is a powerful version of me through the AI. Then the third one is a very naughty child. He always do something not me. So you know the triplet problem, that outside the house always confused which one is which. So maybe in this way, privacy is preserved. So thank you.
Hello, everyone. My name is Farhan Tura. I'm from Comcast. I'm part of the growing group Comcast Applied AI, which applies artificial intelligence to various verticals at Comcast, including digital home, media analytics, and content discovery. So I'm leading the natural language processing team under that, and my team builds the core engine behind a lot of Comcast products, including Xfinity Assistant and the voice remote. So for the Dream Assistant, I just wanted to add something different. I think we use our devices to stream content and entertainment quite a bit. So I think the virtual assistant should really help with this decision-making process that we go through, whether we're on the road or at home on the couch with our friends and family. And I think there's like two-way problem here. One is around the techniques, underlying techniques, and the other one is around the interface and the user experience that really needs to be good for this to be useful. So happy to be here and have the conversation. Thank you.
Okay, so U, V, and W people, come on up. Is George here?
Hi, I'm Xavi Uribe Echevarria, the founder and CEO of Sherpa.ai. Our goal is to build the most personal assistant, and we believe that the next generation of assistant will take into account your context, will be more personal and proactive, and that's what we are working on. And we also announced early this year a white label assistant platform, and we already have signed a few big agreements with big corporations. So we will announce them soon. So that's what we do. Thanks.
Is Arthur here?
Hi, everybody. My name is Doran Weber. I'm a Vice President Program Director at the Sloan Foundation. Unlike many of you, I have the luxury of giving money away, not having to make it, and luxury of asking, is what we're doing good for society? So in terms of technology, one of my programs, Universal Access to Knowledge, is making sure that the advances are used for the widest public benefit. Since about 2008, I've been I think nominally still the largest funder of Wikipedia, because I think Wikipedia embodies, what the dream of the World Wide Web, the Digital Public Library of America, which is an answer to Google Book Search, and now I'm working with Consumer Reports because I think the question of privacy is really a huge issue and one that we can't really ignore. Not only is there an unprecedented level of data being collected about each of us, but also inferences are made about us behind a black box that can really affect our future. And not only are they exacerbating inequities, but when you have the rise of authoritarianism, as we're seeing in the world, you have the potentially a perfect storm. So it's very troubling. What I think is exciting about what Monica is doing is that not only is it taking privacy as a central tenet, but it's also it's innovative, and for those of you here, you can actually make a lot of money doing things the right way. So I encourage you to go in that direction. Thank you.
So hi everyone, I'm Sly. I'm a PhD student in Monica's group, and I've been working on Almond for a little bit more than 3 years. So my dream assistant is what we are building right now. Of course, I'm now talking about Almond in its current state. I'm talking about in the future, Almond with all its potential fulfilled and with access to all the information and APIs. Of course, this cannot be done within our group, so we need collaborations from industry, from open source communities, and I hope my dream can come true. Thank you.
Hi everyone, I'm Jackie Young, and I'm a fourth-year PhD student working with James and Monica. And so my vision of the virtual assistant is, in the future, is that the virtual assistant should be able to use multiple modalities to acquire information about our context and then understand our intent using multimodal kind of a way. And so I've been working on AR and VR and also multimodal interaction for a little bit now. And I believe, like, especially in the AR and VR world, AR VR doesn't limit it. You have to have a glass on it. It could be like voice assist, like your smart speakers in some ways, like augmented reality, because you are interacting with your reality while talking to it. So yeah, I believe in those kind of scenarios, virtual assistant is kind of a first class citizen in terms of interaction. Like, because you don't want to like keep a keyboard with you everywhere you go, or like you don't necessarily want to look at your phone while you're interacting with the real world. So that's kind of what I envision, and I've been kind of working on it, on like technology and frameworks that support multimodal interaction while in the real world.
Hi everybody, my name is Chen Guangzhu. This is maybe the 20th time I'm last on the alphabetical list. Already used to that. So I'm a principal researcher in Microsoft Speech and Dialogue Research Group, same as Robert Chambers. Our group is responsible for all the speech-related APIs within Microsoft on Azure, and also the related natural language processing for the generated language. And my personal research is on NLU and also NLG, like task-oriented dialogue, which I'll talk about in the afternoon, text summarization and so on. Prior to this group, I was working in another product group in Microsoft on customer support virtual agent. And in the process, I feel it's very difficult to, and takes a lot of time to onboard a new customer. We spend a lot of effort like writing customer-specific scripts for that. And I hope in the future, and as soon as possible, we can have that process automated. Yeah, thank you.
Okay, that's everybody. But now we're about 30 minutes late, so we're gonna take a 15-minute break and come back at 11:35, and then we'll have a few short talks, and then we'll have lunch. I think there should be food out. If you go out the doors to the left here where there was food in the morning.
Just take the time. Just no questions. All right, let's get started on our next session. And this is a session of several talks on open source data, open source technology. And then we're going to start with Giovanni, whom you have heard from. And he's going to start with the toolkit of Almond.
Hello again, thank you for coming. I'm very excited to talk to you today about Almond, our open source collection of tools to build virtual assistant. And our goal is to support natural language programming. This is a framework in which every command gets translated into a formal programming language representation that makes use of APIs and skills in a library. And we care about natural language programming because it is powerful and it is useful. It allows you to connect multiple skills across different services. For example, I can say when I upload a new Instagram picture with a specific hashtag, post it on Twitter, and this in fact is one of the most popular skills on the if this then that website, connecting Instagram and Twitter. So why is natural language programming hard? We first of all need to design the skill library to support programming and interoperability. We then need to code information. And finally, most importantly, and perhaps least unexpectedly, is we need a lot of high-quality training data. So our presentation is called Thingpedia, an encyclopedia of things. And Thingpedia provides two things. It provides a uniform representation of APIs that, unlike the representation of APIs that are in Alexa or Google Assistant, which are mostly just intent dispatchers, we capture full signatures. We capture both the inputs and the outputs out of the APIs in static typing. And this enables us to have filters. It enables us to type-based filters, type-based composition or parameter passing. It also allows us to support interoperability as information from one API can flow into the next. In addition, Thingpedia stores natural language information. That is, it stores pairs of how you refer to a certain operation in natural language and the corresponding code. This is in form of annotations on the APIs, as well as templates that describe how operations are invoked. And I will go more into detail on the templates later. And our target language is ThingTalk. And here is the first construct of ThingTalk. This is when get do. It connects a when event, applies some filters to compute, optionally gets some extra data, and then executes an action. And we have chosen this construct because it is high level, it is useful, and it matches how our users want to specify this kind of very common, very useful commands. Not in particular compared to a regular programming language. It has no variables. Instead, you refer to names directly. It has no loops, and data is automatically iterated if necessary. And it has no if statements, which are replaced by conditions of the data in terms of filters. And given our ThingTalk language and our Thingpedia API, it might be straightforward to understand a command such as this one, get the latest KCD comic and post a picture on Twitter. But when we apply it in the real world, the user might give us all these different ways to express exactly the same command, and we want to map all of this to the same code. So how do we translate all tasks to natural language? Training data is hard, and it is expensive to acquire. It is extremely expensive, in particular for the natural language programming task, because our training data is pairs of sentence and the corresponding program. That is, the annotation has to be done by someone who is a programmer, who can write code, and is an expert in the domain. Instead, we propose to annotate only a small sample of evaluation data, that is, validation, dev data, and test data. And we can then build a training set that doesn't include any real data. This makes it cheap, because we only annotate small data, and it also avoids the privacy problem because we don't need to continuously collect data from our users. And the way we do so is through our Genie tool, our Genie parser generator, that takes as input the Thingpedia information, the signatures and the operation templates. It takes as input the target language we're trying to translate to, that is the ThingTalk language, and construct templates that define how the language is used, as well as parameter data sets. These are data sets of like people names, locations, song names, and so on that are used for entity recognition. And out comes a trained semantic parser. So going into more details, our operation templates are pairs of small snippet of language, the part of speech, there could be a noun, a verb, a when phrase, and the corresponding code. And the interesting thing to observe here is that the same function, say list folder, can be used in many different ways. I can say to list my files, or I can use it to monitor when I modify a file because the list changes, or when I create a file, there's a new file name. Further note that the same API can be referred both as a noun, such as the download URL of a certain file, or as a verb, just straight up download that file. And therefore, state-of-the-art technique that are based on associating a unique canonical form to each API or operation in the language are insufficient because they wouldn't capture the whole variety of the way people interact with these APIs. Our operation templates are then combined into constructs. And constructs or construct templates are, again, pairs of natural language that are now grammar, not just a snippet, and the corresponding code, where the code allows the program, the template designer, to define how to program the training set and define how these constructs are combined. So for example, I can say, when I upload a picture to Instagram, then post a picture to Twitter, or post a picture to Twitter when I upload a picture to Instagram, and both should be recognized. And so our pipeline starts from the information in Thingpedia, the APIs and the operation templates. We combine them with the construct templates. These are defined once and for all for the constructs we care to support by an expert, a programming language expert, a developer. And we combine operation and construct templates to synthesize a very large training set. A small portion of it is then paraphrased using crowdsourcing, using mTurk. And both paraphrases and synthesized data are combined, augmented with parameter data sets that allow us to recognize entities to produce the final training data. And note that, unlike previous state-of-the-art, we train with both paraphrases and synthesized data. Synthesized data helps with compositionality. It shows that a certain API can be composed with all other different APIs independently, whereas paraphrase gives you robustness. It actually exposes you to different ways to express a certain command and teaches you language, fundamentally. We can also use the paraphrase and inspect it to build new constructs, which allows us to enrich the value of the few workers to put really a lot of effort to come up with creative sentences. And then we turn them into construct, and we can synthesize more data. And given the training set, we can train our model, which is called the LUINET, Language User Interface Network. This is based on the off-the-shelf DEC-NLP, or multitask question answering network. This is a model that was shown to be effective across a number of NLP tasks, uses both BiLSTM and self-attention, so you get the best of both worlds. And we have augmented it with a language model on the decoder side, taking advantage of the fact that we can easily generate a lot of programs because our programs are formal, and we can pre-train that part of the network. And moving on to our first experimental result, the first experiment is on this kind of when, get, do sentences. These are sentences that use one or two skills and at most two filters. And we ran our experiment out of what was the whole Thingpedia at the time, 44 skills and 131 APIs in American English. And we don't optimize on any skill specifically. We collect 1.3 million sentences with synthesis. We crowdsource about 1% of it, 24,000. That turns out to be $8,000. And after augmentation and training set is 3.6 million. For evaluation, we both crowdsource data from mTurk that we then annotate manually, and we use data from the if, this, then that. This is data that we have no control over, and therefore is the most representative. As an aside, state-of-the-art previously would say test on paraphrase data. This, you should not do that, because in our experience, you can get near perfect accuracy on paraphrases, and then you deploy in the real world and the model fails miserably. And so we have split our evaluation data and a validation set that we use to refine our templates and build a better training set, and a test set that gives a final accuracy number. And without further ado, the result is that Genie improves over the previous state-of-the-art significantly. We can achieve an accuracy of 68% on the validation set, 62% on the test set. And again, note that there was no real data in the training set. This is all trained on synthesize and paraphrase and tested on real data. Furthermore, we did not optimize specifically on any skill. We just did 44 all at once with few students worth of effort. As a case study, we then put a few man days of effort on Spotify, and we can see that we can increase their accuracy all the way up to 80%. This shows that a domain expert that cares about can actually use this mechanism to improve the accuracy of their own skill. Furthermore, we applied Genie to an extension of the formal language. We added min, max, count, aggregation operators to the language. And again, we find an accuracy around 60%. This shows that our models are extensible, and we can grow both the capabilities of the formal language and the ThinkPedia collaboratively. And to put this into practice, and not just AI, we have also built a comprehensive virtual assistant engine. This provides dialogue management, skill configuration, and credential storage, as well as useful background services that most virtual assistants will need, like notifications, reminders, automations, and so on. And we have integrated with the best-in-class open source for input and output. We have used the Mycroft for voice, for hot word activation and text-to-speech. We use Microsoft Cloud for speech-to-text. We have integrated with the bot framework to give us access to Slack and a Messenger. And a member of our community actually built our integration with WhatsApp. Furthermore, we have shown that we can put this engine in Alexa and either use the native Alexa AI and just do whatever Amazon will do for you, or use our own AI and access our capabilities. And our engine runs on, we have a Linux version that runs on the cloud or runs locally on your computer or on your home server. The computer is how I run it. Or we have an Android version that runs on your phone, and in that case, all your credentials, all your API interactions happen directly from your phone. And so this completes our picture. You can see the Almond has grown a little umbrella because it's an umbrella for all these projects. We have shown the ThingTalk programming language, the Genie parser generator that allows domain experts to build their language capabilities. And we have shown ThinkPedia, our representation that enables this extensibility, and a LuiNet semantic parser, and finally the Almond engine. All of this is open source. All of this is modular. You can take any part of it, use it in your product, in your assistant, in your bot, any of it. And so our hope is that if you put your skill in ThinkPedia, we will be able to access immediately all these existing assistants. Furthermore, because we have our own AI, you will be able to access Almond, the privacy-preserving virtual assistant. And because Almond is open source, we will be able to put it on websites, app, phone services, or anywhere you need a natural language interface. And my belief is that open source and open standard will win over walled gardens. Thank you. Do we have time for questions? Maybe one.
tend to iterate, or sort of choosing between different skills to iterate, the graphs that you showed?
It's yeah, so our evaluation metric, because we are programming, is program accuracy. We want to match exactly the target sentence. So all the parameters, all the filters, all the skills, everything has to be matched. We do, in our paper, have error analysis in terms of getting the skills right, getting whether it's a 1 or 2 element skill and so on, but we care about getting everything right at once.
So on the programming language that you're using, have you compared that with just using Sparkle? And what are the strengths and weaknesses of what you guys are doing versus that?
We don't have direct quantitative evaluation, but we have our experience. In our paper, we discussed you need to follow certain design principles when you choose the target language. And a few of them I try to cover, including choosing a construct that matches the input sentence as much as possible. Because if there is a lot of change that has to happen in the neural network, it will be harder. You also need static typing and like an API, like a schema defined ahead of time, which in a graph database might be harder to obtain. You need canonicalizability, so you need a unique form for every program, for every semantic of the program, which kills out everything Turing complete, kills out Python, kills out SQL as it happens. So that's why we needed to design our own language.
The accuracy numbers, even though in general it seems like 60%, I wouldn't want to go to the doctor with 60% accuracy. But you're saying get every parameter right. So I'm hearing there's a shiny side of that, which is I bet you have high certainty of whether you know the query or not. Is that correct? So if someone could call you as a service and say, do you know this query? How much confidence could you return that you know the query and you got it right?
It's actually, unfortunately, the opposite. Because it is a generation problem, it's not. So in the classification world, people have done a lot to measure confidence, to measure auto-distribution, to bring these confidence scores to actually realistic values. In the generation, confidence tends to accumulate because you still have a language model at the end of the day. The language model, your confidence are driven by whether you're getting the grammar and the type right. And so it's kind of hard, and so it has basically 3 failure mode of operation. Either gets the right thing perfectly, it gets you something completely wrong, or it gets you nothing.
If you compare it with a lot of existing commands where they are just simple commands, then the accuracy is different. This is a lot of the compound commands with filters and so forth.
It seems like you would know like whether you covered the query or not. I mean, like you got a bunch of words here, and you got a bunch of parameters, and you laid them out, like you say it's a complex command. Normally you don't know. Normally if you just use a fuzzy probabilistic matching thing, you have no idea whether you got
Actually,
it right.
the direction that we are going is that we assume people will be breaking up their commands into pieces. All right, so there will be more like you say one thing that is easier to understand, and then you say the next thing. And the fact that we learn compositionality allows us to get to dialogues next. And I think that that's the better way to actually use this technology. But having a formal representation is really useful. I think that that's what we are trying to show. And you can even get to the 60-some% for these compounds with just a few students' effort.
Right, I think I might have to.
Yes, I think well, thank you very much. Our next speaker is Paulus, CEO of Home Assistant. And we've been working actively with Paulus, and looking forward to the talk.
I think CEO is a big word. We're an open source project. Founder, I like the word more. Let's see. Let me see if I can get my speaker notes on here. Where is display? There you go. Where are the... Oh. Okay. It's better. And of course, this is gonna completely ruin my live demo, but that's okay. Awesome. All right, so hello. Like I said, my name is Paulus Schoutsen. I'm the founder of Home Assistant, and Home Assistant is the world's biggest open source home automation platform. It's around 6 years old. And the goal of Home Assistant is to create an open platform that puts local control and privacy first. It runs on low-powered machines that people can acquire. Like, for example, one of the main things people start with is like a $35 Raspberry Pi. You combine this with software that is free to download, and it's very easy to get started with Home Assistant. Home Assistant itself is like a Python application, but we have built like a small operating system around it that you can put on a Raspberry Pi, and it actually turns your Raspberry Pi into a full home automation hub. This allows users easily to stay up to date and stay secure. And with Home Assistant, we don't just actually target the United States and Europe, right? We're global, it's open source. And so we also made sure that we run everywhere in the world. And that is especially that, a lot of people use phones, but the quality and the speed of phones across the globe is not as fast as we are used to, especially in something like here, like Silicon Valley. So we actually made sure that Home Assistant runs great on budget Android phones. We also made sure that our user interface is fully translatable, and we have support for 54 different languages in our UI, including right to left languages like Hebrew or Farsi. And this has made us very popular, right? We don't have a lot of metrics just because we're privacy focused. But if you look on for example, something like Docker Hub, our images have been downloaded 10 million times. And so Home Assistant is the community, and the community is Home Assistant, right? There's no investors, right? The only thing we care about is users. And so at the end, we're a group of people. We're building technology that we want to use ourselves. Oh. We're building technology that we ourselves want to run in our own homes, right? And at this moment, we're doing a release around every 3 weeks, and we have around 85 people actively contributing code to each release. So this is kind of how Home Assistant looks, right? It's an interface. You can put it on your phone. You can put it on big screens. It's responsive. It will scale down. It will scale up. And Home Assistant is built around 3 things. It's observe, control, and automate. Observe. We want to make sure that we know what's going on in your house. What is the temperature? Is the door open? Control. We want to be able to say, control the thermostat, control the lights, control the switches. And the third is automation. And automation is just a rule engine where the observations are the input and the control is the output. But to be able to observe and control things, we are the controller, but we are not we don't make hardware, right? We integrate with different APIs. And so we call these things integrations is when we integrate an API into Home Assistant. And we have around 1,500 different APIs integrated into Home Assistant. This ranges from things like the Ecobee thermostat, Philips Hue lights, home automation protocols that cover a wide range of devices like Zigbee and Z-Wave, and also low-level things like MQTT or Arduino I/O pins. There's really no limit on what is possible. And most of these integrations, and this is what really makes us different from all these commercial solutions, are actually maintained by the community. And this means that a developer starts using Home Assistant, maybe 7 out of the 8 things are supported, and he will add support for that 8th thing. Or maybe he starts using something, finds a bug, someone else reports a bug, and slowly we're creating very solid integrations that has very good support for the APIs of the devices. And it's great because by doing this, we're actually showing companies that we care, that we want to control our own stuff. So for example, at some point we had an integration that was using an API that we observed from an Android application. And the company realized this, and then all of a sudden was hey, people want this, and they actually built an open API that allowed us to better integrate. And earlier I mentioned that we're global, we're around the world, and it also means that we support APIs that are from everywhere, right? So, we have support for DeepStack, which is an AI platform from Nigeria. We integrate with IoT products from New Zealand or India, you name it. So yeah, let's kind of quickly summarize like what Home Assistant is about, right? So Home Assistant is open source. Home Assistant available worldwide. We do everything local. Like the cloud is optional. If there's no internet, Home Assistant still runs. We store all the data local. We prefer local control. We will talk to the cloud, but then we just pull that data local as soon as possible, and that's where everything is processed. And we have a very layered, extensible architecture, so that every piece in Home Assistant you can swap out for your own, you can customize, you can build on different parts of it. And then the other thing is that we have very extended documentation on how our API is structured, how you can access it, and we have great ways for local applications to get authentication and actually access this data. Right? So what does this lead to? So you get very affordable home automation, $35 or an existing computer, you're up and running. We get very fast home automation, because this is local, right? You don't have to go through a cloud, your motion is sensed, it's locally, we can control the light, locally. It's reliable, because there's less hops, there's less that can break. It is secure, your data never leaves your home. It's very customizable. We made sure that everything in the interface, you can swap it out. And this is what we think is very important, because not a single person is the same, not a single culture is the same, not a single language is the same, right? We want people to be able to build user interfaces at the layer in Home Assistant that they want, or maybe throw away our UI, build their own UI that is meant, that better fits their household, right? And the last thing is, we are a foundation for other projects. We have solved this home automation thing. We know about the data that's at home, and we allow you to control things at your home. And by being open, we allow other projects that want to build something with smart home data to just use that data. They don't have to reinvent the whole wheel. They don't have to build all their own 1,500 integrations to get started. And this is kind of where Almond comes in, right? Because Almond reached out to us recently, and they were like, "Hey, let's talk." I was looking at their website, and it's we're open, we're privacy focused. I'm like, that's us. But we only really focus on the smart home. We don't have the assistant, we don't have the natural language processing, all these things. So this was a perfect match. And so we started our teams teamed up and we started hacking together. We built an integration both ways. So the first thing that we did is that we added Home Assistant support to Almond. So anywhere where you are running Almond, and like Giovanni said, you can run it on your phone, you can run it at home, you can run it anywhere you want, you will now be able to control lights or any other device. But then, of course, for Home Assistant users, that's not useful, because then they need another app, and they kind of want to have everything at once. So we also added support to Home Assistant to directly, inside Home Assistant, talk to Almond. And so now I'm going to do a live demo, which we'll see if that's going to work. Hmm? You want me to press buttons? Let me see. This is. Oh, I need to. Can I just? There you go. Okay. So for this demo, I'm going to just open two Home Assistant UIs. And the reason for that is that once I'm opening Almond on here, it's like an overlay, and so you're not going to be able to see what's happening. So I put the left screen. It's in sync. Everything in the Home Assistant is always streaming, so everything's always in sync. As you can see, something changes, it's immediate. So the first test always, when I'm testing Almond, if it works, is to ask for a joke. So let me see. I don't have audio output. Well, that's okay. We don't need audio. Okay. That's okay. It's on the screen as well. Tell a joke. All right, that works. That's great. So now, of course, you also want to control Home Assistant, right? So turn on the lights. Ta-da. Okay, that worked. That was great. So what's happening here, this is actually running in Chrome. So Google offers for websites integration with Google speech-to-text and text-to-speech. So we can just leverage that. But of course, that's not the great way to expose Almond, right? Because then you have to open your app, open the UI, and you can actually already just touch the buttons that you want to touch. So we have some ideas around that. But the first thing is what we want to do is that we want to improve Almond. Because right now, the way we do things in open source is that we build out the foundational, like the backbone of like these integrations, and then the different like devices or different like utterances and the skills, we leave that to our open source contributors. Because these are like small tasks that people can pick up in the weekend. And so one of the things is that Home Assistant supports a lot of different things. And this is like a bunch of the things that we support. And these things are not yet supported in Almond. So one of the things that we want to do is that we want to make sure Almond knows about them, knows which piece of information these devices have, and be able to know which controls these devices have. So for example, a light, you want to be able to say, can I turn on and off? But you want to change the color, the brightness, the light temperature, right? It gets complicated very fast. The other thing that we're going to do for Home Assistant is that we're going to, right now, I have Almond Server running on my computer. But that's not very convenient. That's not what I can ask my users, like, oh, just install this server and then like you can connect it all up. So what we're going to do is that we're going to make a way that users will be able to press a single button. It will install Almond. It will configure Home Assistant to talk to Almond, and it will configure Almond to talk to Home Assistant, all with like a single button click. That way our users will be able to get started very fast. However, like I said, that's UI. That's like a good step, but we want to do it better. So then we were thinking is like, you know, what is a voice assistant, right? Like when we talk about like speech to text, it kind of basically boils down to this. You detect a hot word, you start throwing speech to text, then you try to get the intention of this text, then you do something with that intention, and then you speak the response back to the user. And so we are like building a voice assistant, a generic voice assistant add-on for Home Assistant. So what does this mean? So we're just gonna plug in pieces of technology. So for hot word, we're just gonna go off with Snowboy for now, because there's no good open source hot word available that runs on a Raspberry Pi. We're gonna do speech to text, conversation is gonna be by Almond, and text to speech. And this text to speech and speech to text, these are all integrations in Home Assistant. So people will be able to plug in different things, people will be able to experiment, and this will allow to like kind of like plug and play your own assistant. And as long as it will, you know, we will make sure that it works out of the box. So the idea is that like you'll be able to install Home Assistant, plug in a speaker and a microphone into your Raspberry Pi, and have your own voice assistant. And this too is actually something we're going to launch in like 3 weeks. So that's Home Assistant. Thank you. Are there any questions? Yeah.
Quick question. Can you already run the Almond parts on the Raspberry Pi?
Yeah, so that's a good question. So right now we run the Almond server on the Raspberry Pi, but the Almond server will still communicate with the Genie cloud, I think it's called, Giovanni?
Yeah, the inference side of Genie.
Yeah, so the way Almond works is that the text to ThingSpeak will happen in the cloud, and the execution of the ThingSpeak with the connected accounts will actually happen locally. So right now, what our first version is that will just send it to the Almond server to just convert it to ThingSpeak, and the ThingSpeak will be executed locally. Yes?
So is the iPhone, is it accessible for the iPhone yet, or do we need to wait until so you've got it on Android?
Right now, Home Assistant is a web application. So you can run it on your iPhone. We also have a native iPhone application to integrate with Home Assistant. The biggest downside is that like the systems are pretty locked down on Android and iPhone, so we couldn't do like a hot word detection that routes through us, right? It will end up in Siri or Google Assistant. But if you want to have your iPhone open it up and control your house, that's totally possible.
I meant the Almond voice assist.
Ah, okay. Oh no. So you can talk to you can just type to the voice assistant through your iPhone, but you will not be able to speak. Yes.
So considering you're processing so much locally, I'm really curious. Basically, are there really notable differences in performance in the usability based upon the hardware utilized? Is the smartphone really offering any discernible difference than a high-end desktop?
I think so. The reason why it's pretty easy to run home automation at home is that there's not that much data at home going on, right? Like, how often do you open a door? How often, there's sensors, they will generate a lot of data, right? The real powerful, things that consume a lot of resources is if we start dealing with video, right? If you're gonna do either just video streaming, if we start doing machine learning on video, like object detection, these kind of things, that's where we start running into limitations of hardware, and that's why I see that the users that do that with Home Assistant, they actually upgrade. They no longer use a Raspberry Pi. They will have servers running. And nowadays there's these Coral sticks from Google that they can offload a lot of machine learning, and actually those work pretty well as well with Raspberry Pi still, but it's a little bit more complicated to set up. Yes.
Do you see a world where your Home Assist can plug into something like Comcast or AT&T or one of these larger home security systems?
I think, in the end, if there's an API, either public or at least accessible, we can plug into it. And generally, these things happen is people will have these systems and then they're like, I want to use this. The odds, however, that somebody would pay for Comcast and for Home Assistant and then make that bridge is probably pretty small. The biggest challenge that is actually in the IoT space is that there's no standard. Right, I know the Mozilla guys have been really working hard on the Web of Things standard, but adoption is not really there. The bigger players don't really care. If you look at the Google, the Amazon, they build their own standard, and we just have to send them all our data, and that's not something that really works for us. Cool, thank you.
Thank you. Our next speaker is Celesio, and he will be talking about the queries with natural language, the queries on web.
Okay, hello everyone. So we know question answering is one of the most common uses in virtual assistants. So in this talk, I'm going to talk about how Almond can answer complex queries on the structured web. So I believe people in this room are all very excited about how virtual assistants have been growing in the last couple of years. And just last month, Alexa announced they reached the 100,000 skills milestone, which is really impressive. But still, this is only a tiny portion of the data out there in the web. In comparison, there are 1.7 billion websites, so we still have a long way to go. And further, with a much more flexible user interface, linguistic user interface, virtual assistants need to be able to answer all kinds of questions from users. And sometimes these questions can be complicated. For example, it's totally natural for me to ask, what is the top-rated Chinese restaurant in Palo Alto? But such a simple question, in fact, involves 3 different properties and computation on top. So how can we build a QA system that can scale up to the level of the number of websites, and at the same time handle the complexity here, complexity in questions like the examples here. So we present our toolkit called Schema to QA. It can generate QA system for all websites as long as they use schema.org, and it can answer questions, complex questions with multiple properties and computation. And last but not least, it is cost effective. So we can do all domains in schema.org automatically, and developer can put in a small amount of manual effort to improve the performance in each domain. So in our experiment, we reached about 75% of accuracy with just 1 man-week of effort for one domain without any real data. So how can we do that? And as have been introduced multiple times, we use natural language programming. So we turn each question into a ThingTalk program. So we don't rely on the actual information on the website when we parse in the natural language. And then we just run the ThingTalk program to query the website directly. So now let's first take a look at how we can use ThingTalk to represent complex questions. So in its most basic form, a ThingTalk query comes with a table and filters. So for example, we can filter on the restaurant table on the property serves cuisine. So this will give me Chinese restaurants. And we can put on more filters. For example, I can limit location to be only in Palo Alto by filter on geo. And we also support sorting. So I can sort, for example, I can sort on the ratings. So this will give me the top rated Chinese restaurant in Palo Alto. And we also have support for joins. For example, I can join the restaurant table with the review table. So this will give me a restaurant reviewed by Bob only. And on top of that, ThingTalk also have support for projections. So users can get the particular property they care about. We also have support for aggregations, so we can calculate the min, max count of different properties. And there's so many more. So this shows that we can use ThingTalk to represent the questions. But where can we get the data? So as we said, we use schema.org. So schema.org is a way to store structured data on web pages. And it's mainly used for search engines nowadays. And it covers a lot of domains already, from restaurants, hotels, to recipes, products, news, and so many more. And here's an example. We grabbed it from Yelp. This is information for the French Laundry restaurant. It contains the information of the restaurant, including the name, the cuisine, the rating values, and so on. And most importantly, there are already 40% of the websites using schema.org. So it will be great if you can use schema.org to retrieve information. But schema.org is designed for machine, not for human. So we need to somehow map schema.org to natural language. So we have developed a tool to automatically translate schema.org into our Simpedia representation along with all the natural language annotations for each property and operation templates. Due to time limit, I'm going to introduce one component in this tool. So as you can imagine, one of the most important and challenging tasks is to understand how each property can be referred in natural language, and they vary very differently between different properties. For example, let's look at two properties in restaurants, serves cuisine and rating value. So probably the most common way we refer to cuisine of a restaurant is just by its value. We'll just say Chinese restaurant without mentioning the word served or cuisine at all in the sentence. The fact Chinese is a cuisine is just implicit. But this won't work for rating value. If we only use the value, we'll generate something like 4.5 restaurant, which doesn't make sense at all. So as you can see here, there are a lot of ways we can combine the value, the property name, and the restaurant together in natural language, but they just won't work for every property. So to solve this problem, we use the actual data in the website. We collect a sample of the value for each property, and we generate a lot of combinations of the value and the property name and the class name. And then some of these candidates are bad, some of them good, but it's okay. We throw all of them into a search engine, and we rank by the number of exact matches. In this way, we learn which combinations are more common to use in real life. And then we can pick the top ones as our operation templates. So in this way, we can generate very reasonable operation templates for our Simpedia representation. And we also allow developers to further fine-tune the templates manually to improve the performance. So at the end, we're able to translate the entire schema.org into our Simpedia representation, along with all the natural language part. So now, by leveraging the abstract schemas in schema.org, we're able to have access to 40% of the websites. But note that due to the time limit and the resource limit, we only crawl data for 3 domains. So the search engine approach will only apply to these 3 domains. So now we have the Simpedia, which gives us the function signature, the natural language annotations, the operation templates. We can now use Genie to generate a large training set to train LuiNet. So now we can finally finish this diagram, beautiful diagram of natural language programming to turn the questions into ThingTalk. So now let's move on to see how the system actually performs in real world. So we first test on 2 domains, restaurant and person. Restaurant, we use data from Yelp, and person, we use data from LinkedIn. And using Genie, we generate a training set of 1.8 million sentences for restaurant and 900,000 sentences for person. And for evaluation, we collected another set of more realistic data. We went to Mechanical Turk and give Turkers a list of properties they can use and just ask them to come up with whatever questions they want. So this is as realistic as it can get. And one interesting thing we noticed is that we only ask for questions with 1 property or 2 properties. But however, in restaurant domain, we still get a lot of questions involve more than 3 properties. This is probably because some of the questions are just too natural, and the Turkers themselves didn't even realize that they're using so many properties. So let's take a look at the result. So overall, we get 74% for restaurants and 78% for person. And on the questions with only 1 property, we're able to get 80% for both domains. And for questions with 2 properties, we still be able to get over 70% for both domains. And I think most impressive thing here is that for questions with 3 or more properties involved, we can still get 65%. And keep in mind, all these numbers are trained without any real data. So this provides a very strong baseline for QA systems. And this high accuracy benefits a lot from our templates. So we have a very comprehensive template set in our Genie and in our ThinkPedia representation. So in fact, if we train only on synthetic data, we still be able to get like between around 40 to 50% of accuracy in these 2 domains. And in comparison, if we use the templates in previous work, Sempra, and only training only on synthetic data, the performance will be really poor. And we also explore that how the knowledge can be transferred across domains. So we did experiments on transferring knowledge from restaurant hotels because they share a lot of properties. And we put 0 manual effort to the hotel domain. We accept the evaluation data. We collect the same hard, realistic evaluation data manually. And we didn't even do paraphrase. We used a script to transfer the paraphrase data in the restaurant domain into the hotel domain automatically. And yet, we still get 55% overall accuracy on hotel questions. And if we only count questions using the shared properties, we get 63% of accuracy. So this means that the knowledge we learn from one domain can be easily transferred to similar domains. And last, we also integrate the schema to QA in our Almond Assistant, of course. So these are 2 screenshots we captured just to show it works from end to end. So in conclusion, we present our toolkit schema to QA. It can scale by mapping schema.org to natural language, and it can handle complex questions, and it is cost effective. So every company, websites can use our tool to build a QA system themselves. Thank you.
So using the exact match is a very interesting idea on the web search engine. So my question is, why don't you use a language model? So a very simple in-graph can also tell whether this.
Right. We actually thought about it, and we want to implement it in the future. It's in our roadmap. Yes. Yes.
So in terms of generating the natural language description of the program, so you use the web, and you mentioned that you were able to map the entire schema.org to the natural language side.
Yes.
So, but I wonder, so I think the schema should contain a lot of long-tail entities that doesn't occur very frequently on the web. So did you have any problem collecting descriptions for this?
So for the experiment we did for the 3 domains, we trimmed down the ThinkPedia representation to only the data we have, only the data we crawled from the web. But we are able to generate the entire schema.org, but the quality might be not as good once we have the data. So, but that's fine. But because if you don't have the data, it's not meaningful to generate the question anyways. It won't give you anything. So we assume that the data is always available in our setting. So if people apply our tool, they will have the data to refine the natural language annotations and operation templates. Yes.
I just have a quick question. So with our implementation, the W3C Web of Things is not standardized yet. There's an approach to use like iot.schema.org for these JSON descriptions, but it's not far from complete. However, the Web of Things description in the JSON does have these links, you know, so Mozilla's implementation of everything our gateway can handle could be, you know, pulled in and parsed. And if you have that data, then you get over the problem like Paulus mentioned, where all the manufacturers of the devices don't actually, you know, make things easy to integrate. We have to like transform all of them into a standard rather than every light bulb having common, you know, characteristics. So if you had that smaller data set of like an iot.schema.org, could you run it all in, as part of this, you know, just the way you've done this standard schema.org framework?
Yeah, it's definitely true, yes. So, I mean, it's both the IoT, the Home Assistant abstraction, and schema abstraction give us the ability to like map to a smaller basic abstractions to be able to handle a lot of more devices and web pages. So I can definitely see that happening if we have that in schema.org.
Yeah, because ours is all exposed with one web thing API. We hide all of the brand specific
Right,
stuff.
right, definitely. Yes.
So what is it going to take to increase the accuracy?
So here everything's automatic. The part that we find increased accuracy most importantly is the natural language annotations for each property. For example, we have a lot of heuristic and algorithm to generate them, but still sometimes it's not accurate, not complete enough. So for example, serves to say, for example, rating value. When we refer it to in natural language, normally we'll use the word star, a 4-star restaurant or something like that. But we cannot generate that from nowhere because that information is not in any form in the schema.org. So by manually putting those information will give us a boost in natural language translation.
Thank you very much. All right, next we have Alex, and he's going to talk about Snorkel. And he introduced
Great. Let me plug in. I think this is the most terrified of an audience I've been recently because I'm quite hungry, and I'm assuming everyone else is quite hangry. So I'm going to try to comply with some time constraints. Let's see. Cool. Okay. So let's see. I'm going to go through kind of quickly, and so I'm mostly talking about I'm entirely talking about the open source and academic Snorkel project that we've worked on for about 4 years out of Chris Ray's lab here at Stanford, and through my PhD work as well as that of many of my former lab mates and current coworkers. So I'm going to give just a very high-level overview, and there's a lot more that we actually just did a release in August, right after a workshop we had at Stanford of the V0.9 with a bunch of new tutorials and stuff like that. So you can go there for more. Or talk to me over lunch. Once you've taken your first bite, I'll answer theory questions. Okay. So I'll start with the motivation, and again, this is going to be somewhat high level, and we've worked on all sorts of applications. A lot of this stuff actually has been deployed, or sort of versions of this system, I'll say, have been deployed in actual production virtual assistant systems out in industry. But broadly, I'm going to talk about how do we train a classifier or some kind of machine learning model. You can imagine mapping a classifier to what's the intent, or what device is the user asking about, or something like this. But I'm just going to stay very high level. So a lot of our motivation, this is not an exclusive statement, but it's based on our observations over the last 4 years, is that machine learning development, if you think of this BuzzFeed supervised setting as having kind of 3 basic ingredients at a high level, you have training data, you have some kind of machine learning model, you have a model class or a model architecture that you need to tune on that data, and then you have some kind of hardware to do that training and serving. And it used to be, certainly when I entered grad school here, that if you just built a model for one particular type of X-ray or type of natural language task or one type of hardware, algorithmic implementation, still quite an accomplishment, but that would be, like several PhDs worth of work possibly. And now for a lot of tasks, we can actually just take, robustly supported open source components for the models, and there are lots of, other platforms for the hardware, and get these things running at least to a first approximation on traditionally grand challenge tasks like text, natural language, image, etc., in like several lines of Python. You can guess my punchline. This is all predicated on the, on having a training data set for the particular task. So, we've seen a lot of use cases and kind of see training data as one of the, in the negative phrasing, the key bottleneck in ML dev today. And the positive phrasing, the kind of differentiator that decides whether, and how well an application works. So I'll just give one example that I can share openly from a radiology project that we have ongoing. I think it's on its like seventh submission right now, but it's kind of at this intersectional niche of systems and radiologists. So it's still going out there. But the numbers were kind of staggering in that we looked at basically how much variance we got in an end performance metric. This is ROC AUC on a binary triage task at the over 4 radiology and neurology data sets of the Stanford hospital system. Just a classification problem. Basic point was that it took a couple days to try everything from an AlexNet to a DenseNet, ResNet, sort of 7 years of deep learning image model progress. About a point of difference in ROC AUC. Whereas it took about 8 person months of a Stanford radiologist's or a team of Stanford radiologists' time to actually label a training set. And if you look at the curves, you look at the differential from, say, a couple weeks to a couple of months of training data, so the volume, you look at the noise level of the training set. I'll get more into that. And you look at the data augmentation strategies used, which was mentioned earlier, all about an order of magnitude larger effect on the end performance. So this is just a caricature of many settings we see where this is the lever that ML engineers actually want to be playing with. Not that it has to be an either or, but this is the kind of differentiator. Either way, it's the one that we're excited about. So just to highlight this, labeling training data sets by hand is fine if it's cats versus dogs or if it's stop signs if you're doing AV or some settings maybe for general natural language understanding. But for many settings, it's very expensive when you need to have domain experts actually do the labeling. It's very difficult when you have privacy constraints, right? We work with many people, both academic side and through other routes, where you can't ship data out to be labeled on the government or medical or tech side. And finally, every time you enter a new setting, so your input data changes or your output goals change, what you want the model to do, you often just have to relabel the training set, right? And I can get into that with some case studies. The key idea that we've pursued for the last 4 years and are still working on along with a lot of others in the community is trying to build and manage training data programmatically. Or rather, from the perspective of us as system builders, we're trying to build a platform, Snorkel, that enables people to build and manage training data sets and thereby kind of program machine learning models programmatically using higher level heuristics. So just to situate, the goal has always been not to kick the human out of the loop, but to let the human interface at a higher level rather than labeling individual data points, writing heuristics, putting in their domain expert knowledge in higher level ways. Okay, so I'll give a concrete example. Just to start, this is just a canonical one of machine learning, a classic binary classification example. I actually don't know enough about home, loans to know on my own whether this is spam or not. So I guess I would have been a nice mark, but apparently this is spam. Our goal is to put into a model, and model just says spam or ham, yes or no. It's classic machine learning application. So the high-level question or one of them that motivated us, phrased another way, is, why is hand labeling the only interface to much of the machine learning stack? Right? I have domain expertise. For example, if I think that the phrase money might be highly correlated with a spam email, I may have what we often in a recent paper with Google called organizational knowledge which could be on the open source, on the web, or it could be inside your organization. I might have a list of drug names, and I know that if it matches that list, that's a good sign. It's often called at a high level distance supervision. I might have a legacy model. That's not good enough for various reasons, but I think that if it labels something as spam, that's indicative. But all of this kind of gets thrown out. Instead, we just pay people to individually label data points. So in the idea in Snorkel, and these are just different components of a current deployment version that we're building, but the high-level point is in all these papers and in the open source repo. We want to kind of go through 3 main steps. The first is that we try and let users directly express knowledge as functions. So there are actually a bunch of operators, but labeling functions is the first one. Training data needs to be labeled for a classification task. So rather than having this just come through in yes/no labels, we let them write what we call labeling functions. So this one is a simple one. Just says taking a data point, if money is in the body, labeled as spam, else abstain. And you can think of different ways of doing this. We have GUIs that we build for certain deployments. You can just write Python in the open source. We've done a recent paper we did directly from natural language to labeling functions to then training a model, a system called BabbleLabel that was presented at ACL by my lab mate. Either way, all of these different sources of labels come in, and then a lot of the work that we did over the years, especially on the theory side, was figuring out how can we combine all of these noisy sources. So you write 20 labeling functions, and any data point is labeled by a couple of them, and they disagree, and they may be correlated or have different levels of accuracy on different subsets or partitions of the data. How can you automatically learn where to trust the different label sources and how to not double count them if they're correlated? And so we've done a lot of work on doing that in an unsupervised or sort of latent variable modeling fashion over the years. I am way too happy to talk about that later. Ask someone about their PhD thesis at your own risk. But anyway, and then done a lot around the data management aspect of this. Is if your training data is being generated programmatically, there's a whole bunch of new things you can do around managing, monitoring, versioning, and serving it. And the final goal, in general, is to then use this programmatically labeled data to train some machine learning model. A question that is a natural one to ask is, why do you even train the model if you have a bunch of functions that label data? It's a good question to ask, and the answer should ultimately be answered empirically, which we try to make easy to do in the open source code. But the basic answer is usually the machine learning models of today are quite good at generalizing either to more features or to new feature sets. So you can write labeling functions over, say, the text of a radiology report, but train an image classifier that can now recognize the incoming image without the text. Or you can write a bunch of these rules over natural language and have the machine learning model automatically generalize to synonymous phrasings or terms. And what are the advantages of this kind of programmatic labeling approach? And I'll just say this quite openly of, not Snorkel versus others, but just sort of weak supervision in general is the usual umbrella term that's, of where this work has fallen. Well, first of all, you can, get training data much more quickly. You can dump in signals from across an organization. Again, that could be, dictionaries and models found on the internet or inside your org. You can do eyes-off labeling to a large extent. You can usually need to look at some data to write these labeling functions, otherwise like flying blind. But then the majority of your data set can be labeled by a program rather than by a human. So we can drastically reduce the number of eyes that need to go on data points. And if your ML model is not instantly perfect after it comes down from the deep learning heavens, then you can actually go back and iteratively tweak your training set until, especially on, we've done work on specific slices of data to actually get it to work, especially as conditions change. So I'll just breeze through. I'm actually going to skip some of these. So these are all published. Google was an interesting one because I think there's upwards of 25 deployments that at least I'm aware of now. But we started with 3, and a lot of the motivation here was that there's actually a lot of budget for labeling training data, but because of privacy expertise and most of all adversarial nature of the problems, where it changed a lot, they were having to relabel all the time. So it was actually even for them a pain point. Recently presented about an Intel deployment, the Stanford hospital I mentioned. I'll just show one result here, which is kind of cool. This is an RSC AUC curve. So up and to the left is better of just this is a triaging application. So this is just taking in, say, a chest x-ray and just saying, should this be bumped to the front of the queue to be read by a radiologist? No replacing radiologists in the problems we work on. Or can this sit in the back of the queue? Urgent or not, a triaging problem. So this is the line after person months of hand labeling. This is a recent paper that was published by a collaborator after person years of labeling at Stanford. Then we had an interventional radiology fellow at Stanford Hospital write about 20 labeling functions, and that took him a couple days, and this was the ROC-AUC curve there. So a brief note on this. From one perspective, this is kind of an eye-popping result. Months, nearly years, going to days. If you look at how we did it, it's actually fairly low-hanging fruit. A lot of the images had these messy text records. We wrote these labeling functions over the text records, got noisy labels that Snorkel used, rather than having a radiologist sit and look at the images. So this isn't meant to be magic. It's meant to just, grab the low-hanging fruit of how we can often label data in programmatic and more efficient ways. Okay, I'll briefly talk about, should I cut now?
I think last sentence.
Last sentence. Okay, well, I'm going to skip by. Then this is the actual superglue. If any of you are familiar with superglue, it's a natural language understanding task. Has more relevance to voice assistants. I'm going to skip by and just say that I'll end on this slide. If you're curious about anything that I just talked about and not ready to murder me out of hunger, or actually the latter one, maybe that subsides and you go back to being interested. We actually have a range of other operators, and we did a lot of work to extend the open source code to support them. So it's not just labeling data, but we've, over the last 4 years at Stanford, looked at what our collaborators are doing to actually get models to work on the training data. So these include two others that we recently started supporting. One is a data augmentation. So the canonical example is rotating images before you feed it into your model. Any image model uses it. Increasingly, text natural language models use it as well. That was based on 2017 work in NeurIPS, and it's supported in there. And then we have a recent paper in NeurIPS in 2019, so this year, about what we call slicing functions. This is actually motivated by a real-life Snorkel clone deployment at a big technology company with a big, well-known voice assistant, where, as well as other applications, where certain slices of the data were really critical not to mess up on. So we have a new paper on how to actually let users noisily specify those by writing little functions, and then have the model automatically devote more representational capacity to trying to do well on those slices. Anyway, thank you all for the time. Now food. Right, food?
No, we have a special guest, Michelle.
Oh, sorry. I apologize.
And Michelle is a sophomore, and she's going to take 5 minutes to tell us about the hackathon that she is running. That is going to help.
This is the fastest presentation you've ever heard. Yeah, so like Monica said, I'm a sophomore undergrad, probably the youngest person in this room, and I also didn't get the memo to dress in dark colors. Sorry about that. I'm just going to talk about TreeHacks. So TreeHacks is something I'm involved in, and essentially Stanford's hackathon. I'm going to go through a few slides, but this year TreeHacks is super excited to partner with Stanford Oval to make voice assistance hacks as accessible as possible. And some background for what exactly TreeHacks is. Let's go back to what a hackathon is. Hundreds of hackers from around the world gather and build something they're passionate about. TreeHacks is Stanford's student-led hackathon where we bring 1,200 plus hackers last year. This year we're looking at about 1,400. We bring those hackers to Stanford for 36 hours to work on some awesome projects. So, like I said, the number of participants we have over half of them are Stanford students, 8 plus countries, 86 plus schools, and for all these students, we fly them out, we provide all travel reimbursements, all food for the entire event to make sure the event is as accessible as possible. Last year we had 50% female and non-binary admits, and we had 41 prizes for these hackers who made the best hacks. This year, the reason we decided to partner with Oval is because we know that students feel there's a need for a privacy-centric open source voice assistant platform. And what does this look like in terms of providing, this assistance to students? Well, in one way, we want to provide resources for hackers. So that takes the form of hardware from Raspberry Pis to smart home assistants that they can hack off of, APIs, data sets, industry mentors, both technical and non-technical, We have tech talks, hands-on workshops, and prizes for hackers to have the best experience possible in 36 hours. From here, we hope that hackers will be able to improve Almond's natural language understanding model for those who are more machine learning focused. We also want them to implement new capabilities on Thingipedia, to use hardware to customize virtual assistants, and so much more. And what we found is every year, these hackers really surprise us. So there's no predicting what they can or can't do. We just want to provide the resources to make sure they have all the ability to make that happen. Let's take a quick look at past voice-related projects. Some super cool ones that we've had in the past is, one was a voice assistant to engage citizens in diverse, healthy political discourse. Another was a safety-oriented virtual assistant that interacts with and guides users walking alone at night, and that's also able to send emergency alerts. And the last one I think was super cool as well, a memory tracker skill for Alexa that uses sentiment analysis to categorize and store memories for the user to reflect upon in the past and to track mental growth. So these are super cool projects. We have more that I couldn't fit on this page, but for some context, that's what we're working with in terms of the hackers who are interested in this space. And these are from past TreeHacks. That's when we didn't even have specific focus on voice assistants. So with this year, when we're deciding to funnel a lot of resources into that, we're excited for all the possibilities. Yeah, so for the benefits of TreeHacks in terms of sponsors and companies, the biggest, one of the biggest is company brand awareness. Because you bring, so many engineering-focused students all into this one event, you get a lot of company brand awareness within 36 hours. The second one is code contribution and innovative ideas from hundreds of the world's brightest engineering students. When you have, a dedicated 36 hours for students to really use their brains and think of, whatever crazy ideas they can, you get some really exciting stuff, and that's been awesome to see from this past year. And the last one, classic recruiting. Yeah, that's pretty self-explanatory, I think. Yeah, so the core of it is by supporting Oval, you're also supporting TreeHacks and the growth of hundreds of top engineering students across the world. And I think it's super exciting that voice assistants is such a rapidly growing platform, and that students at Stanford are so excited about it. So I think when you harness the talent that you get from students, the bright minds, and also the existing platforms out there, you get some really awesome projects in the works. So yeah, I did promise I'd be fast. Thank you so much for your time. Come chat with me if you'd like to be involved, if you're not too hungry. And definitely feel free to email me at baom@stanford.edu if you're interested in getting involved. Thank you so much.
this is the dialogue session, and I'm very happy to welcome next speaker, Juleka Kanitur from Amazon, and she's going to talk to us about multi-domain state tracking.
Yes, hi. Thank you for the introduction. I hope the microphone is okay. So I'll give you a brief overview of some of the work that we are doing, some of the research work that we are doing at Amazon on dialogue systems in general. I'll actually start with the Alexa Prize Challenge and then move on to the task-oriented dialogue systems. The research in dialogue system has been mainly studied in two areas, social bots and task-oriented task completion bots. Social bots, they focused on naturalness and relevance and engaging conversations and also integration of knowledge. So when somebody is just chit-chatting about a topic that they are interested in, those will be covered mostly social conversational systems. On the other hand of the spectrum are the task completion agents. Here the focus is mostly task success. Usually these are connected to backends that have dynamic information or APIs that people can use to complete some task. And you can imagine a lot of these dialogues do actually switch back and forth. The main reason for splitting them into two is the approaches are somewhat different, but these days actually they are getting very similar also. So I'll first talk about our work on social conversational systems. We mainly work on social conversational systems in the framework of Alexa Prize Challenge. Many of you may have heard about Alexa Prize Challenge already. It's a global university competition. It's organized by Amazon for the past 3 years. Now we are going into the 3rd year. And the goal is to hold engaging and coherent conversations with the Alexa University bots for 20 minutes and get a high score. So this year, we funded several universities, 10 universities, to participate in the challenge. Stanford and Chris Manning's group is one of them. It's quite exciting. And on the Amazon side, we provide a framework which we call the Cobot architecture. It's basically a framework where we do the speech recognition, we do the text-to-speech synthesis, we get user utterances, and then we train some models to detect, for example, offensive utterances, to detect sentiment and topics of these input utterances from users. And then we provide places for the university bots to integrate their components in, where we can actually provide them data. So, for example, intent classifiers or knowledge-grounded response generation or response selection. These are the components that they have been building and integrating into our framework. The next challenge is going to start soon, but you can already currently communicate with last year's winner systems. If you just say, Alexa, let's chat, you're going to be paired up with one of the bots, and hopefully you'll enjoy it. We have been trying to help the teams so that they actually focus on the research problems, but not really engineering these forms of bots. So that's been taking some time of us. One of the findings that we have seen is actually teams, bots are having challenges in engaging deep conversations, deep knowledgeable conversations with users. And part of the reason is available data sets. So even though they have been building bots and they have been actually interacting with actual real users, we haven't really earlier provided them any data. They have been mostly building with their resources and publicly available data sets. So this year we actually created a knowledge-grounded conversational data set so that they and we can also study how people engage in deeper conversations on a topic and how they switch from one topic to another and how they actually can realize something that they know in natural language in a conversation. So we collected this data set and made it actually publicly available, not to the participating teams. Currently, it's the largest knowledge-grounded conversational data set that's out there. We released this in September. And it has 10,000 dialogues, 250,000 turns, and almost 5 million words. In addition to this, we also published benchmarks with the state-of-the-art methods that we have been building or others have been building. And I'm not going to talk about it more, but the information for our paper is here. And here's a data sample. What do I mean by knowledge-grounded conversations? Basically, on the right, you see a conversation where some terms are highlighted. These are conversations between two Turkers, and these Turkers were provided knowledge about certain entities and certain topics before they started the conversation. And what they could do is actually they could talk about what they just learned before the conversation, and we provide enriched data with links to where the information in the knowledge is actually present. So the teams and everyone can actually train models that would do selection of knowledge or generation of knowledge-grounded responses. So the other area that we have been focusing is task completion agents, task-oriented conversations. And our work has actually been recently announced as Alexa Conversations. Arina mentioned it earlier today. The specific thing I want to talk about is basically state tracking. But you can imagine a task-oriented dialogue system has multiple components, including conversational language understanding, which takes user utterances and then extracts entities and intents from the user utterances. So for example, if the user says, book me a table at Cascal for 2 people, language understanding would say that this is a restaurant reservation request and 2 entities are Cascal and 2. Then the next component is dialogue state tracking, which accumulates all of the now understood information from the beginning of the conversation till the point in the conversation so that the system can interact with an API or a backend knowledge source. And we issue a query to the backend. We get some results. And the next thing is to figure out what the system should generate as a response, what action the system should take. This is usually represented as a dialogue act and an argument and value pairs. And we convert this using response generation to natural language utterances. And we play it to the users with text-to-speech synthesis. And the part that I'm going to be talking about is mostly conversational language understanding and dialogue state tracking. I'll probably keep referring it to SDST to keep it short. But this component, the goal is basically to get user utterances and then to map them to a query or an API call to the backend. It's a critical component as understanding is a challenging task. And let's go through an example. I have a multi-domain dialogue example, so you can imagine there's not just one backend, but multiple backends. And dialogue state tracking would figure out that this person is trying to book a table at Cascal for 2 at 6 p.m. tonight. This would be the API call. Maybe the backend results come and then it doesn't work, so the user is offered some other options. State tracking would know that the user picks 7:30 in this situation instead of the 6 p.m. before. And the task is accomplished, and then the system asks, would you like a ride there? And then the user may say yes. In this situation, the system knows that it has offered something, but arrival time is actually the same as the time for the reservation. So this is the information that the state tracking, multi-domain state tracking, is supposed to extract from user dialogues. So what are some of the challenges for disjoint CLU and DST? First of all, sometimes even when the system asks for a value, like what time do you want to eat, the user may not be determined on it. They may be flexible. They may say like any time is fine, I don't care at this point, let's see what is available. These are usually represented as don't cares in state trackers, but they are not really present in users' utterances overtly, so they don't specifically say don't care. And yes and no values are problematic. They also do not appear in user utterances. Do you want internet? Do you want Wi-Fi? Is there any parking? All of these are, user is asking parking is equal to yes or true, a binary value basically. There are lots of indirect mentions. So the backend API may have a set of values that it accepts, like the price range could be $1, $2, $3, or it could be cheap, expensive, moderate. Or if you think of a movie system, there are usually a limited set of movie genre that the backends, that Netflix recognizes in their catalog. And then another issue is open vocabulary arguments. Sometimes the set of possible values is really large, and sometimes it's actually even infinite. And it could be growing as well, like there's a new movie that is being shot every single day, being added to the set of movies that the system is supposed to recognize. And a final challenge is referring expressions, especially in the context of multi-domain dialogues. Users may be referring to things that they have specified before, like book me a cab to the restaurant at the reservation time without saying what the values are. But if the system has a good dialogue state tracker, it should actually already have those values in its state where we can copy this information from. So each of these challenges do actually imply different approaches, should be more suitable for dialogue state tracking. The first three are implying generative methods where you can actually have a vocabulary of values, and the goal of the system could be determine a probability distribution over this vocabulary. But the second set of approaches do actually require either span-based or pointing approaches where you either point to the past dialogue or the current turn or the dialogue state. So to study these forms of interactions, we have been using a corpus called Multivos. It has been released by Cambridge University last year. It has 10,007 domain conversations. However, the annotations of that data set, due to the type of collection, were very noisy. So what we did was we actually used our annotation team to correct the annotations in all of these conversations and release it publicly so that others can work on this data set as well as us. And actually, if you look at the number of percentage of turns that we have changed, it's around 40%. It became a more difficult task, but I think it's more useful to experiment with this now. So, as I mentioned, we have been experimenting with lots of different approaches. We started with generative methods where one can read the full dialogue using hierarchical LSTMs. I'm sorry if this is too much technical detail, but I really enjoy this stuff. So we do use hierarchical recurrent neural nets to represent the dialogue context, and then we try to use feed-forward networks that use the representation of the full dialogue context and then generated probability distribution over the possible values for each slot at every single turn. This would be the generative approach. The benefit of this approach is you could deal with enumerated values or predefined value sets, but they are not really good for open vocabulary slots. So we started looking into approaches that would actually generate a set of candidates from dialogue context and use them as input to these dialogue state trackers. So again, we would get the full dialogue encoding with a hierarchical RNN. Then we would get the system turn, but as well as the system turn, we would get a set of candidates, which either a named entity extraction module could extract, or language understanding could work in this situation, or it could be just a plain set of n-grams. And the task now becomes for each slot, is the candidate value the actual value or not? So now it becomes a binary classification task. The third approach that we tried is using a neural comprehension approach. There are a lot of data sets these days for machine reading comprehension. And our thinking was, can we see dialogue as a document that you keep reading and you're answering questions from that dialogue at any given point in time? Can we treat dialogue state tracking as such? So we built models, again, recurrent neural nets to represent the full dialogue context. Then we posed every slot as a question. But now we want to also capture, in addition to pointing that has been going on in reading comprehension, we also want to represent values that are yes or no's, or that are enums, etc. So the first question that we ask is this slot value, should it be carried over from the previous dialogue state or not? Another question that we ask is this a yes or no, or a don't care type of answer? Or should I actually go and then check the span? And then the third classifier basically detects the span in the utterance. And our final approach, which is very similar to this one, again, we pose the domain and slot as the question. We estimate representations over the dialogue. But we do have multi-layer representations this time, and then we have self-attention plus cross-attention between the question and the answer. And finally, at the top, just like in some of the previous summarization work from Stanford, we do ask, do we generate or do we copy over? So we have been evaluating each of these on the Multivos corpus with both versions, most recently switching to 2.1. And the last approach that I just presented, that one is actually achieving the state-of-the-art performance. It was an incremental improvement. We didn't achieve it in the first day, but we have been spending some time in this work. And when I talk about performance, the numbers kind of look low. It's about like a joint goal accuracy of 50%. How could it be how could it be the highest value? So this evaluation measure is actually looking at all the slots of all the domains. There are 37 slots in this case. And if you look at the individual slot accuracies, for the best system, on average, it's 97%. But if you go to a single turn, and then if you look at all the 37 values, errors add up and cause this degradation. So this is a quite challenging problem. But anyways, so I gave a brief overview of the Alexa Prize and our support for public research data sets. And discussed these multi-domain dialogues. They're bringing some new challenges to the old types of approaches that we have been working with. And handling vocabulary terms, depending on what type of terms they are, is helpful in any form of API call. And we have been building the best, as far as I know, the dialogue state tracker. But these days, it's really a famous and popular problem. So I'm pretty sure in a week or so, we're going to be beating, but we won't give up. Thank you. Questions?
Just curious if all the entries to those to the Alexa Prize Challenge, are they open source and can we get access to it?
That is a very good question. I think they're owned by the universities. Depending on if they want to open source it, they could. But the code, as far as I know, like we don't make it open source. We don't even take it from them in many cases. Oh, yes, but they build their own components. So what happens is they create their own instance of a skill, and then they use our code and components, but we provide them a framework in AWS where they can actually plug in and build their own components. No problem. Thank you. I better leave this for you. Thanks.
Our next speaker is Sujit Ravi from Google, and he's going to talk about scalable and privacy-preserving conversational AI systems.
Hi, everyone. First of all, I think, as we all know, this is actually one of the first forums, and I think hopefully we'll have many more to come, and looking forward to next year. Thank you, Monica and James, for organizing this. I lead a few machine learning teams in Google AI. So my teams are focused on conversational AI, but also like computer vision. And we do a lot of things at scale on the cloud in order to make it, learn with minimal supervision, semi-supervised learning, all that. But on the other extreme, we also try to make sure some of these technologies work on the edge. This is for privacy-preserving, ML, and also to make it run efficiently, even on low-end devices. We're talking about like devices not like Pixels and iPhones, but like things like which have probably 1/10 of the capacity in terms of memory and compute. So what I'm going to do is talk about like how do we build and our journeys through some of these on building scalable and privacy-preserving conversational systems, but give you a whirlwind tour of how we dealt with these challenges, right? So there are challenges in multiple aspects. When I talk about scaling, how do we scale to large data in terms of doing this in a very efficient fashion, but also how do you learn with minimal supervision? So one of the things we do is what we call neural structured learning. I'll talk about that in a bit. Then how do we scale to multimodal and open domain scenarios? I'll give you a few examples of multimodal learning systems that we have built. And in the generation setting, we'll talk about how do we do dialogue generation with controllable semantics. And this is very important for open domain settings where you don't have like task-specific goals, but like it's much more open-ended. You're talking about like chit-chat. And finally, scaling to the edge, where on-device machine learning is going to be a crucial component. So neural structured learning, for those of you, if you just put the words together, it should hopefully convey what it means. But the idea is like a lot of the information that we have is both structured and unstructured. while deep learning has taken off in a significant fashion on making, like doing things like classification, recognition, et cetera, in all modalities very easy and do this at very high capacity and very good performance levels, how do we feed in structured signals into deep networks or like state-of-the-art machine learning systems? It's very tricky to do that. Before we talk about why, how we do that, first of all, there are many instances of like neural structured learning or like where structured data is used in very efficient fashion with machine learning systems and deployed at scale in conversational systems. And a lot of these problems in the language space involves how do we recognize intents. So we released a system called Smart Reply a while back, I think 4 years ago, where it allows you to automatically select with one tap potential responses to incoming email messages and chat messages. And there you have to understand response intents, like what are different response intents, like based on the context of the message. Similarly, in email, you want to understand what is the intent conveyed by the sender, and that might be used to classify or take some other actions. In the image space and video space, like you might want to summarize and compress the information in like a set of frames into like tangible, interpretable concepts so that you can then do reasoning over that. And finally, these things can be put together in multimodal settings where you have images and videos and text all coming together. A photo reply is an example of that, which I'll talk about later. But the core problem here is like all these systems, it's great, ML is great. I mean, we've been making rapid progress, all at the expense of we still require large amounts of data. And as the task complexity increases, we either pay more annotators or we try to come up with more creative ways to do this, right? It's a burden in terms of cost, and it's not easily accessible for everyone, but how can we get over this? So especially for conversations, it's not just annotating with attributes or slots. I mean, you want to do richer interactions, and doing that, like even for humans, are hard. Doing this at scale, even harder. So one of the things we do is exploit the structure in the data, and we use semi-supervised learning to a large effect. And the key ingredients are we use a lot of unlabeled data. This is much easier to obtain. This is also available on the web in many settings. But we combine that with some minimal supervision, which is like, for example, like if you want to do intents or like, conversational or specific types of tasks, you might annotate some partial set of data points, like maybe hundreds of examples. And then we try to exploit the structure of the data, both in the unlabeled and the labeled space very effectively. And one of the good and very effective formalisms we have found to work very well at scale is using graphs. And graphs offer, I mean, it's one of the like really, really easy ways of representing any type of relationship between any type of objects, whether be it like pieces of text connected to other pieces of text, entities connected to others in knowledge graphs, your friendship circles like through your social instances, even things like visual images, like how are different images connected to each other based on the content. And you can be very creative on how we construct the graphs. I'm not going to go into detail, but like feel free to talk to me about this after this. And in the learning setting, at the core, this is like one of the simplest ways to express this, right? If you want to learn like two concepts, car and line, imagine you have already constructed a sort of a network of images that are connected to each other based on the visual similarity. Now, all I need to do is label one image for each class here, and based on the connections, it would be easy to build a probabilistic model that can propagate this information and learn with very high confidence that all the other unlabeled images should belong to this category or the other category with certain probabilities. Now, this is what we do in Google. Like the system that we use for this is called Expander. And of course, doing this not just for like tens of concepts, we can scale to like billions of nodes and trillions of edges and billions of labels. So like the label space itself can be extremely complex, like where you have like compositional like entities connected to other entities and like them forming snippets, etc. This is based on also like we've talked about this externally as well in terms of how do we do this? There's a challenge about like how do you distribute the computation like very effectively so that you can do this across like hundreds or billions of data points. But also at the core is algorithmic complexity reduction, which allows you to do more complex tasks. So for example, we can do constant time inference in the label space, and this is all published in work and like some of it is also available in open source. But the key ingredient is like we convert the data into some form of a graph of relationships, like different types of relationships, and then we do the learning on top of that. Simple example in the conversation setting, imagine you want to learn about emotions. In like occurring in conversations. You take, let's say, words occurring in any corpus, and we can today, you can take your favorite embedding vector mechanism like word to vec to but or anything that you want to do. You can use the embedding vectors now to define similarity metrics between different instances in the space, right? Then between how do two words connect to each other. This gives you now a sparse similarity graph. Now, if I label one word in this graph, like for example, laugh is a funny concept. If I use the strength of the structured data that is represented here and propagate this information, I can still learn that ROTFL, I have no idea what it means, but it still should represent the concept of funny, right, or humor. So this is like basically the idea. Of course, you do this, at different levels of complexity. And doing this has to happen very efficiently in conjunction with all the state-of-the-art advances in machine learning, right? So that's the hard part. We can do very effective graph learning algorithms, scale it up really well, but of course, we want very, powerful predictive functions like deep networks to be at the core of this. Like, how do we reason between, let's say, 10 different edges coming to each other, but like we want sort of a deep network to reason which one is actually more important versus less important, right? Putting these two things together is not easy, especially at scale. But some examples of why you would want to do this, I've already used Smart Reply, you might think it's like a simple sequence-to-sequence problem. I can assure you what went into that is hardly anything simple. To make it work seamlessly, this is just a one-turn. Imagine if you had to do this for conversations, right? We had to discover a structure in the response intent space among all emails and messages. This is done in unsupervised fashion, in semi-supervised, because for some of them you're able to annotate with some concepts. But learning that structured space requires us to do interesting things in the graph learning setting. Now, once you have learned these structured intents, then you can actually use a very powerful network like a LSTM model, or these days BERT, or tomorrow it's something else, to reason over an incoming context or message and say that, okay, this is like the set of response intents that are most viable for this. Now I can use that to generate a particular response that is associated with that intent. If you factor the problem this way, there is a lot of things you can do. Make it interpretable, make it controllable, make it actually learn in a much more open domain as opposed to being starved because you don't have annotated data in a specific domain. And one of the useful outcomes out of all this is that it helps you to build also richer and diverse responses as a byproduct. For example, it's very easy. Anyone who has built an LSTM model or a recurrent model or even a BERT model, transform model will know that given a context, if you start generating from the probabilistic model, you'll start getting very redundant kind of responses. So you can avoid such things by actually elevating it one level higher by learning these structured spaces. Same thing happens in the image world. I won't go into detail here. The image recognition systems at Google are using these combinations of deep learning and graph learning to power state-of-the-art image search and the cloud services, etc. One quick foray. I've talked about the power of structure and how to reason over structure is important, and doing this at scale in conjunction with deep learning. Obviously, one of the questions that comes is what if you could do this jointly? This would eliminate a lot of the your system complexity. It'll also help you power the next generation set of machine learning models. And one of the forays we have taken is what we call neural graph machines. And the idea is this: we're trying to imagine shoving a knowledge graph into a deep network. Right now, how we do it is you'll start forcing it to learn some embeddings and then pass that as features. Instead, what if you could pass in the whole graph? Not just one graph, different types of sources, like maybe image graphs, text graphs, video graphs, and different interaction signals all into the network simultaneously, and allow the network to reason over which structures are more important in conjunction with the features that you pass in as in the regular setting. So this is what we've published a bunch of papers on this. The nice part about this is that it doesn't matter what your network structure is. Depending on the problem, you can actually adapt it to any kind of network structure you want. And it's applicable for a different set of tasks, from conversational understanding, especially in the low supervision regime. When have you heard of a deep network being trained on 5 or 10 examples, right? It is possible, in certain settings. The reason is because you now, instead of all the additional supervision, you're going to leverage the structure as a mechanism of sort of connections to one of the labeled examples, and then that's going to be used in order to produce better predictive functions. Byproduct of this is also that you can actually build leaner and more efficient models, which is an interesting thing to think about, right? We're talking about using more compute, but if you can actually build more efficient models by using structure instead, we should be trying to do more in this space. You can do things like reasoning over knowledge graph. And Adobe doesn't want me to. So let's see. Okay, no reasoning there. So we can do things like reasoning over knowledge graphs, like, these are like entities connected to each other in knowledge graph settings, and do question answering by using these sort of neural graph machine type of structures. This is work published by, one of my interns, like in Andrew McCallum's group at ACL this year. Same thing for images. If you want to build an image indexing system or like a really large image search system, you can use things like interaction signals between users, but also visual similarity signals. And the idea is that we shouldn't restrict ourselves to just one type of signal or one type of annotation or one type of supervision. There's a lot of additional information that is actually available in plenty, and how do you combine that? And this is one mechanism what we can use it for. So the paper is out already. It's going to appear next year. And even more fundamental things like in the algorithm space, everybody knows how graph partitioning is done. There's like several decades worth of work in this space. We can actually do better models, more generalizable models of graph partitioning using neural structured learning. There's a paper at iClear and this year, and then more coming out later. Best part, if you didn't care about any of that stuff, this is available in open source. And I'm going to talk about this at the TensorFlow World Conference tomorrow. It's already available, but we're going to just announce what is available, etc. So if you are thinking about, if you have structured data, or if you want to do semi-supervised learning, or even unsupervised learning, and you want to enable paradigms like neural graph learning, or even things like adversarial learning, this package, or this framework, allows you to do that with very minimal, hand-holding. With a few lines of code, you should be able to, download and run it on your data and try it out. We hope that you will check it out. Please ask me more questions about this later, if you're interested. So just switching gears, as I said, scaling to large data and minimal supervision is one aspect. But of course, when there are multiple modalities involved and even open domain scenarios, there are many such challenges. I won't go into prescriptive solutions of what work, but I'll just give you some examples. One example is this thing that we built called photo reply. The idea is that you get an image and you want to respond to that image, but of course you want to understand what the objects in the image are, but also how you would respond to those type of objects. So if you get a picture of a baby, you want to say cute, again, unless you don't have a heart, or if you have a picture of a skydiving image, it says how exciting and how brave. Or if it's your loved one and they say don't do it, right? Things like that. So this requires understanding both in the image and the text space and connecting it at the structured level. You can't just say that, hey, give me all the images and all the replies that you had and I will train a system. You can build such a system. It'll work for the head intents, but it won't work very well for the long tail. And it won't allow you to diversify and build more richer experiences. Same thing, a much more complicated task is grounded navigation. So imagine you're given instructions and the robot has to execute head upstairs and walk past the piano through an archway directly in front. Turn right when the hallway ends at pictures and table. Wait by the moose antlers hanging on that wall. This is a complicated set of instructions. I mean, how do you actually execute this? You have to do reasoning in the visual and the physical world, as well as interpret the the dialogue that is coming. And it might not be in a single shot. You might actually get different cues based on the oracle or the system that you're talking to. There's new work coming out on how to do this in a generalized manner from our group. Work with UCSP and other folks. And finally, generation is super important in the context of conversational AI. We had this work, this is by Chinadurai from Mila, one of Yoshua's students, and the goal is that open domain dialogue systems are quite often repetitive. Everybody knows that, and there are a number of ways to try to get around that to avoid it from doing generic responses, right? I mean, instead actually give you more personalized aspects in your conversations. Our stab at this was can we learn these conversational networks that are conditioned on interpretable dialogue attributes? And what we mean by dialogue attributes are these are things like different aspects like sentiment. It could be dialogue act, emotion, the speaker persona. And the nice part is you can actually compose these different attributes in the model itself to control how the dialogue is going to go from a point onwards, right? So this actually won the best paper, I would say. Congrats to Chinna for that. There's a lot of interesting, this is just scratching the surface. There's a lot of interesting work, I feel, in this space going forth. So a lot of interesting stuff with, doing things at scale. What is next? I said privacy is one important aspect. So we have big neural networks running on this cloud, but how do we make them run on tiny devices and compute constrained devices? This is absolutely necessary to make things work on the edge, right? I don't think, I'll reiterate, I don't think we can use the excuse that, oh, we need more machines to run these models, because I think the performance gaps in these models, the technologies that we have, are like diminishing rapidly. I won't talk a lot about this. This is the part of on-device machine learning. Zurnitsa, who's my close collaborator on this, will talk in detail. But the high-level idea is that you can do things in the vision space, like, for example, things running on your mobile phone, even things like Smart Reply running on your Android watch. This has like 750 megahertz, processing power with like couple of MB, like versus the original models we built were like gigabytes in size, right? So how do we enable things like that? There's a family of like efficient neural network models that we have built, which we think has broken ground in natural language processing and also in multimodal learning. Zernisa will give you details about that. But you can also do things on this on your own. Last year we announced something on the cloud where you can use this framework called Learn to Compress, where you upload your data and then it will allow you to train a model that is much more efficient, and you will be able to run inference on what we call TensorFlow Lite, which is a different runtime compared to TensorFlow, which is more tuned for mobile devices. There are also mechanisms for doing this for different, you want to choose latency, or do you want to choose like memory, or like different optimization constraints. But hopefully this gives you a smattering of like different challenges and interesting solutions, or at least seeds interesting conversations that we can have after the talk. With that, thank you.
Exactly one question. Anybody has?
Yes.
Okay, one question. A lot of the earlier work that you talked about, it's all inspired by label propagation, and if so, what other things have you guys done on top of that? Where in this case, I guess the label is a machine learning label as opposed to the label from main work.
Yeah, so the question was like a lot of the early work was like when I showed Expander was like label propagation. It's actually true. So these are like label propagation or probabilistic version of that, like at scale, right? But the challenge is like not the system level scaling to data, but challenge is scaling to when you do updates, right? Aggregations like across your network structures. How do you do this for not 100 labels or 1,000 labels? If you want to make it work for, let's say, dependency parse treelets or like, structures of labels, right? That just exponentially blows up the space, right? The medium, or like towards the midpoint and later, what I talked about neural graph is how do we take those and make it much more powerful, but with like neural networks, right? So inherently, the neural graph machines are inspired. The update equations are actually inspired by label propagation update equations. So we can talk more about that like offline, yeah. Right? Thanks.
Next speaker in this session is Lucian Poppa from IBM. He's going to talk about co-creation of explainable AI models for data.
Okay, so I'm Lucian. Okay. Hi everyone, I'm Lucian, and I'm part of a larger team in IBM research at Almaden. working on building the next generation of tools that enable the human-machine co-creation of explainable AI models for data. So a lot of focus in our work is on dealing with hard heterogeneous data and in curation of such data. So needless to say, data is at the foundation of many of the systems and applications that we are building, not only at IBM, but in many places in the academia and industry. We have large amounts of non-traditional data that are produced by several sources, and this complements the more traditional type of structured databases that we had in the past and we still have. So you can also see the dichotomy between the open data that's available as public data sets or subscription data sets and enterprise data. So, however, having said that, many of the AI systems, and especially those that need to face the users, the domain experts that need to solve real-life world problems, the AI systems that support such users need good data in the form of knowledge graphs that can enable then more informed decisions, or labeled data sets and ground truth data sets that can be used for better training of AI models. So producing such good data is essential, and this is a challenge, but it can also benefit from good AI tools. And this is where we come. So our focus is on building AI tools that can assist the human experts with their data curation needs. So just to give an example out of many possible applications, so imagine that you have an expert who may be working for a regulatory agency or for investment management firm, and he or she is interested in gaining insight about the financial health of a company. In this case, we want to be able to find the counterparties and the risk associated with the various counterparties and other types of exposure. So what's needed here is highly structured and curated data that can support this type of experts. However, the data is in raw documents. It's fragmented across filings that are submitted by the various companies. The data is in PDF, HTML, in text. So we need to be able to identify the important pieces of data and then put them together in something that's of high value. So there is a gap here that must be bridged. And today, financial data providers employ thousands of people to actually manually curate such raw data and provide integrated content. So this slide is a high-level overview of the work that we are doing in this space. So our work falls under this umbrella of the AI life cycle for knowledge creation, which has multiple stages. The first one is one in which we make documents consumable by machine. And we use here various combinations of OCR techniques to process PDF documents. And also we pay a lot of attention on understanding tables, since tables often carry a lot of information that can be useful for the domain, for the specific domain. The second phase is one in which you go deeper into understanding the contents of the documents. So here we use NLP and the language analysis. One of the main area of focus here is the universal semantic understanding of language, where we want to build a representation that's actually agnostic of the actual language, which can also enable better domain adaptation. We are also working on contextualized table understanding. So as we extract and identify tables and their contents, we want to be able to relate that to the surrounding text in the documents. And this brings up, this type of linking brings us to the third stage, which is the entity resolution and entity fusion. The idea here is that as we extract data from all of this variety of documents, data sets, we want to be able to link them and put them together into something that forms a knowledge graph of entities and relationships. And we work here on two different aspects. One is entity normalization and variant generation for the various, for the string representations of the various entities as they appear in text or other data sets. And the second part is actual entity resolution, which is the ability to link sets of structured records. And in this space, we are focused, as I said earlier, on human-in-the-loop tools that address the various tasks here. And the other important factor that I should mention is explainability, which is particularly important in industrial settings. We want to build the models that are explainable, that an expert can take and further customize and tune to their particular problem. So just to make things a bit more precise, we can take a look at the anatomy of, the general anatomy of a human-in-the-loop workflow for model development. So there are actually three phases in model development, roughly. Data labeling, the actual model development, and then the deployment and feedback. So for data labeling, the important part is how do we acquire the labeled data? We can use domain experts, which will surely give higher quality for the labeled data, but we can also use crowdsourcing, and we have projects that are that use crowdsourcing to acquire labeled data for various NLP tasks. Then the humans can be involved in the actual learning of the algorithms, of the models. So typically here we would have an AI engineer that provides feedback to the learning system. And we'll see quickly an example of active learning system where the machine interacts with the user to acquire labeled data on demand. Oftentimes we also need to instill external knowledge that may be coming from taxonomies or ontologies into this, into the models that they're going to be learned. And of course there is, we need to have humans in the evaluation phase, and the fact that the model is explainable enables an engineer to actually customize the model. Oftentimes, the machine learning algorithms may overfit to the data, may still need to be, the result may still need to be customized. And there is another feedback loop from the actual end users or the domain experts using the tools. So having said that, let's take a look at two examples of systems. So I'm highlighting here two. One is on text analysis use case motivated by one of our products, Watson Discovery. So the problem here is to be able to build a model that can classify sentences in legal documents. So these sentences, so this is imagine you have a database of sentences and we need to label them as into one of many labels such as communication, warranty, intellectual property, and so on. So in this system, the way we approach this, we have a deep learning model that learns rules. These rules are based on linguistic predicates that apply on top of semantic parsing of natural language. And once the rules are produced, there's a customization phase. So we have a user interface where the NLP engineer can further customize these rules. And you'll see screenshots of our system in a slide. The second application that I want to highlight is the entity resolution. So imagine here that we want to match entities across two very large data sets. Let's say I want to match IBM employees and find those who frequently tweet on a specific topic, that are expert on a specific topic. So this requires matching. In this system, we use active learning to acquire the labeled data as needed and learn again a set of rules. So these rules are similar to the ones we learned in the other scenario, except the predicates are very different. So these are predicates that are specific to entity resolution. And again, this type of active learning system will work well in situations where you don't have much labeled data. And this is often the case when you go to a industry customer. They will not have much labeled data. So in terms of regarding the system that learns linguistic expressions, we've conducted initial experiments. So this is a paper that's still under review. We showed that our system called RuleNN outperforms rule learning baselines such as MLN, Markov Logic Network Learning, and neural logic programming. Also, we showed that RuleNN outperforms black box classifiers from multiple instance learning, MINET. And RuleNN is also competitive with black box sentence classifiers such as BiLSTM, which it outperforms in the case of several of these labels. So this experiment is done on IBM procurement contracts. And, but more importantly, we gain interpretability over the black box models while still being competitive. So I mentioned the visual interface. This is what happens after the automatic learning of the rules. So we have a system called Heidel. This was showed in ACL as a demo this summer. The expert can look at the various types of rules and you can select rules or rank the rules according to their performance, precision, or F1 score. Moreover, you can look at the examples that are specific to each rule. You can see examples that are positive for the particular rule, also examples that are false positives. Furthermore, there is a playground mode where the NLP engineer can add or drop various predicates and see what the impact of that is. So for example, in this case, we can if we drop one of the predicates, the system says that the precision will stay the same, but of course the recall will increase. So, and it will quantify how much the recall will increase, and also what will give examples of relevant sentences that are now additionally classified by this rule. So this is Heidel. Now for entity resolution, I just want to mention that this is a long-standing research problem. It has been around for decades, but it's still very challenging and still very active. There are actually multiple manifestations of entity resolution. The more basic one, if you want, is the one that looks at string representations of entities. So here we need to be able to learn how to understand the name of an entity and how to normalize it. So this is an example of a company that has many different variations. Then the bread and butter of entity resolution is the more structured record linkage, where we have additional context associated to the various entities, and we can form rules to match those entities. And then, of course, this all leads into the knowledge curation and the creation of a knowledge graph based on structured entities and relationships from the raw data. And in one of the systems that we built, we actually use financial filings filed with the SEC and FDIC to construct a financial knowledge base that exposes an entity-centric view of the data. Just a few details on the entity resolution technology. So we have a system that is based on active learning that acquires labeled data on demand. This is system ER. It has two main phases. So it actually can start with no training data, so that's an advantage. And it requires some feature engineering, but the system comes pre-built with a library of various either generic matching functions or domain-specific matching functions for various domains. And then we learn explainable models in the form of rules. And then these rules can be executed at scale. We can run them on top of Spark or on top of Hadoop or other types of machines. just to give some highlights of entity resolution, how the active learning algorithm performs. This is a scenario that I mentioned earlier where we match an internal employee database, in this case, with Twitter profiles. This is a sparse context because usually, while an enterprise database may have a lot of information for each record, something like Twitter will not have much information. But despite that, you can still produce a lot of matches. So here we compare System ER with the supervised general learners, such as SVM and MLN learning. But these do very badly. They have very low recall for entity resolution. So since these are more generic type of rule learning or machine learning algorithms. Now, if we compare with learning systems that are specific to entity resolution, and in particular compare with active learning, so Arasu et al. Is a prior paper, and we showed that System ER outperforms it. So we can actually achieve, with 430 labels in this case, we can learn a set of rules that produce almost 10 times more links, while achieving a precision of at least 90%. And in general, active learning systems that we build, they have high precision guarantees. So this is a system that we use in IBM to build industrial strength models for entity resolution and for knowledge graph construction. And we use it in particular in the healthcare and in the finance domains. And let me stop here.
Always try to bring the human in the loop, right?
Yes.
So bring human in the loop can bring some benefit. For example, people will feel more confident. However, sometimes you will sacrifice for lower accuracy. Do you see this trade-off, or you see some opportunity to have both benefit at the same time?
Sure, you can have a trade-off between precision and recall. In many applications, actually, in the industrial application, you want to be biased towards precision, high precision, especially for knowledge graph construction or entity resolution. You don't want to match, you don't have too many false positives. So we tend to be biased towards precision. But there is always a trade-off. I mean, yeah.
All right, let's thank our speaker. A little bit over time.
Hi, everybody. Mac setup, hold on. There we go. One second. So again, I'm Jen King. I'm from the Center for Internet Society here at Stanford. I'm just going to, at Monica's request, give you guys a very, very fast, high-level overview of basically the laws, the GDPR and the California Consumer Privacy Act and how they relate to this general space. And, oh, my screen looks pretty cool, doesn't it? Let's see. Oh, come on, here. Let me bring this up before I plug this back in. And this will literally take about 4 minutes. And I need to emphasize that I am not a lawyer, so if you take anything I tell you as legal advice, then you've definitely gotten what you paid for, which is free, not necessarily great legal advice. Okay, here we go. Is that showing up? Yeah. Come on, thing, go. Okay, so lightning speed here. Once this shows back up, here we go. Okay. Sorry, my slides are extremely primitive today. So I just want to go over very, very quickly kind of what the legal landscape looks like for work in this area. looking at the GDPR and CCPA. So for those of you who may or may not know, the GDPR is the general data protection regulation that passed in Europe, or not passed, but went into effect back in May 2018. And so one of the things I want to emphasize about this is that it is a human rights-based framework, which is very different from what we have in the US, where our right to privacy is inferred from the Fourth Amendment of the US Constitution. And it's a human rights-based framework, so it's a very different approach to thinking about data and personal data and how we basically legislate that space. So I'm not going to read you the slides. I just want to give you kind of a couple of things to think about in terms of how these different laws approach this space. One of the things I really want to note, though, about the GDPR is people talk about it as if it's this giant settled thing. And it's really not, in the sense that the law is settled, but the interpretation of the GDPR is not settled. And so one of the things that we've been waiting for is for the various country-level data protection organizations to release their interpretations of the different complaints that people have filed with those different sets. So the Irish DPO, for example, will eventually kind of interpret the GDPR for Irish consumers. And so we haven't really seen a lot of decisions in that area. And so we don't actually know what shape the GDPR may take on the ground as we move forward. In terms of how this affects AI, in the whole AI area, the principles really come down to this. You have to have no algorithmic bias. So there's a principle around fairness. Purpose limitations. So you can't reuse data outside of its original context without basically getting explicit consent from data subjects. So this idea that you can flash a consent screen in front of somebody and then do whatever you want will not fly with the GDPR. Data minimization is another clear principle in that you have to have clear objectives for a system and you have to justify what data is used. So the sense of that you can just kind of like make something that's cool and grab a bunch of data and see what you come up with, not going to fly with the GDPR. And as we were just hearing from the last piece, transparent processing. Okay, you have to be able to explain to people what your system does and why it does it. So this idea of having a black box that you cannot audit, if you are creating a system that actually has impacts on humans, you're actually creating individual automated decisions, you have to be able to explain what your system does. And so in general, building systems that have impacts on individuals, that register some type of decision, is held to very high scrutiny under the GDPR. And there are particular categories of data that are special categories of personal data that may or may not be permitted depending on what your system is going to do. Really, the two key points I want to make with the GDPR is that you have to disclose what's going on. So you can't just create systems that have no explainability, no insight to what's happening, and that use personal data for these purposes. And then very quickly, the CCPA. For those of you who haven't heard about the CCPA, this is California's privacy law. It goes into effect on January 1st. It creates several new rights in California. The right to notice. You have to be able to notify people at the point of collection what data you are actually collecting about them and what you're going to do with it. Right to access, so your ability as a California consumer to actually access that data and download it and take it with you. So data portability, which is also in the GDPR. You have to be able to opt out of sales of personal data. You have to be able to request that companies delete your data, and companies cannot discriminate against you for these actions. So my take on the CCPA, honestly, is that there's not necessarily a huge effect on the types of systems we're building in this room, not to the same effect that we see with GDPR, but get ready for CCPA 2.0, which is on the horizon. The group that put together this ballot initiative, which was taken off the ballot and then put into law by California legislatures, they're actually creating a second version. So we'll probably see that on the ballot November 2020. So there's more to come. For those of you who I heard a couple groans, for those of you who have already worked on CCPA. The two just final points I want to make is that really the gist of this is that there's a lot of focus on explainable AI. You have to be able to justify what you're doing and explain why you're coming to the conclusions you're coming to. Privacy by design is another key point, which I'm not going to go into, but if you haven't heard of privacy by design at this point, you really need to. GDPR mandates privacy by design, and the Federal Trade Commission here in the US basically has said, you need to do it. You know, we haven't actually legislated in this area, but if we catch you for some violation, you haven't shown that you've used privacy by design, you're definitely going to get unwelcome scrutiny from regulators. So that's it. I will be happy to take questions later, because I want to get our next speaker come up, who is Mark Duranton. Is that correct? Yes.
So thank you, Jen, because then this avoid me to explain what is a GDPR. So hoping that's Beamer will work. Yes. Where is my mouse? Oops. Yes. Okay, so I'm Mark Duranton. I am from CA. So, okay, yep. Hopefully that will go. Oops. Yes, okay. So my name is Mark Duranton. I am from CA. So CA is a non-profit research and technology organization based in France. So we just discussed this morning during the introduction what is your dream as a digital a personal assistant. So for me, we already have this digital personal assistant, and we see that most of the people, and just here, have one request, so to enforce privacy. So in Europe, we just have the GDPR, which has consequences on how we design this personal assistant, and in both ways. But because basically now what people are using is this. Each time they go to a website, they have a pop-up, and which is very cumbersome, and they all click yes. So that's the opposite idea, because they don't read what they are allowing the company to do. So that's a good idea, GDPR, but with this, it's a bad implementation. So it's where we need to have assistant to help you in this. And of course, I would like to have assistant that provides me also support or warranty or shielding between the hackers, the spoofing on all the malware, and also about the fake news. But that's not the subject of today. I will focus mainly on the privacy issue. So it's why we need this digital guardian angel here. So when you are a user, you want to do two things. So the first one is to share data, and typically sharing on a Facebook. But even in Facebook, you don't know what are the parameters, if it's public, private, and things like that. So you will have a set of parameters. And of course, what you want to share on the public in Facebook is certainly not the same kind of information that you would like to share with your doctor, for example. So that means that there are different privacy requirements. So the second topic is getting data from the web here. So there are several topics of it, but I will focus on what I just explained. Due to the GDPR, we have all these very annoying pop-up. So one idea here is to have an intelligent assistant that will browse through the condition, and knowing your profile will click instead of you, so that it will be like the old web without all these pop-ups. So all this will be done in the background with by your assistant. Okay, so that's why I need this digital guardian angel that will protect me both when I will share data and when I will get data. So now I will focus mainly on the sharing data side. And this is the result of a project that started 5 or 6 years ago, so it's already finished. That its aim was to analyze all the framework of the online social networks, and also trying to understand a little bit how personal data should be handled, and also how people behave about it. So one of the goals is to build this semi-automatic awareness tool to assist the user in their interaction with personal data. So typically, this is very important because most of the people didn't really realize what are private data. So of course, some very personal things like your PIN number of your credit card, they understand that is private data. But for example, when they post a picture on the web, they don't know really if it's private, if it's public, and things like that. So the idea here is to have a tool that will analyze what are the consequences if you publish this picture on the web. And this is an example here where we have two pictures. And depending on the use, so if you are an insurance company, you could say that, well, this guy has a healthy risk because he's drinking a lot and things like that. And also for the job, that might not be a good profile. And we see now that more and more companies are looking into Facebook on their private data to have an assessment of their future new employees. So we have made a tool which is based on a technology we developed for quite a long time. It's called SimFet. So that's basically, well, it's a deep neural network, but we cut it into two phases. Let's say one universal part, which is basically making a universal description of the image. And it's adapted to a very large number of classes, and the classifier that could be easily added by the user on a particular application. So now the system is able to understand to analyze about 80,000 different classes. And we tested in the real field. So in one of the a benchmark, which was medieval. So the idea is that you learn about 25 million images from the web, and the competition was on 500,000 image, you need to identify where the image is located. And we went first during the 3 years of the challenge. So it's quite easy when you have a picture of the Eiffel Tower. You know that it's in Paris, but on general picture, it's far more difficult. So we get to have, in 70% of the image, to have an accurate location within 100 kilometers. So the same tools, or the same technologies also used this year in the food classification. So in the Kaggle, we were third. You could say, you were not first, but it was with this general purpose tool and not with a tool tuned towards this application. And it could also work on the face classification with 35,000 classes. So what we did for this application to have an assessment of the privacy of your data. So the idea here, as it was explained in some of the previous talk, we transform, let's say, the image into text document with a set of annotation. And with this, we could build a corpus from the set of private data. And then also we apply LDA, latent Dirichlet allocation, to create, let's say, topic models, so higher classes from this. So we went from image to a more semantical approach of the interpretation. So typically, when you see this image, so you could see that the second level semantic representation goes more high-level concept like drinking and things like that. So that's the idea where you could have a better idea of the context on the implication for your privacy. So we implemented into an app So here you could see that you could link to this app your Instagram, your Facebook, and a general profile. It will give you some of the quality here. Sorry, it's in French, so it's not yet translated. So about your alcohol consumption, about extreme sport, about your political impression, and things like that. So that gives you from your profile what could be inferred from your personality from the external stuff. And it even goes onto detailed profile. So on particular image, it could say that in the image in the middle, well, it's a high risk because it's you show unhealthy food, so if an insurance company sees that, it could increase your fees because, yeah, you could be at risk. While on the other image, it's healthy food, so that's good. You should put that here. So that's really an advisor to help you to share the right data, or at least to understand what are the implications when you shared this. So that's a key problem because most of the people didn't really see the implication. So this could be done automatically. So now I will switch to the other part, which is basically when you get data, and particularly what's it's not done yet, what we could do for the interpretation of the GDPR data on pop-up. And again, here it's based on a general in a tool quite generic that we developed during at least 10 years old. It's using deep learning. It's open source for the general engine, and it's cover 12 languages, and it was used by several industry from banking like CA, like oil company, Total, from Airbus and things like that. I will show you few examples of what this tool can do. So this is one application that we did for Bureau Veritas, and the goal is to analyze the regulatory constraints. So all the laws are different in each country, even in Europe. In each country, they have different set of law, and the laws are evolving, and the regulatory constraints are also evolving. So typically, this tool is able to collect all the information and give you recommendation. And if you want to sell this product into this country, then that's the set of recommendation that you should do. And typically now it's browsing 12,000 official source of information, and unfortunately they are not labeled. So you really need to analyze the text, and there is no metadata that could help you to analyze the text. And the tool is browsing typically 20,000 web page per day for being accurate day to day. So the same tool is also used for classification, so seeing that it's also cover languages that are different from English, French, so more Latin-based languages, like Chinese here is basically for the Chinese social security to check if from a prescription is corresponding to the disease here. So typically here from this prescription, it could go to check if it's correct for this kind of stuff. So that because people could want to have some other drugs for other topics. So we get a 98% of accuracy. And for the oil company Total, so the idea here is to summarize into a very small information the news in their domain. So typically here, to know that, okay, one company, a Petrogas, get some new allocation in oil field here from a complete text. So it's this kind of technology that we want to apply to be able to browse all the web of all this legal stuff, to be able to know exactly what are in this recommendation, so that you could set the flag according to your own privacy requirements. And now this kind of tool we are using to chatbot like Almond, but on a particular domain. So the idea here is really to be oriented toward a particular business. So the idea is to feed the system with documentation on equipment and things like that, so that after the chatbot could interact with the user in a natural language on this particular domain. And indeed, this could be linked to off-the-shelf a system like Facebook, Google, and the other here. So just to finish my presentation, I would like to give you some long-term view or evolution that we see today, because this year is the 30th anniversary of the World Wide Web, which was invented in Europe and which is an open standard now. So we hope that the next generation of personal assistant will be like this. So what we see today is that typically most of the thing is done on the cloud remotely, and the data are, let's say, kept by the big company that are processing your data here. So we see a trend, and we just see the presentation of Google about, what we could say Edge AI, where basically the processing is done locally, which is better for privacy, because your data remain near you and didn't go necessarily to far away or another country, which could be a problem for the GDPR if your data is flowing from Europe to the US and things like that. So what we could see in the future is that the web will be more a repository of skills, of knowledge, and then all the personal assistant will be able to access this knowledge in an interactive way and in a dynamic way. So I think that's what Almond is doing, and is perhaps the next web. So for us, it should be like the web, open to everybody with interoperability, with a standard, so that each people could access to the knowledge and could cooperate. And about cooperation, that's my last slide, is that we really need this collaboration between a human and machine. I would like the machine to be my digital guardian angel, to be really helping me to access to the cyberspace. But also, I need to help it, and as some talk were presented today, is to improve also the capability of the machine. So human in the loop and how to improve it is also a key element for us. Thank you very much.
Is a public cloud feasible?
Well, in Europe, we would like to have a public cloud, yes. The problem is that it will be, it might be now to have a French public cloud, a German public cloud, and things like that. We are not yet here. And a public cloud that is cross-border will be even more difficult because of mainly legal reasons. Not technical reason, of course. So we work a lot with Japan, and here we do have problem because we cannot process in Europe data that were generated in Japan, and vice versa, due to the both regulation of both countries.
Great. Thank you, merci. Welcome back, Giovanni, to the stage.
That's very quickly. Yes. And I will now fit. I will try to fit. All right, everyone, it's me again. And we have heard about the idea of a digital guardian angel that helps us with our privacy decision. And maybe that digital guardian angel can be a virtual assistant, and it can help us share. And this is joint work with my colleagues here at Stanford and advisor Monica, and it was presented at the Ubiquitous Computing Conference last year. So how do people share data? Well, if we're talking about actual data like photos, files, contacts, the obvious solution that people go to is Facebook, or if they care, maybe email and message. But what about IoT devices? What about services like bank accounts? Are we gonna share the username and password and give out full access? What about devices like Nest that are tied to your Google account? Are you gonna give out your whole Google email and password to share the data? Well, our goal is to share with fine-grained control. Define who, when, where, and what can be shared. And not just username and password. And of course, because we are at the Virtual Assistant Conference, our plan is to share through Virtual Assistant. In particular, we observe the Virtual Assistant serve requests on the user's behalf. And so if they can serve requests on my behalf, they can serve requests on behalf of someone who might want to access my data, or I might want to share their data with them. And we have designed a federated architecture that allows the virtual assistants to communicate without any third party seeing the data. Choosing a virtual assistant provides generality because all the capabilities that are available to a user are available to be shared. It provides usability because it natively supports natural language. And finally, it provides privacy because we're never actually granting direct access. The virtual assistant is always mediating, is always a trusted agent that guarantees that only the allowed access is provided. And we are casting this in the framework of natural language programming. So we have extended our when, get, do construct to be an access control construct. We added a filter on the action as well, and we added a requester in front. And here are a lot of examples that we can support. You can share your data with your doctor, you can share your email with your secretary, you can let your daughter watch Netflix at only a certain time, etc. And anything in Thingpedia can be used to share and to put restrictions. So let's look at an example. Imagine a dad wants to help their daughter monitor their house when the daughter is away, like the daughter has a security camera. The dad might say something like, ask Alice to notify me when a security camera detects motion. And the dad's assistant will then translate that into an executable formal program. It gets sent to Alice's assistant. Now Alice is a trusted agent. We'll check into a policy database if the request is allowed. But we are not designing a top-down access control system where we have system administrators and managers defining policies. Instead, we want a system that is able to understand on demand. At the same time, remote execution or like sending out code is very dangerous, and users are trained not to accept any request or code. How do we combine those two? Well, we take advantage of the fact that we are choosing ThingTalk as the code representation, the program. It's a very high-level language. In fact, we can translate not just ThingTalk from natural language, but also ThingTalk to natural language. And so we can generate a permission request to Alice that matches exactly what the request is. It says, Dad wants to get notified when motion is detected on your security camera. The translation happens on Alice's assistant, and so it's guaranteed to be exactly what will be executed. And so should Alice accept? Should Alice let her dad see a security camera? Blanket statement. Probably not, but she might want to say, only if I'm not home. So now the assistant interprets this as a constraint and can combine both the request and the constraint that Alice applies, save this into the policy database, and now execute it, send the results back to the dad's assistant, which now displays notification motion detected. So how to check if a program is allowed. I will not go into detail, but at a high level, we use satisfiability modulo theories, which is an algorithm to check if two logical formulas are entailed. So we map both the program and the policy formally specified to SMT, to logical formula, and we check if they actually are entailed. Furthermore, if the programming is natically allowed, we can use SMT to also compute the largest intersection of the program and the policy. And this algorithm will give us a formal guarantee that whatever we execute is actually allowed by the policy. So we have constructed all this technology, but do people really use this complexity in access control? And to verify, to answer this question, we conducted a survey of 200 people from the general public on mTurk. We wrote down 20 use cases of sharing. Here are some examples. And first we asked, would you be comfortable sharing this asset, like your credit card, under only role-based control? So would you share your credit card with your teenage daughter? Would you let the Amazon post courier unlock the door? Would you let your kid watch Netflix? And you can see that there is quite a broad spectrum. Some use cases, people are very scared, they're not willing to share. Some people are more okay, like Netflix people in general are more okay. Then we show two additional constraints. We show fine-grained control. For example, the credit card, but only for food, or only with a $20 budget limit, or the Netflix only between 7 and 9 p.m. And what we observe is that across the board, all the use cases improve. Everybody becomes more comfortable to share if you allow them to impose fine-grained control. In fact, if you consider all the use cases and all the people, the number of instances in which people are comfortable sharing doubles once you introduce fine-grained control. We also wanted to validate whether our ThingTalk policies construct is understandable and actually covers what people care about. So we collected 220 use cases of sharing with fine-grained control. We collected this from mTurk. We're just showing 3 examples of someone asking for a request and someone else replying with only under certain conditions. So the workers are not familiar with the system, they're not programmers, they have not seen what the system can do. But the interesting thing is that 85% of the use cases we have collected can be represented in the ThingTalk policies construct, either with existing APIs that someone will have to add to Thingpedia, or with new APIs and new capabilities by the service and hardware providers. And we are interested also in performance on natural language, so we applied our tool Genie. We constructed a training set, and we paraphrased a very small portion of it, and we found that we get 82% accuracy on, again, realistic crowdsourced policies, which is a marked improvement over the previous state-of-the-art of training with our real data. And in conclusion, we have shown that Almond helps users share their data without losing privacy, and people are significantly more willing to share if we fine-grained control in their hands. And we have shown that Almond lets users control sharing easily in natural language and with fine-grained control. And I have a little gift for you. We have a short demo. This is work that's been done by 2 undergrad students, Rick and Elvis, this summer, and 2 master students, Tracy and SK, this fall. The use case we're interested in is helping doctors manage a large number of patients and giving personalized care to each patient. We are dealing with patients who are a little older, will need reminders to take their blood pressure, and let's see the demo. Please tell me it works. Oh, wait, oh. 1 second, I need to plug the sound. Which is the sound cable?
Dr. Lee can only see 5,000 patients a year because he has to schedule regular appointments with every patient periodically. Almond allows him to give better care to more patients.
Almond, ask Bob to record his blood pressure every evening. Almond,
Okay, so you want me to tell that Bob?
let me know if Bob's blood pressure goes above 140 and 90.
Okay, I'm going to note that. For different patients, Dr. Lee has different requirements.
Almond, ask Tracy to record her blood pressure 3 times a day. Almond,
Okay, I'm going to
tell me if Tracy's blood pressure is above 180 and 120.
Okay, I'm going to. Patients often forget to record their blood pressure, but their almonds can remind them to enter their data. All the sent data is encrypted and no third party sees the data. Now, Dr. Lee can spend more time on the patients who most need his help. Almond, helping doctors.
Again, for this, you gotta congratulate the 2 undergrads and the 2 master students who worked on this project.
One question, anybody? All right, let's go ahead and move on because we are definitely behind. Ed Cheng from HTC is next.
Sorry.
So when I'm setting up, I just make a small announcement. When you see I'm suspicious taking photos, because I'm an event photographer, and so because of privacy issue, if you don't want your photo to be shared, your picture to be shared, let Giovanni know. So we are going to share all the photos we took during the event, but for privacy reason, you can send your email. Okay, so my focus will be on using the blockchain technology to preserve privacy. So pretty much this is an implementation, collaborate with Monica's team and David Majerus and also National Taiwan University. So we focus initially on precision medicine, but if you want to make sure diagnosis and treatment can be very effective, we need a lot of data. So imagine how much data your car collects a day from you. It's probably billions, millions and millions of bytes, like Tesla, right? Constantly collecting data. But we really want to be healthy. We are more important, our babies are more important than cars, but how much data we collected from our babies? Probably very, very minimum. So in the future, suppose we have a lot of data for a person. The current model is at time X, if we don't feel really well, we go to a hospital. To make an appointment, we get a classification, what kind of diseases. But precision medicine or proactive medicine is we really want to make the risk prediction as early as possible. Therefore, we need to collect a lot of data. So IoTs, I don't need to say more about it. Almond can connect to various IoTs, and we have lots of medical records in all different formats and from different sources. We ought to integrate them together, but we have this privacy issue. So how to deal with the privacy issue, and what are the requirements of the performance? Privacy, we also need to be able to audit even let's say I allow the hospital to access my data, I really want to know when my data get accessed. Or let's say I make a request, like Giovanni just did an example, measure my blood pressure, if above 180, tell my doctor, but my doctor may say, you didn't send me the message. So it has to be auditable, right? It has to be accountable. Otherwise, if there's any misunderstanding or miscommunication, really have some indelible record need to be looked into. And the system must have low latency. And Bitcoin has high latency, high throughput must be supported, of course, consistency, just like I mentioned. Okay, so is blockchain a solution or it's a hype? Let's look at the fundamental theory of transactions. So this is a very famous Eric Brewer's CAP theorem. There are 3 requirements: partition tolerance, consistency, and the availability for distributed systems. And they cannot all exist or be supported at the same time. Only 2 can coexist at the same time. So one popular model is blockchain. Blockchain only worry about decentralization, partition tolerance, and the consistency because they don't want double spending to happen, but they have to suffer from availability. There's no way out. This is theoretical foundation. So this is blockchain's problem. So if we use a blockchain-like, Bitcoin-like blockchain, we run into this kind of problem, right? So how do we solve it? The other extreme is just like banking. They ensure consistency, availability, but whenever there's a partition in the network, they just shut down the system. Easy to solve the problem. But if we want to compromise the two, we want to make sure public can audit all the data access and authorization. At the same time, we want to ensure this kind of high throughput and the low latency. We probably need to combine CA and CP. And we already say we cannot have CAP all 3 at the same time. But let's say we have the 2 together, but we make it hierarchical. So this has been talked about in the community, like you have a main chain, you have side chains, right? So main chain doing public validation, and side chain you can do whatever efficient methods like banking, or we do IoT data uploading with low latency and high throughput support. For the details, we can talk offline, or we can just look into our paper, how can we support high throughput on the side chain and doing validation on the main chain. At the same time, side chain, you can support different kind of chain. You can use different protocols, like Tendermint, or maybe a Scalar, right? Scalar is done by David Majors at Stanford. Then the next question is privacy. How do you make sure the data privacy is preserved? And how many heard about smart contract? Right, virtually everyone. The smart contract, basically, you don't store data in the public. You put a piece of code as a contract in your blockchain. But even better, Monica just talked about, Almond just demonstrated, and you have this Thinkpedia or ThingTalk, right? So it's a piece of code, but you can convert back into natural language. Or it could be a piece of natural language you put into a smart contract. When smart contract get executed, then we convert into a piece of code. So when you talk about auditability, you cannot put a piece of code in a smart contract because people cannot read it. So this is a very beautiful assembly or combination of natural language and the smart contract. All the advantages are there, right? Contract is a piece of code and no data there, and data is offline. Only when the contract gets validated, approved by multiple parties, then the contract can be executed. Whenever the contract is executed, we also log on the blockchain. So you cannot say, well, I didn't get the data or I didn't access the data. And the user can be informed. Let's say my private data has been used by a company doing data mining. I like to know when my data has been used, and maybe I can charge a company, especially in the medical domain, right? If a person suffers from rare disease, the data may be very valuable, and the raw data may not have a lot of value, but if a physician willing to annotate the data, the physician may be able to get profit sharing. So this kind of architecture not only providing privacy, providing high performance, at the same time may have this kind of token economy, can encourage people to share data and doing AI kind of research. For privacy preserve AI, there has been quite a few proposals. But for medicine, federated AI may not be very useful because different hospitals may have different CT formats, different resolutions, different annotation schemes. And if you don't know the FDA process, you don't just annotate some data in a hospital, then you apply for FDA. Even the annotation pipeline has to fulfill or satisfy the FDA requirements. So all this desirably should be kind of people willing to share and collect it to a particular location or process, which really understand the process and standardize the data format and doing high quality annotation, then eventually can help the human being. So finally put together, this is end-to-end architecture. First of all, a user could be a pharmaceutical company or myself has some patient data. I really like to be able to share my data with a pharmaceutical company. So there's a directory service first, just like web search, right? Many people have data, but if you don't have a Google search engine, you cannot discover data. So data directory service is basically a cache service, caching all the blockchain data. And the user can do search. Then user can do bidding and contract signing on the TTS. And once the contract has been signed, then contract will be put onto the blockchain. And when contract is executed, also will be logged on the blockchain. And auditability, because it's decentralized the root, so anybody can go to the ledgers to just audit what's going on in the past. So there wouldn't be any dispute because everything is hard and auditable. So with that, this is a very brief discussion, and we have been working with Monica's team at Stanford. Hopefully this could be a very useful infrastructure for preserving privacy. Thank you.
How are you navigating this NOMED people versus HL7 and fire and the medical health silos?
It's really challenging because, but this is probably a reasonable scheme because we only need to be able to use RESTful API to access to individual data. So, but individual like companies or healthcare providers, they have to be able to provide access into the platform. Okay, so it's a break time, right?
Yes,
okay, thank
this is a break time. We are half an hour behind. Our break is supposed to be for half an hour. Maybe we'll take 20 minutes.
I wanted to check if I also have a dongle, but this looks like the right dongle to use.
Is that your dongle or is that the dongle was here?
This dongle is here.
Yeah, yeah, that's cool. Well, from what I understand, it sounds like there's some kind of relationships with not just Microsoft.
So 10 minutes, because Michael has a speech, and you don't want to make it.
I do not, but do we want to swap these two?
You're already set up, so just go for it.
All right. Okay, let's get started.
Please, everybody, sit down. Let's welcome our next speaker in the user engagement track. We have Arun Chaganti from Square, and he's going to talk to us about reflective listening in open-ended dialogue.
Hey, thank you so much. I said hi earlier. I'm Arun. I'm the AI lead at the conversations team at Square. And I'm going to tell you something that is just like a neat trick. It's a neat generation trick that we use in our chatbot to handle out-of-domain responses. So I don't need to say this. Over the last 5 years, we've had great progress on the penetration of general-purpose chatbots like these, as well as very specific task-oriented chatbots like Erica from the Bank of America and our own Square Assistant for small businesses. And one of the things that these chatbots have enabled is this natural language interface that can be incredibly convenient for people to communicate about just about any type of question with a chatbot. And so if you have something like this, what's the weather today, boom, all of these chatbots will get it. The problem, though, is that because we've made our interface so broad, natural language, it can be anything. Users don't really know what that boundary is between what is in domain and what is out of domain. And so if I were to say something like this, I haven't been fired, just saying. If I were to say something like this, the chatbots we have just don't know where it fits in our domain. Where does it fit? And I can just say that I don't think that that's like the most empathetic response that I could get if I were to say this, just saying. What should we do as people who are thinking about developing these chatbots to handle these out-of-domain settings? And I can promise you we'll never be able to make everything in our domain. The kind of strategy or idea we have is to adopt this tried and tested method that expert human communicators use, which is called reflective or empathetic listening. The idea is just by reflecting the user's language, we can emulate a sense of empathy and at least make them feel like they've been heard without honestly understanding what they said. So if we said, I got fired, I don't really know what that means, but at least I can understand this something with sentiment. I can express a sympathy by saying, I'm sorry to hear you were fired, whatever that means. And so this task that we propose called Mimic and Rephrase is fairly simple. Given an input prompt from the user, something like I just got fired, and a particular speech act that we want to convey, in this case expressing sympathy, can we combine the two to convey that speech act while using as much language from the prompt as possible to emulate the sense of hearing the other person? So for the rest of this talk, high-level takeaway is we can teach bots to perform this reflective listening using this generation task that we propose called mimic rephrasals. In the rest of this talk, I'll just cover what it means to be a good mimic rephrasal, and then talk about a data set we collected, some models, and evaluation, and conclude. So we found 5 rough categories for what makes a good mimic rephrasal. It should be appropriate, convey the topic of interest. It should be fluent, of course, be grammatical. it should be specific to, it should have the right level of specificity from the input prompt. It should, of course, be concise and to the point. And most importantly, it should have a sense of repetitiveness. It should mimic the user's language to emulate this sense of empathetic or reflective listening. Let me ground this with an example. Let's say for this particular input prompt, I have, I'm curious whether the swimming pool is open. Very generic response that's very similar to what most chatbots use today. Could apply for any response. It never gives that sense of being specific or actually addressing what I've asked. I'll show you what this leads to in a deployment towards the end of the talk. There's some naive ways of just taking the input and shoving it into this sort of, I don't know why, in quotes, you said this, that often can be either ungrammatical or just not capture the right point of the user's question. So it's non-trivial, but it seems like a simple task to go from what the customer or the user said to something that addresses their point. In this case, I don't know whether the swimming pool is open after 7 p.m. And this is what we want. With that out of the way, let's look at a data set that we've collected for this task. We've looked at roughly 2 types of speech acts. One is expressing sympathy, and the other is to inform a lack of ability of the bot. In both of these tasks, we use Mechanical Turk in 2 stages. We first ask people to generate these stories or generate questions that we've collected, and then ask them to create responses that express that speech act while using empathetic listening. In total, we have about 10,000 pairs for the I don't know data set, 6,000 for the emotive, and they're about the same length as the prompt. There's a lot of overlap, which again reinforces this is the task we're doing is trying to copy a lot of language from the user. More qualitatively, we see about 30 to 40% of these rephrasals involve some change of perspective from the customer's perspective to the bots. And another 15 to 40 involves some amount of subselection to like hone in on the key details that we should be responding to. And finally, there's a small set that are syntactically challenging that involves some non-trivial reordering of clauses. With that data set, let's look at some very simple models to try and do this rephrasing. We have just 2. One was a rule-based syntactic rewriting system. For those of you who have used Core NLP and are familiar with SemGrex, it's that. And we have a couple of patterns for how to reorder things to be grammatical. Of course, we also trained a neural network because it's 2018, or when this paper is worked on. And it's a fairly standard model. We start with a BILSTM with attention. We add a copying mechanism because the whole task is about copying things from the input. And we had to do some tricks with the beam search that we used in order to actually generate the right type of response. In order to evaluate this model, we had one part which was an automatic evaluation. It was just to get a sense of a pulse on how the models were doing. And really the only takeaway is that both the rule-based system and our fancy neural network do comparably well. The real test or the real measure is how do we do if we compare with human responses, and how do we do an A/B test. And here the real takeaway is that the fancy neural model does almost as well as humans, which would be a 50-50 preference rate over here on the I don't know data set. All the models do a little bit worse on the emotive data set, and this is just the types of questions that people ask are just much more complicated, and we also have less data to train a fancy model on. This is the real fun part. So we saw that we had this I don't know model that did pretty well on relative to human on our A/B test, and we wanted to see how well it would do in practice. Give you a sense of the qualitative difference, let me show you 2 transcripts. Both of these transcripts were from our time as a startup, as Eloquent Labs, when we were working with an insurance company. So this is why there's a domain shift in terms of what we were working on. So it's an insurance company. A customer would come in and say something like, I locked my keys in the car, what should I do? And this is something that, at least at the time, we did not have an answer for. We couldn't support. And so we'd say something like, I'm sorry, I think I missed something in there. To which they would immediately say, lockout support. And then we'd say, I still don't know what you mean. And they'd keep on rephrasing this until they would get frustrated and leave. I don't think this is a unique experience. I have done this to chatbots too, because I know that they're likely stupid and I should just keep trying again and again. I'm guessing I'm not the only one here. After deploying the system that rephrased the user input, what we noticed was that there was this marked change in user behavior, where they used to just rephrase by saying something more specific. I don't know if we have lockout support. People would either take us up on help to go talk to a representative, or they would ask another question they had and move on. And that was like our big takeaway from this, this experiment. All right, that's more or less all I have. Just to conclude, what we saw was that we can handle these out-of-domain responses in a chatbot gracefully by teaching them this technique of reflective listening. It's a very simple generation task, and that's a pro. That means that simple models are able to perform comparably well with humans, and we were actually able to deploy this in practice. The data set and models are available. Happy to take any questions if I have time for it. Do I have time for it?
Sir, great work. I have a question about out-of-domain. So in some sense, to know that getting fired is a negative thing, you still need that kind of data. So it's not fully out-of-domain, because you need to collect the data set that will reflect those kind of questions. Have you done experiments in which it's fully out-of-domain and what's accuracy for those things?
So it is, you're absolutely right about how do you figure out what is out of domain? The deployment we had was really for this I don't know set. So there are some rules. We basically can identify it's a question, and we can identify that this question doesn't match anything in our knowledge base. It's possible that our model was bad and it does match something in our knowledge base, but here too, I think it's a better user experience to just tell them I wasn't able to find it, rather than have them continuously try and try again. But it is an important point that there is figuring out what is outside the data set is important, and we do this in a simple heuristic way.
How risky is using reflective listening in sort of like the emotive space? Because like if you were to say, I'm happy that you were fired, but if the model were to say that by accident, like that'd be a pretty significant.
You are absolutely right, and there are guardrails that we have when we're using in the I don't know setting. For example, if there's any profanity in the input, we will not use it. This is a good point, and at least we find with some guardrails it works out well. There are, of course, embarrassing examples where it can go wrong, and I will not say that you can just take this out of the box and try and use it.
All right, let's thank our speaker. So our next speaker is Professor Michael Bernstein here from Stanford, and he's going to talk about open world interaction between people and conversational agents.
I did not get fired today. That is not emotive enough. Okay, well, so I would like to talk a bit about what happens when conversational agents, like with Arun, sort of need to push outside of their existing boundaries. And in particular, I'm most interested in what happens, because this happens when we actually put this in front of people. Conversational agents inside of sort of constrained environments can work great, but in these kinds of open world environments, we're encountering new things, we're coming across reactions that we've never seen before, and the conversational agents need to be able to adapt and react in ways that feel fluid. So in this work, which is work in progress, by the way, so we value your feedback, we're talking about the creation of a conversational AI agent that is learning to ask engaging questions to fix its mispredictions. So we have an AI model that's trying to learn about the world. In our case, it's trying to learn about the visual world, and that it doesn't know things, or it knows that it doesn't know things, or it thinks it might know something, but it's not sure, and it needs to be able to engage with people to sort of improve its own knowledge. So it has to trade off two things. One, what do I need to know? Is this information I care about? And second, what do people actually want to talk about? As a computer vision system, I might be very interested in whether the corner of that table is exactly 90 degrees, but if I were to ask someone, they'd be like, why are you asking me this? Like, you're violating the Gricean maxims all over the place. So what we've been doing is creating a system, and I'll explain this graph in a moment, that is essentially deployed on Instagram, asking people questions about the images that they post, learning from the answers in a gigantic reinforcement learning loop to essentially revise its own knowledge of the world. So imagine that you post on Instagram this picture and label it with, I found this little one outside my apartment, to which I'd say, you have a really cool apartment location. The system then reflects on its own knowledge base. What does it know? What does it know about the things that it's looking at? And finds a concept that it's unfamiliar with. It's uncertain as to what the object is that's sitting on a tree here. This is a sort of unusual animal. You can imagine that there are many different ways that it could phrase this question. This is a sort of open world language generation task. And it's going to try and pick the one that people would be most interested in actually engaging with. Based on the feedback it gets, the person might reply. They might say, the agent might say, oh, wow, I've never seen a tail like that on a fox, even though it may actually know that it's not, in fact, a fox. It turns out that on the internet, the way to get people to reply is to say something that's wrong. Try it on Wikipedia. It works really well. And then based on the feedback, for example, if the person never replies, it gets some negative feedback that this isn't actually a good pick, or a negative reward if the person is confused or indicates frustration at the system, and a positive reward if the person actually answers the question informatively. All of these are going through a classifier to identify whether they've answered the question, and if they've answered it, where the extent of the answer is. So we then can answer this, it's in fact a red panda, pull it back into our system and move forward. So we have this sort of never-ending learning loop. And again, what we're trying to do is what we call engagement learning, essentially combining the human interest in engagement trying to improve that over time, learning to ask better questions, learning better how to phrase questions, what people want to talk about and what they don't, and also improving our knowledge over time, asking questions that are going to help our prediction task. So if you have any training in RL, you probably are like, Michael, this is never going to work. And a few months ago, before we figured it out, you would have been right. The reason is that essentially the action space here is huge. So we have very, very sparse feedback from people. That is to say, essentially our action space is the vocabulary size to the power of the question length, which is 10 to the 80 or so. That's not great, especially when we only have, at best, some tens or hundreds of thousands of responses. You can't learn that space tractably. So what we identified was that there's actually a much smaller subspace here that is tractable to learn. So what we do is we identify a latent discretization of that search space. Think of this roughly as learning topics rather than words. So we're learning a policy over the kinds of things that are answerable and people are interested in answering. Once we identify that, we can use a decoder to essentially, in a deterministic way, generate a question about that. So the image is fed in, produces some set of image features. Our encoder then maps that onto essentially a set of activations in this latent intermediate space, which then our decoder can take and use to ask a question about it. What we can do, when we do this, we find that, of course, yes, now the action space is much smaller, making the learning tractable, and that in this space of getting feedback, we actually start to succeed. So here's some examples. Our bot has been live on Instagram for about a year. It's gathered over 100,000 responses from people. And you can see the kinds of questions it starts to ask and the kinds of new information it's learning. What kind of bird of this? It gets a very fine-grained category, a white-winged swallow. Or is the horse running? It's a colt, it just goes. What's the food on the plate made of? Octopus with boiled potatoes, olive oil, and it's a Spanish dish. Information that we never originally asked for, but they volunteered to us. Or is this a boat? No, it's a yacht. And in fact, we get all sorts of different kinds of responses about various attributes, things about the historical information of the area, personal information about the individual if they want to share it, detailed information about that food. This all despite the fact that this bot self-identifies as a bot. It says, hey, I'm a bot, I'm a research project at Stanford, in its profile. And you can see some examples here of positive engagement signals where people will reply informatively, negative engagement signals where they're just like, what are you talking about? Because the system obviously occasionally makes mistakes. A few things to note. The blue dotted line here is if we just ask people to, if we say we want to learn about this, write up a question, and they do. So it's about 37% response rate if we post those questions. And now you can ask what different policies would get us. If we're only trying to optimize for engagement, this would be basically the fallacy of most social media platforms today. You end up with things that are that do get responses, but as I'll show in a moment, aren't actually very helpful to the AI. Likewise, if you're only trying to prioritize knowledge, that is to train the AI something, which again is probably what the AI is most directly trying to do, but people may not be interested in answering it, then your response rate plummets. But you can actually, by combining this, actually get pretty much a taste great, less filling kind of solution here, where you get most of the response rate of an engagement-only solution with, as I'll demonstrate in a moment, most of the learning from the other alternative. Just to give you a sense of how these different policies generate different kinds of questions. So top left here is an image. It's a picture that was posted to Instagram, and you can see in these four examples what the different models would ask about it. So, for example, if you're just interested in engagement, you might ask, what's the person doing? If you're only interested in knowledge, you might say, what breed is the animal on the right? Really natural. And if you're trying to combine them, you end up with something like, what's the animal on the right doing? Likewise, on the bottom, you might say something like, what's the child holding? Which is really engaging, but doesn't actually help the system at all. What colors are in the picture would be something that the algorithm actually needs to learn, but people get confused and don't really want to answer that question. It's not really well framed. And then again, something that combines the two ends up being more like, what's the child looking at? Just very briefly, I want to mention that we basically draw on a transformer architecture in order to parse the responses. I don't want to get too much into detail here, but you can imagine that once we get this free-form text, we have to actually guarantee that this can be parsed out in a way that our algorithm can learn from it. And this slide is basically just trying to make the case that, for the most part, we can. And in fact, when we take those answers and we put it back into the data set and try to retrain on our own task, performance improves. So we're comparing here to what's called a VQA data set. That's a visual question answering. So this is a data set in computer vision where you have pictures and questions and you're trying to actually generate the answer. So one thing to note is that our system here is called ELIA. The orange line on the left half is on top, meaning if you're training on our data set and you're testing on our data set, you do much better than if you're training on a sort of standard data set. And what that means is that conversations on social media are different than the kinds of things that Turkers create when you pay them to answer questions. But on the right-hand side is actually something that's another interesting story, which is that if you're trying to train on VQA and test on VQA, you do pretty well. That's the blue line on top. But we can take the data that's completely sort of volunteer contributed and start to actually approach the quality of this very expensive data set just by asking people questions about their images on Instagram. So, just to sort of pull this back together, we've been developing further refinements of this that can target the question more specifically if you want to be able to ask about materials or spatial relationships or shapes or location and so on. But I think what I would hope that you take away from this are two things. One, that we believe it's actually within reach to start to teach these conversational agents to have more open world conversations. That through feedback from the individuals who they're talking with, like if Joe Fish shakes his head at me or smiles at me, the system can actually start to make progress now on this very, very hard learning problem about learning from that data. And second, I hope you'll take away that it's really important when doing this to build into the model some understanding of people's reactions to the things that are happening. And that's really key to making this work. Being completely honest, if we had just taken sort of paid annotators and asked them to generate this kind of stuff, we never would have learned sort of Instagram social norms. But by doing it this way, we actually started to adapt to the domain. So I'll stop there. Thanks very much.
how did you bootstrap the system? Like, where did you start?
Yeah, so how do we bootstrap the system? Basically, for that, we bootstrapped it with, paid annotations. That's where, you need to have a language model from somewhere, and that's where we started. It was essentially I think we fine-tuned a VQA model on our own data. But then once you kick that off, you basically go into this reinforcement learning loop where it's continually retraining. Yeah.
So on the compression that you're doing with the to get the reinforcement learning to work.
Yes.
At what point would reinforcement learning start to work effectively, and where I suppose that's the sweet spot as opposed to continuing to compress where you maybe compressed more than you needed to. So
right.
Did you do a bunch of experiments to kind of find that sweet spot?
So the question is essentially, we reduced the dimensionality, right? Had we gone a little bit wider or a little bit narrower, would that have impacted the outcome? I don't yet have those numbers for you. This project is still happening, and we will look into that. My sense is that the main win was going from a notion of 10 to the 80 to 10 to the 3. These are just like orders of magnitude different.
Yeah, I agree when I saw that was maybe you compressed too much, but
Yeah, so you can imagine that what you're probably getting here is 10 to the 3 different kinds of things it could ask about. Or it's compressing the topic that it's asking about and maybe a bit about the style of how it asks the question.
So you still have a lot of variation in those sort of
Yeah, I suspect you could probably go out another order of magnitude and it would be learnable, but it would require more data. And likewise, you could make it smaller, but then you'd probably you'd have to restrict the domain more, right? You'd want to start with just food pictures on Instagram or just travel pictures. And we've been interested in training in one domain and then trying to migrate it to other ones.
All right, let's thank the speaker.
Thanks.
This completes our user engagement session, and the next session is...
So our first speaker in this session is Joe K from Mozilla, and he will talk about outstanding voice and Mozilla.
Whose phone is this? You're getting unplugged, dude.
All right. I retract my previous statement where I said, all right. Talk among yourselves. Yeah, I was thinking that. I mean, it was just working sitting over there. Tell you what, I'll start and then I'll catch up as we're going along. How about that? Okay, it's 4 o'clock. We've still got about another, 4 talks to go, 5 talks to go towards the end of the day. And everyone's head is filled because there's like a million things that people have said. And it is a credit to James and to Monica that we have such a wide diversity of what I think of as epistemologies, right? Ways of knowing about things, all of which are relevant to the work that is going on around virtual assistants. So what I want to be, for my turn, what I want to do is talk you through some of the work we've been doing at Mozilla over the last couple of years around voice, around assistants, and around what that means as an ecosystem to work in. So as soon as this actually, Wyatt decided to restart at that moment, I don't know. I didn't even upgrade to Catalina. Is it Catalina? What's the new one? Did you just see they released their first, sorry William, wherever you are, they just released their first update, and it has, I think it was 15 different CVMs, like security alerts that they fixed in the fixed to Catalina, and you're like, that's a lot, dude. Okay, let's see if it works. Cross your fingers. I really did prepare. I really did, like, have it ready to go. Maybe. Bodes well. Kind of bodes well. So, at Mozilla, we are interested in open voice, right? We're interested in how we can make sure that there is a way that the innovation that the internet brings to people can continue in new domains. It is becoming apparent, I don't think anybody would be here in this room if they didn't believe that voice work was crucial and that voice was not going to be the key interface for computing in the future, right? You've probably got the same slide lying around that I've got somewhere that claims that 50% of all voice searches will be voice by 2020. I also don't believe that per se, but I think it's a sort of interesting baseline to make sure that we understand. I don't believe the 50% like as a raw number. As a trend, absolutely, right? Voice is a dead cheap and dead good way of interacting with stuff. And what you'll see here when this finishes doing its loading thing, if it feels like that happening, I'm not even going to do the present mode. I just don't trust it today, you know? There we are. What you're going to see is some ways that we've tried to explore that. There's two things that I think are key observations that sometimes get elided in these discussions. The first is that we're in these data-driven economies. It used to be we were in algorithm-driven economies, right? So we would try and come up with a new thing. It was quite simple. All I had to do was hire some scientist on my team, and she just had to be smarter than the scientist on your team, right? Great. That's actually a sort of weirdly democratic way of doing things. And now we have this sort of Matthew's Law thing, in that if we're doing innovation by scraping data, then people who already have that data can create innovation, and people who don't have that data, it's really hard to compete. If you're going to, imagine you're going to start up and you think, oh, I've got a really good idea for doing a self-driving car. It's really hard to compete against existing self-driving cars. So that's this problem with data-driven economies, right? And there are degrees to which that's a valuable and useful thing, but one of the things that we believe at Mozilla is we really want to open up opportunities for there to be more innovation. It's not clear to me that the right way to get the best interfaces is to have, say, 2 large companies or 3 large companies do all the innovation. I really believe that the right way is to have a whole bunch of people do it. And the second thing is this question about keyloggers, right? Imagine if we think that voice is going to replace the keyboard, imagine if every keyboard that was made right now had a keylogger in it and sent it to some large company. That's the situation we're in with voice, and we think there's opportunities to do better. So, let's think about the situation we're in. Those of you who, like me, have been in this world for a while will remember in 2008, Mary Meeker put out a graph in which she said, look, the future is mobile, and everyone sort of waved their hands and panicked. This is putting some numbers on the sort of this rhetorical graph. This is what the world looks like right now. We're at something like, call it 4 billion smartphones out there. PCs seem to be leveling off at about the 350 million, some sort of range like that. We're seeing smart speakers on a track to go to be a more common device than PCs. VR headsets are down there. They're going through a down bit. I want to believe they'll go back up again, but that's what that looks like. But people are concerned. So when we go and ask people their concerns about this, and I think this is a key thing that I would love to see more work on, people are concerned about having these devices in their home. In general, we're seeing, I mean, as you see by that adoption curve on smart speakers, people are generally wanting to have these in their home because it is the best way to do various things. And I'll talk about what those things are people do in a second. It is the best way to set a timer for your pasta that anyone has ever invented. The best way is to say, hey, Alexa, set a timer for my pasta for 10 minutes, right? Great, right? So we see those trade-offs, but I think we're seeing people increasingly concerned about this. And if you look at the techlash, if you look at the fact that I can look at graduate students in computer science on Stanford's campus, and I look at their Twitter bios and it says, "fuck Silicon Valley" in it, right? You've got to be concerned about that. We can't just accept that as normal. We need to take this seriously as something that will impact the future of technology as an industry. So, what are people doing? Are they just setting timers, right? This is some work that was led by a guy called Tawfiq Amari, who is currently on the job market. He's a PhD student at the University of Michigan and a super, super smart dude. It's not the world's prettiest graph, but what we did was to go onto Reddit and we said, hey, will anybody let us look at your data on how you actually use Alexa? And we got about 100 people. And some of my colleagues, Frank Bentley, who some of you might know over at Yahoo, did the same thing with Google Home data. So what you're seeing here is a total of about 250,000 voice commands. People are mainly doing music, right? People are mainly, like it really is, hey Alexa, play Desperado, like it is that. We're seeing search show up there in that mix, and we're seeing, as expected, Google Home does a bit better than search than Alexa does. Notice that IoT is down there. Alexa stuff is about 16%, Google Home is about 10%. We're seeing a lot of mistakes. I believe that number has gone down. This data is a little bit old. But we're sort of 3/4 of the way around the pie, and we've said 3 things, right? We've talked about search, we've talked about music, we've talked about IoT. Volume stuff is really interesting. So you can go and look at this paper. It's in the ACM Digital Library. It's the second most downloaded paper in Tokai right now. I was kind of, I've never had a paper that's been the second most downloaded one in Tokai before. I'm quite proud of that. There's some interesting things like in Alexa, for example, the number of volume down commands is about 5% more than the number of volume up commands, right? Suggesting that Alexa is set at a little bit too high a volume. I love having data like that to deal with. So, given this, what are other ways? This is a log analysis, right? This gives sort of one way of generating understandings and one way of generating knowledge in the world. What are other ones? We do a lot of surveys, and we do surveys in a whole bunch of different ways. And I picked this slide because it tells you sort of, this was one particular survey asking how people wanted to listen to things on the web. Notice that we're trying 3 different conditions. So those are sort of 3 questions that we ask. We're doing things on Reddit. We're doing things on SurveyMonkey. And what this looks like is, if someone opens up their browser, see this thing up here? This is the cue for the people in the back of the room to tell me to go back to the microphone. But if you see that little drop down there, we can do survey work in Firefox at enormous scale, and it's great to sort of see the sort of answers that we get out of that. We can do it in multiple languages as well. So we tried doing this snippet in the US, in Germany, and in France. And we found things like, you know, where did people want to listen to things? Where did they want to listen to stuff? And why were they listening? Why were they listening to information? And the key thing about listening is you can do it while your hands are doing other things. And I know that's like a completely obvious point. Of course that's why people listen to things, right? Of course that's why they listen to music on their speakers. Of course it's why they listen to the radio when they're doing the washing up. But this idea that this is a core thing about listening. Do any of you use Pocket? Anybody? Right? Some of you use Pocket. It's a great way. You come across an article on the web, you say, this is interesting, I'd like to read it later. You click a button and it goes into your Pocket and you can read it later. You can also listen to it later. So my team put together a system. We're currently using the Alexa voices for that. And so you can sit there and it can play all the articles that you came across yesterday that you're like, I should get around to doing. And we found that people want to do it in this multitasking kind of way. I'm going to talk about 2 more things and then a wrap-up, finish-up thing. This question of why do people listen, I think, is actually sort of fundamental. So we did a bunch of field work last summer. We took a couple of interns to Europe. Both I and my lead researcher, Janice Tsai, took our whole families with us. And we basically spent a month going around Europe telling our children to stop complaining. We did a whole bunch of field work. In every city we were in, we did 4 different interviews in people's homes. We did workshops in each one of these places where we invited usually 4 or 5 people to come and sit in a room and tell us about their listening. It was super fun, but we learned these 3 core things, and I think these are sort of fundamental to the human existence, which is why I bothered to put this extra slide in here. One is that people listen to the things that it identify with, right? I listen to British comedy podcasts, right? And people say, would you like to listen to this work-related podcast? And I say rude words back at them, because I don't want to listen to a work-related podcast. I spend enough time at work. When I'm listening to podcasts, it reinforces my identity as a British person with a sense of humor, right? That's what I'm listening to. The second is we work around known constraints, and we saw this everywhere, and we sort of forget this, particularly in Silicon Valley, where we have access to large, expensive telephones, where we have basically ubiquitous internet. But every time we saw people, they would say, well, I'm running out of space on my phone, so I download the podcast and then I delete the ones I've been doing before. I know that when I get on the tube in London, I can't actually get to anything, but it turns out that the tube, the underground in Hamburg has much better internet, so it's fine there. I'm concerned about battery life, and so I'll have a separate device that I only use for podcasts, because that way when I come home at the end of the day, my phone is tired. So people work around constraints. And the third thing they do is they support their existing routines. People don't just listen at some random time. They listen when it's the right time to listen. They'll listen, the people in Hamburg, is anyone from Hamburg? Anyone Germans here? In Hamburg, the way that you know you are a hamburger, I think it is. Doesn't sound right. The way you know you're a hamburger is you listen to the 6 o'clock news. This is what everyone does, right? And they were like, well, it's very important about being German, right? And I was like, this is fascinating. This is, again, sort of reinforces that identity, and they have this routine. These are not always routines that are fixed in time. It's not that I commute between 8 and 8:30. Breastfeeding was one that came up. Like, mothers would say, yeah, I know that the breastfeeding is going to happen. I'm going to sit there maybe 20 minutes, maybe half an hour, but my hands are going to be busy. I need to have something to listen to during that routine. All right, I want to talk about one more research project, which is evaluating text-to-speech quality, because I think this is one of the core things that are part of voice user interfaces. You were saying that you'd been using the Mycroft voices, and we'll talk about why that might not be the best project moving forward. But the big thing is, if you look at conferences like Interspeech, like in general, you look at the speech world on this, they don't do a lot of long-term listening. They do a lot of short sentences. There's a lot of work. Larry, you probably know this stuff a lot better than I do. There's a lot of short-term things that are like, listen to one sentence, listen to one paragraph. So we picked one particular article. It's called How to Reduce Your Stress in 5 Minutes a Day. I think my whole team can just repeat it like with our eyes closed now. And we would take all these different robot voices and have them read the article, and then we get 50 people on Mechanical Turk to listen to it and rate it on various things. So we would say, is this a voice you'd like to listen to? Do you want to hear this again? How highly would you rate it? We tested, approximately speaking, all the voices. I mean, this is obviously not true. We tested a wide variety of voices across different providers, including some humans. Myself, people on my team, our intern, Julia, and we also have a control of reading the text. And there's a whole bunch of data here, and I feel like this is sort of very typical in the talk. You put up a very dense slide that's got writing too small to read on and then run away. But I will point out some things. So the orange circles here, these are humans. This is me. I'm currently winning our team contest on this. Yes. But I think it's mainly because we're testing on Americans. Americans like British accents. Notice that my colleague Janice is down there. And Janice has I mean, if she was here, you wouldn't be like, oh my God, she sounds weird and horrible to listen to. She doesn't at all. She has a perfectly reasonable speaking voice. But all of those ones in the middle are voices that are uncomparable or better to human quality, right? That's the stage we're at with text-to-speech. We're getting voices, at least in English, that are as good as humans, and I think that's fascinating. The blue one there is just reading it yourself, right? If you just read it and we've got that as a sort of baseline. And we had to modify the question a little bit, but that sort of idea of how you generate data is really crucial. Up there, the new Poly voices from Amazon, good job there. The newscaster voice is doing pretty well. There's a bunch of the Mozilla voices that I'm actually pleased to see our new systems are doing pretty well there. Notice the ones down the far end, Mycroft. The default iOS voice is not good. That's the second worst one over there. And the default Android voice, so there's no, mobile phones have lousy voices right now, and I think there's a lot of opportunity for improvement. Okay, I'm going to give myself one more minute. There are three areas where I think we need to see this growth, and I think the people in this room are likely the right people to see that happen. One is getting better at doing consumer voice products, right? How can we build things that have privacy and security built in? Because I think this is the direction that we're seeing society go, and it's the direction that I think we want to see society grow. Those of you who were at the HCI AI conference on Monday and Tuesday, there's this world in which there are a set of values about the way that we think the world should be, and those can be encapsulated in the way that we design these interfaces. It is important to design with privacy, with security first. The same is true with developer tools, moving towards the sort of offline stuff, federated learning, ways in which we can get away from the fact that voice interfaces are a keylogger. I don't think any of us in this room are happy about that. It's a sort of inevitable consequence of some of the decisions we've made, but there's opportunity there. And the third is thinking about what open voice stack coalitions look like around technology, around opportunities to move forward, around legal threats, because I assure you there will be legal threats and they will be coming pretty soon, both in the US and in the EU. And I think we need to be able to have a coherent way to respond to that. And if right now there is not that coherent way to respond to it, and I think we need to have that, particularly with political changes that we're seeing on the horizon. Okay, I want to do one more thing, which is to enlist all of your help. In my copious free time, I run the Mozilla Research Grant Program. And this is not quite the same scale as the effort that you have at Sloan, kind of off by a few orders of magnitude, I think. But we try and get twice a year we put out some questions that we think are really crucial. One of the things I think is really interesting is how often you're seeing, of our 7 questions here, 5 of them I think are directly relevant to the work that's going on in this room. So if you see something here that's interesting, please look me up on Twitter because they're all on there. And if there's people that you know, academics, researchers, people at non-profit institutes who are doing interesting work that answer these sort of questions about surveillance, about different cultures, cultural attitudes to privacy and security. And I'm going to leave you with this last one, which is thinking if we get to this open voice ecosystem, if we succeed with what we're trying to do here, what are the kind of cultural and social and political impacts we can imagine? What are the things that we're not thinking about right now that might have impact around having this kind of technology out there in the world? And I think having those sort of questions forefront in our minds are really important. All right, I'm going to stop talking. Thank you all very much.
Questions? Can take one?
That's okay. I won't take it personally.
Okay. Next up, we have Rob Chambers from Microsoft, and he will talk about the Proprietary speech techniques.
We have yeah, I need mini display.
Schema? This
No,
is just...
this is a mini display port.
Oh.
Man, how times have changed. Apple dongles are there. Microsoft ones are not. Oh, okay. It used to be that like every Microsoft laptop like work.
If anyone needs to connect a Nokia N95 to a fax machine, he's got one of those. It's all right.
Seriously.
All right. Okay, so in case I happen to wander away from the microphone, I thought it might be fun to demonstrate actual speech recognition while we're doing it. This is my way of doing a demonstration without actually doing a demonstration. Okay, so I'm here to talk to you about democratizing speech, both technologies and experiences. And it's important to look at both of those because sometimes we'll look at the technologies, but we won't actually look at the experiences. I see this as a great trick because you're going to follow along. Okay, so, well, I could turn that on, but what we need to do is we need to really understand, what does democratization really mean? It means a lot of different things to different people, but the dictionary says that it means to make something accessible to everyone. Well, then we need to try to understand what is something and what is everyone, because I think we get this wrong a lot of the time. We might also want to talk about what natural means, because that's what we're trying to build, natural experiences. So let's start with everyone. What does it really mean? Well, it doesn't mean all developers. And so we could be focusing on, getting skill developers or capsule developers or API consumer users to use our capabilities in our systems. But that's not really where we're trying to focus. We have to start with everyone, and that's everyone that wants to use these systems. If it's not developers, it's really about consumers and business workers and students and adults and children and my country and your country and the whole planet. Each one of you are one of 8 billion people that have an idea or a desire or a question that you want to do something with. You want some kind of action to happen, and that's what we're trying to solve here, is actually getting you between that idea or problem and your solution. So let's take an example of search. When you try to do a web search today, you type some keywords in, you hit enter, what happens? Well, first of all, did you do the search or did the search engine do the search? That's an important question because it's the difference between, are there actors and directors in this, the actor being the search engine and me being the director, or was it really that you were trying to do that search? And I think that's a fundamental difference when we think about what assistants are. We often place too much emphasis on the assistant itself and not on the empowerment of the people that are trying to get the tasks done. The system will become natural when the actors and the directors all collapse into a single user and the interface fades away, it disappears. Is it really natural to work through intermediaries? It's not, no. It's natural to act as yourself and not think about the tools and technologies that you're using. It makes you self-conscious otherwise. So if that's true, sorry, duplicate slide, it really is about you. And so you can see this example with tennis. I was having a conversation earlier this morning, so I took the example. When you play tennis, I don't, we have a great tennis player over here, the racket disappears. It's not a racket. You are playing tennis. You are right there. If you're a soccer professional, your cleats are the things that really kick the ball with your foot, but you don't think about the cleats. The cleats are gone. But we think maybe a little too much about the agents themselves and what they're doing. And we need to make that fade away for the experiences to take over. So what about natural? What does that really mean? Well, it comes from the word nature, obviously. And so nature, things are natural because sometimes they're innate. Like you just knew this when you came out. But sometimes they're learned. Let's consider a non-linguistic example like opening a door. Well, you can open a car door. You can open a door to a house. You can open a movie theater door when you're exiting. Those are 3 very different ways of opening doors. One you twist, one you push on, one you pull a handle on. But would you consider them as being natural? Anybody? Well, they are, and they are because that's what we all know, because we've learned those things. So natural is a point of context in time. It's a point of what the environment has taught you, what you know. So how does that actually happen? Well, part of that is de facto standards. Those door knobs and handles and other things have been there forever. They're de facto standards. There might actually be some ISO standards, I don't really know. There probably are, but they weren't that way initially. And so another way to do it is actually intentionally with standards efforts. And so the work that we're talking about here really is both the de facto aspect and the actual intentional effort of creating standards. Now, those standards are both from a technical standpoint as well as from an experiential standpoint, and we need to remember that. The ISO standard might talk about how those doorknobs are supposed to work and tolerances and things like that, but there's an experiential aspect to it that we haven't standardized in our industry. And I'm going to talk about a couple examples of that. So first, let's look at human computing interactions. Keyboarding became natural. Who here believes that a QWERTY keyboard is anything like natural? But yet it's the winner, right? Why? Well, it's because it was ubiquitous. It was because it was the thing everybody used. It started out because you couldn't type on a typewriter and it would jam up. And so that design turned in intentionally makes you slow at typing, but yet we all do that every day, which is awesome because that's why you should use voice, because QWERTY's terrible. And so it's either innately natural or it's learned. Sometimes that happens. Language is innately natural. Voice is innately natural. Vision is innately natural. We should embrace those things and understand how humans interact and then try to replicate that in the actual systems that we're building. So, well, let's look at language a little. Let's look at language specifically. It doesn't necessarily mean complex language patterns. If I'm trying to go someplace, I'm probably not going to say very long, complicated sentences. I'm going to say things that you all know what I'm talking about. If I walk up to a ticketing agent, I'm probably not going to say my whole life story. They're probably going to ask me a simple question, and I'm going to say, to Seattle, right? That's all I'm going to say, and they understand from the context what's actually happening. That's based in things like Grice's maxim of quantity. You don't say too much, you don't say not enough, you say just the right amount. I've got a quick story to tell you. One time I was in my car and I was taking my kids. I have 4 kids. They play soccer, not tennis. Well, actually, that's not true. My oldest just played tennis. But we were driving and I had to take them to soccer practice. And I got about a mile away from the house and I realized, because I was thinking way too much about things like this that we do and not very much about where I was supposed to drive them. And I had to think, well, am I driving to this field or am I driving to this other field? So I placed a call, obviously with voice, on my car to my wife. And this is what she said before I said anything. Field 4. And I'm like, thanks. And and then I'm on my way to field 4 because she knew from the context that natural interaction didn't take anything from me at all other than ringing my wife up. And she knew what it meant, right? That's important to consider when we're building these assistants. What is the context that you need to have? What is the situational awareness that our assistants really need to take advantage of? Okay, so let's talk about conversation. The word conversation itself is a bit interesting. Do you really want to have a conversation with your light switch? Show of hands. Okay, that's fine. I appreciate your bravery and honesty. The reality is I don't think we do, for the most part. We just want to do things. We want things to happen. We don't want something to do it. We want to make it happen. We want it to be completed. I think we're leaking some of our implementation details into our experiences. We have conversations there because we don't understand the context. We have conversations there because we don't understand all of what the user is saying in their words or their meanings or their colloquialisms. And that's really important for us to get right. But we don't focus on that enough. If we're going to build an open ecosystem here, these are kind of some of the challenges I believe we need to focus on. We need to strive for soccer field 4 kind of experiences and not the I can say 27 words and you get the 3 words that were the most important. Also about assistants, if you look at what we're building, the assistant companies and the teams that build them, they have a bunch of ideas. Those graphs were from Joyfish, great. Everybody's doing the same thing. Why aren't they doing more things than that? It's because I only play music so much. I only set so many timers. I only ask about the weather so many times a day. I only ... for the 100 things. When you look at the next 1,000 things, we're all different. And we haven't helped the users get there. We have a big crutch on the developer community, and we're trying to have them build up the rest of the capabilities. But we're missing something really important. really, really important. What is that? Well, it's probably not just about these big leaps of capability. Like, I want to say something and have 20 things happen. I want to be able to say things and get little tiny things to happen, I think. Because, I want to really be able to be empowered to use voice all day long for all of the things that are important to me, for the things that voice is the best at. It's not going to be great for touching up photos, maybe. I don't want to move by pixels, but I might want to tell it, objects and different things I want to adjust in the picture, right? We also are trapping our users inside these assistant experiences, right? We've got applications that do calendaring, and we've got applications that do email, and we've got applications that do social media, and then we have assistants that are trying to duplicate all of those things. It's a race, and I don't think the assistants will keep up. I think that all of these capabilities in these other places are going to have more capability. They're going to be able to do more things. And so when we tack voice outside of those experiences, I think it's useful. It's very useful. But I don't think it's enough. There's an analogy I'll play here. So this morning, actually yesterday, I flew down to California. But interestingly, the airplane didn't pick me up at my house. I had to drive to the airport, unfortunately. It was easy to do. It was 6 a.m. in the morning. But I didn't get into my car when I rolled out of bed. I walked from my bed to do things, and then I eventually walked to my car, and then I drove to the airport. There are more elemental actions that we do that we're not enabling people to do. We're building airplanes and we're building flight systems from major hubs in the world, and we're helping people fly. You only fly so much. There's all of the other transportation. What is the biggest mode of transportation used by humans in time? You walk, right? What are you doing with a PC or with a phone most of the time? Well, you're not doing those 100 things that we had on the board there. Otherwise, we'd have a lot more usage in the industry. We're missing out on some of these elemental actions. When you say something to an assistant and you're trapped there, you're trapped. I liked some of the things very much that Larry showed this morning. Right? He showed not just the teaching part. That was cool, and I love that. But even before we get there, there are some simple things. How about scroll down? Right? How many times have you said something that you're a little bit too far away from your voice experience and you're like, I have to walk over to the, right? Well, it happens to me quite a lot, and it's really frustrating, and I'm lazy, and I really don't want to walk over there. I really want to be able to do everything all the time, no matter what it is, and I want to be able to do the big things like fly to California, but I want to be able to walk to my dresser as well. And if we focus on, I think, some of those things, we'll see an uptake everywhere because people won't feel trapped. They won't feel like it's a boxing experience of I can only do this thing, and then, well, if I can't do all of it, why am I going to do this one thing at all, right? So as an industry, I think we need to focus on the elemental. The shortcuts are really awesome. They take you very far distances, but the airplane's never going to pick me up at my house. And so democratization, what does it really mean? It really means we have to focus on the users. What do the users want to do? Big tasks, lots of big tasks, and all the little tasks. And how does it all fit together? In the context in which they are. Probably more in their apps and more in the experiences. Sure, have separate experiences that are fantastic, but we're sort of missing that sort of multimodal. I think a lot of people are thinking multimodal means in your assistant. I don't think that's what that means. I think it means in the world, wherever they are. I'm outside of my car, I'm inside of my car, I'm wearing some AR device, I've got a mobile phone, I've got, like, where I am is where I am, and that's where I want to be when I'm doing the things. So, I think that's about it. Thank you very much. That was 14 minutes and 30 seconds, so I can do one question. Anybody? Anybody? All right.
Let's thank our speaker again.
Thank you.
Next we have Jackie Young, my labmate, and he will talk about how he talked to his light switches.
Exactly. I guess it's fine. I can keep up for
10 minutes. All right. So. Is this the correct cable? Oh, here we go. All right, so hi everyone, I'm Jack Young from Stanford University. I'm a fourth-year PhD student working with James and Monica, and I'm here to talk about multimodal interaction with smart appliances and smartphones. So it's actually basically two projects. So the first project is about talking with smart appliances, switches, with only a microphone array. And the second one is about talking with smartphone for switching between apps. So let's start with the first one. How do we talk with why do we want to talk with smart appliances? So this is my home in China, and I spent a lot of time last holiday season to configure every single one of those lights to be a smart light, and then I put a bunch of HomePods so that my parents can interact with it. But their biggest concern is how do they remember what's the name of each one of those lights? It's weird, right? Like, you can call maybe one of them ceiling lights, but do you call one of them like left wall light or something? This is actually what I do in my home. I sort of remember them, but like it's really hard, and it's definitely not for everyone. The question is, how do we refer to each one of them? And so my idea is basically just talk to appliances, talk to your switches. If you if the switch is another person, you can just talk to him, and he will know you are talking to him instead of anyone else. So why don't we just talk to him? So this is basically the project. Let's see if the sound works. Turn on this light. So see, I'm talking to the light, and I say turn on this light, and the light I was talking towards will turn on. All of this is done only with a microphone array, which is similar. That is a similar microphone array that is embedded in all of the smart speakers that you have at home. So let's see how do we achieve this. This is what the microphone array receives. Basically, it's raw audio data. Actually, a lot of audio data because it has multiple microphones. Traditionally, they was used to do something like beamforming so that they can be aligned together to amplify the strength of the signal to noise. But the thing is, with this alignment, they just dump out all the alignment and details in individual soundtracks. So on the other hand, what we are doing is we feed this raw audio into a neural network, and then we output the head position and orientation of the user. So this seems really simple. Why doesn't the prior work just do this, right? Why doesn't every industry people is doing this? So we go through a bunch of related works, and then it seems like their model is not accurate enough. For example, the best model we can find is 0.5 meters in positional error, and the 44 degrees is achieved with multiple microphone arrays, not even one microphone array. And the only process short input, while their results shows longer input will have better accuracy, but longer input also increase latency. And their model usually only outputs either position or rotation, and obviously multitask learning is really beneficial, so like a better model should try to produce both, and then like it's beneficial for both of them if we train for both of them. And the reason behind all of this is because there's lack of data. There's very little data of you both have the microphone array data and the precise position and direction of the user. The best prior work only have 900 seconds of hand label data. So the question came down to how do we collect data? And prior work basically they collect the raw audio using a microphone array, that's pretty obvious, and then they collect head position and orientation by a hand labeled data. So they have a video camera and then they hand label data using Mechanical Turk or something. This is time consuming and really inaccurate. So what Santander do is we basically use a VR data collection pipeline. What we do is we build a VR application that guides the user to move around in a room in a very evenly distributed way. And then we use, similarly, we use a microphone array to collect raw audio. And then we use, since VR has way better accuracy in terms of head tracking, we just use that as a ground truth. And this is kind of how it works. So the VR application shows a triangle, which you are trying to align yourself with that triangle, and then that will guide you to a different position. And this is me doing the data collection. We can do this like for 30 minutes and so, and then we keep on having the very accurate positional tracking data throughout that time. So eventually we collect 751 minutes of training data, which is 50 times the prior work. This is only with 3 months of me working on this project. So you can imagine if this in like an industry setting, you can collect way more data than like any prior work and get even better model. So our machine learning model looks like this. This is similar to prior work. We have a few layers of convolutional neural network to process the raw signal. And with this, you can only get pretty poor result. As I said, like a convolutional neural network can only have limited input. So like the input is limited to a certain length. And we want to extend it to arbitrary length, so we append the LSTM after that. Basically, this LSTM layer is processing the data from this current input and also from all the prior input, basically using that to make the signal a little bit more stable. And also, our model output both position, orientation, and also we add an extra thing called confidence, because we find out during different part of our speech, our accuracy is actually a little bit different. So we make our model output a confidence so that it will output higher confidence when you are speaking something that make it that the system think I definitely know where you are, and sometimes when the system doesn't really know where you are, it will output a little bit lower confidence. So that after you speak a certain command, we can do a weighted average to get the most accurate result. And this is kind of how it works in life. So the right part shows the prediction result of the model. You can see the position and also the direction of the output. And by the way, this is actually like a worst case kind of for our system, because I'm exactly facing towards the other direction of the smartphone array. The system actually performs a little bit better if I'm speaking towards the smartphone array. The reason I do that is just because I can show myself and the smartphone array at the same time. So you see, it's almost like I can get 100% at turning on the light, kind of. This is basically 5 lights in a room. And we can get average position accuracy around 0.3 meters and average rotational accuracy to 33 degrees. Okay, yeah, so next up, let's talk about smartphone. My other project, this is an ongoing project, so it's pretty experimental. With smartphone, I think one of the biggest problems we identify is context switching. So for example, in this case, I am texting another person about my mom's phone number because I want my mom to be able to pick up that person. So usually what do we do? Like, I don't remember my mom's exact phone number. I let my phone remember it. So what I do is I will open my contact app, search for my mom, copy her phone address, switch back to this email client, and then paste it there, right? Or we can use virtual assistant. We ask virtual assistant, what's my mom's phone number, memorize it, and then just put it in the mail client. This is both really weird. Why can't we just let virtual assistant do it? So this is what I imagine we will do it in the future. We tap on the screen and says, insert my mom's phone number here. And virtual assistant just does it for me and put the phone number in the text box. So here what we are basically doing is we ask the virtual assistant to copy information from another app. And we use our finger to specify where we want the information to be put. So this is basically, you naturally describe the information you want, and you don't need to leave the current GUI context. And similarly, you can also get the information in your current app to another app. For example, in this case, my friends text me an address, and I just want to know, show me the direction there, or how long does it take to get there? Is the traffic bad there? Or show me a picture around that place, or put that in the notes. There's a bunch of stuff I can do. I don't want to do them manually. I just want, because the information is already there, I just want to specify that I want to execute a certain voice command with that information on screen, right? So it's actually really easy to implement in Almond. So the harder part is actually in the accessibility API. I need to figure out a way to get the information from the screen, or actually manipulate the content on the screen a little bit. But implementing in the Smart Assistant is really easy. We just, I basically add 2 constructs into ThingTalk. One of them basically get a selection on the screen, get the information that I selected on the screen. The other one allows me to output information. So Almond will, after a command is executed, it will give me some result. And then the second command allow me to put that result back onto the screen. And we use Accessibility API on Android to acquire and change user content. Without further ado, let's start a demo. So here, my friend is asking me to go to a dinner sometime. So, well, I'm staying with my mom, but I don't actually remember my mom's exact address. So what should I do?
Almond. Insert.
So I click on the text box,
here.
and then I say insert my mom's address here. And then it populates my address and my mom's address and put it there. So I can just send, and then it will be sent. She lives at 425 Grand Avenue, Palo Alto. Well, this is just for exemplary reasons. Don't go to that address. And yeah, so now my friend says, I know a place nearby, and this is the restaurant. I don't know how to pronounce that name, right? And I still want to know whether that's a good restaurant. Never heard of it. So what should I do? Should I copy it and go to Yelp? Well, there's an easier way.
Almond. What is the rating of this restaurant?
La Bodeguita del Medio is a 4-star restaurant.
Well, here we go. Well, this is not good enough for my standard. Let's go to the best place in Palo Alto. Well, should I go to Yelp again and search for the best place? Well, why don't we just do this?
Almond.
I tap on the text box again to indicate where do I want to insert it.
In Palo Alto, here.
By the way, those are like the latest feature that Slade just talked about in this morning, which is querying a database. And pretty easy, right? So this is how virtual assistant with multimodal interaction can facilitate our everyday life with a smartphone. So that's all, and I'm happy to take any question.
What was the hardest part about building the demo?
Which one?
The hardest part about orchestrating the demo?
The demo previously? We have some trouble training both of my constructs, and they're like basically the language model part is kind of weird because I think it depends on tuning because I build myself separately and he built himself separately, and it's really hard to merge them together. Yeah, but otherwise, yeah. And actually, I want to talk about the other thing, which is the first demo, which is the talk to a smart appliances demo. The hardest part is actually get the voice to text working. We're using Google's voice to text, but it doesn't work very well. Maybe I should try the Microsoft one. All right. Yeah.
All right, let's send our speaker again. So last session, by the way. So it has been a long day. So now we have Conversation from Google talking about conversational AI on Edge.
Perfect. Well, hello everyone. It's such a great pleasure to be here. There are many interesting things that I could talk about, but today I decided to pick one of the biggest challenges we've been tackling for the past couple of years. And the whole point is we're trying to build conversational AI that lives literally on your devices, whether it's your smartwatch or your phone. And I'm going to share all the challenges as well as the advances that we have made so far. So as you know, we live in this golden age of deep learning and everything happening on cloud. And while this is so impressive, the interesting part is we carry our watches and our phones all the time. And most of the time, users just say well, I'm very worried about the privacy, sending my data up to the cloud. And that made us think of, okay, maybe we should start becoming more creative and think, how can we bring on those small, tiny devices the same high quality of models, make sure that users have consistent experiences. And that's how our work started. It literally stems for these 4 principles. Like the first one is user privacy. As I say, like users enjoy our latest features, but every time they hear, well, data is shipped somewhere to cloud, they get very wary about like what's happening to my data. Number 2 is like we have limited connectivity. Even if you go on a hike, you don't have access to the internet all the time and connection is not good, but you still want to call your assistant and you still want to get same functionalities. Third important thing is efficient computing. So we can build complex models and we can't make like them last forever until the user gets a reply. So then the question is like, can we make those models small, very fast, very efficient, at high accuracy? And the 4 most important thing is consistent user experience. There is no user that wants to ask a question and get 5 different replies or interactions. So we have to make sure when we build, all of these constraints are satisfied. So to make sure that all people are on the same page, I'm going to give an example. Just like I was saying to Rob, there are people who love talking to their devices. And I'm one of those. At home, everything is connected. Literally, the moment I open the door, the first command I execute every single day is turn on my living room lights. And what happens typically for all applications that are built on the cloud is we ship those commands to the cloud, we do all the intent understanding, we extract all the entities, we do the fulfillment, then we send back the command, and the command gets executed. But if you think about it and you do this every single day, multiple times a day, you're going to see that there is a delay, yes? So what is the solution? Typically, user gets very impatient and just opens the app and just clicks a button, problem solved. I don't need to execute that voice command. But the way that we can actually overcome that is, well, we can build on-device models that are fast. And literally, you can put the intelligence in any device. You can talk to your microwaves, you can talk to your smart plugs, and to be honest, I love that. And I do believe that we are very close to getting there. But in addition to making the intent understanding and the entities on the device, you can get even more creative. You can start having generative models that can come and say, reply to your incoming text message, like how is it going? You can do all of those technologies and make them live on those tiny devices. So what are the challenges? There's like tons of challenges that we have to think about tiny devices. But first is like hardware constraint. So we have very, very limited memory. You cannot load like big models. You have to be super energy efficient. You don't want to drain your batteries. You want to make sure that everything is working seamlessly. Number 2 is like no product person is going to let you build and release a product if the quality bar is not met. And if you objectively think on a very, very small, tiny memory, how are you going to build like model that is going to have the same performance as those on the cloud? Number 3, complex architectures for inference. We have to make sure everything like runs very fast. And of course, we have to be able to solve all kinds of problems. So when Sujit and I, Sujit who's here in the audience, we started thinking about this problem, we did see, hey, people have tried it, but somehow, most of the time, it's not successful. One is like either people have said, well, I take all inputs, I hash them with the output category, and problem is solved. But we all know that people are not robots, and they won't remember the commands. So even if you say something, it won't get executed. Other people have actually tried to do very fast sampling. They try to incorporate deep learning models with graph learning, and those are good, but the challenge is that then the models become so bulky that you cannot actually fit them on your watch or on your phone. So then Sujit and I were sitting and thinking, well, we live in the deep learning era. We know all the challenges, what people have tried, but can we combine the best of both worlds, and can we think about brand new neural networks that can be small in size, that can be very efficient, and can reach the state-of-the-art or near state-of-the-art performance. Today, like fast forward 2 years later, it's possible. But when we were starting, actually, that was not the case. So where we are today, well, we have like full-fledged pipelines where you pass data with your input and your desired output. And you literally, what we do is like we have special models, neural network models. We call them self-governing networks. By now we have multiple variations. They're all based on technology we call projection nets. We can train all these models on cloud, and then using TensorFlow Lite, we can ship them on any device, being a watch, being a mobile phone. The good part is like they're easily customizable. You can come and tell us, hey, this is my size requirement. This is how fast I want them. We do everything on the fly, and we customize for any different product, including assistants, spam, ads, and whatnot. So here's an example of like I'm gonna try to keep it very high level so people can understand. But when we take our input, could be a sentence, words, phrases, whole document. What we do is like we very quickly do feature generation. So if you remember, all the current neural networks sit down and use lots of word embeddings, but we cannot load them. You don't have gigabytes of memory to do that. So we do very, very quickly feature extraction. It could be n-grams, skip grams, you decide. And then we try to take all of that and literally put it in hash ID and the count. How many times have we seen that n-gram or that skip gram? So the magic happens in this so-called projection layer. What we are doing is like we're taking all these large vectors of the hashed IDs and the counts. We have a seed vector, we're multiplying them, and we're literally checking, okay, what's the sign between the seed vector and the current sparse vector? If it is positive, we say 1. If it is negative, we say 0. And we generate these bit vectors that are super small, compact, and that allows us to start generating these very powerful networks in small sizes. Once the projection vectors are generated, we do full-fledged, like fully connected layer. And in this case, we do a lot of classification problems. So we do softmax, and we just do the output. So what's the powerful thing about all of these like projection networks? Well, one is like we got rid of all of these embeddings. You don't need to like learn something and then load it. Everything is happening dynamically on the fly. It's computed, you don't have to store anything. The models are, as I say, super efficient. You transform all your inputs into bits, and they actually, what we tested is like they're able to preserve semantic similarity between words, phrases, and even sentences. So what I'm going to show is like, well, how accurate are these models actually? And I'm going to also show about our latency, as well as like various applications. So we started with increasing complexity. So first, we look at dialogue act data, which happens between two people. The idea is like every time somebody says something, let's say about 12 foot in diameter, we have to predict what is the dialogue act. You say statement. So anytime someone speaks, give an input sentence, we produce the output. And we have 42 classes that we have to predict. So we took all of the state-of-the-art and recent literature, and we decided to do a comparison. So we started with the baselines that people have worked since 2000 on those problems, and we see that definitely our model that is on top is doing much better than both the HMM naive-Bayes method. After that, we took and compared it against all of the different neural network models that exist in the literature, and we see that performance is consistent. So that's definitely a positive improvement. So then we decided to get more ambitious. Okay, let's make it challenging. Let's put more people into the conversation and see like what's happening. So these are open conversations that are happening on technical discussion. As you see, some are longer, some are shorter, and the task still remains the same. Somebody says something, you have to predict what is the dialogue act. So consistently, the same people who work on the previous data worked also on this one. And if you see, it's like, it's very consistent, the story with the previous data set for 2 people versus multiple speakers. We improve all the baselines. We improve all over CNNs, RNNs with attention. And one thing that we noticed is like, for this specific data set, we got very close to RNN model of Kanpur. But there were a couple of things. They actually did a lot of pre-training on different data sets, which we didn't have any access to that. And then when we look at the model sizes, our model is like very small. It's like just 300 kilobytes, and there has like millions of parameters. So in terms of like size, ours is model and very comparable performance. Then we started thinking, okay, that's one architecture, is definitely possible, but there are many, many more ways that you can build powerful architectures. So people use both words and character embeddings. Well, can we do the same for on-device problems? And what we did is like, we came up with a hierarchical partition projections. The idea is that you have both the so-called word projections as well as character projections. Each of these can be learned in parallel, and then you can concatenate them and have the same network. So we want to have this like power, joint power of both the word and the character level information. So let's see what happens. The good news is like now we can compare towards our first model, and you can see that, well, the moment I start injecting character information into the network, definitely performance for both of these data sets keeps improving. So we're trending in the right direction. And then we said, okay, we tested these data sets, but we want to learn more things, like can we do intent predictions? So we took all the open data sets. One of them was 80s. Literally the task is somebody says something, we have to figure out what the intent is. And we started doing same comparisons. Majority class baseline comparison, attention RNN, Hakani, like Dilek, who was here in the morning, she was one of the creators for the joint intent and slot prediction models. So if you see, like our SGN and on-device models definitely consistently keep doing and improving over all of those models. When we build applications, we also have to think not only about one language, like English, but we typically have to build for 20 or 100. So then we started looking into, are there any freely available data sets that we can start testing our technology? And we found very nice like customer feedback data set for English, Japanese, French, and Spanish. Literally anything a person says, we need to know, is this a complaint, command, bug, request, and meaningless? And the whole idea for this test was like we wanted to see, well, how is it is to take our technology and plug it for different language. We want to preserve same parameters. We don't want to do anything additional. So the story looks like that, like HGNN is on top. If we look to similarity baselines that are just trying to retrieve topmost similar sentences to the input, we're definitely doing much better. If we look to people who actually engineered a lot of features, use pre-trained embeddings, use sentiment classifier, external knowledge bases and whatnot, definitely our neural networks do better as well. And the model that actually we noticed that we're getting very close is the one of Barbara Planck. And one of the things we kind of touch base with her is like, okay, what's going on here in your model? And she says, well, what I did is like I translated tons of data. I added this data. I trained like multilingual embeddings. I have part of speech tagging information. This is awesome. But we don't want to do that because each of these things, one is going to occupy memory. Two is like you have to have another system that generates part of speech tag, another system that generates translations on the fly. So definitely it's good for server-side application, but maybe not the right way or direction to go for on-device. We digged up everything we built. Actually, we do a lot of ablation studies because we want to know what's happening in the network, what's happening for our models and data sets. One of the things we did is like we actually wanted to compare how impactful is this joint word and character information versus just the word projections. And if you've seen the partition version where you have separate like character as well as like word embedding learning, definitely word and character does better. But the same thing is true if people say that, well, I don't want to have a partition network. I just want to have one network that can learn both of these representation in one shot. The story is very consistent. So that shows you that word and character actually is the right way to go and model. Then we started looking, okay, inside word and character, which is better? Is it better to partition the network or is it better to not partition? So if you see, it's much better to partition in the case of word and character. But the same observation is true also when you just use the words. So partitioning is good. And overall, the conclusion is like, well, the newly designed network, the HGNN++ is much more powerful. It gains like up to 10% improvements. So then we said, well, good. So now we know these models are accurate. They're getting near, if not even better performance than state-of-the-art models. That brings us to problem number 2, which was like, well, what happens with the model size, right? So you have very, very small memory capacity. What we do is like different clients, so-called product orgs, might have different requirements of how much space we have. So we decided to test all different extreme, all the way from a couple of kilobytes to 2.5 megabytes, which is still a very small model. So if you look for the model, like 2.5 megabytes, we get something like 94% accuracy. If you start shrinking the model to just like 100 kilobytes, you get like 82% accuracy, which is definitely very impressive to show that at such small size, you can get such high precision. Then the next thing we said is like, okay, we know that compression algorithms have existed, so can we make it even smaller than what we have? And actually we employed quantization, so Sujit actually has ported all of those models also for learning to compress that people can use open source. And one of the things that we see is like, well, with 100 kilobytes, we get 82, but if you go as low as like 33 kilobytes, you still get like 80% accuracy. And in some in extreme cases in which people just want like 7 kilobyte like space, you can still get like 77% accuracy. So this is like super impressive that with projections and those architectures, you can get such great performances and small sizes. So we check the size, we check the accuracy. Last thing we need to worry about is latency. As I said, nobody wants slow applications in real time. So what we did is like, let's measure latency on pixel device. And what we did is like, we pass input text and we just measure how fast our models are. So if you see accuracy is still very high and they're as fast as 3.3 milliseconds. So just to conclude, we literally laid the foundation for the whole field of how you do NLP on device. We developed like 2 powerful neural networks, and we actually have many more that were published in the past couple of months. The most important part is like, though these models are so compact and the projections are like the vectors are so small, the semantics between the sentences and the meaning is captured. So we did show accuracy improvements, we did show small sizes, and most important part is doing really well on multiple tasking languages. Last is like, we have tons of paper, MNLP, ACL, NACL, and so on that we worked on in the past year, so feel free to read them. And with that, I'll conclude, and thank you so much for inviting me.
Have you guys looked at structured prediction?
Yes. So we have, that's like something we're preparing a paper for ACL 2020, and we have evaluated it on different data sets, both for name entities as well as like all the slot extractions that are coming for the conversational parts. Yeah.
And second, how do the metrics vary with number of labels? So does it come a point? Is there a point of number of labels where on-device models with such small, compact models start performing worse than the bigger models?
I think it depends. So in real scenarios, sometimes, you know, in search and let's say assistant, you might have thousands of labels just to capture the different types of the intents. But then the question is, one is like, how are these labels? Are they super correlated? Do you have enough data to represent them and so on and so forth? So what we have done is like, in some of these papers that I showed you, like we have done even evaluation on like 3 million data sets with a lot of like labels, and I would say like it's capturing also the property of what the data is, because when we take state-of-the-art results, we notice that the behaviors of the algorithms are very consistent with how the rest of the models are, right?
Have you guys done any thinking yet, or maybe some results on how do you personalize and train out personalized models?
No, but actually that is a very good point, because so one of the things we do is like enterprise search, and there is everyone wants personalized things, right? And that's definitely something that I think it's very important to do. Main challenge is like, especially when you publish work and you try to explain to people like, hey, this is what we do, take this data, reproduce result. The biggest challenge is like, where do we find data that is open source, that the whole community later can take it and reproduce, right? So internally, we might have our data and know how to do these things, but the challenge is like, where's that data externally to the community, right? And as you know, it's like many things like spelling correction, like personalized results, all of these like come to play, like how do you generate the replies? So for reply generation, like Sujit has some models, and then we use like human annotators and raters or the people themselves. But as I say, the biggest challenge is if you want to open this to the rest of the world, right, where do we get that data? So I do encourage people, generate data. We have a lot of problems to solve, and I think that's the biggest challenge, right?
Over time, so let's leave other questions offline.
Thank you.
So next we have Chen Guangzhu from Microsoft talking about their research progress in task-oriented dialogue.
Hi everybody, I'm Chen Guangzhu. Very glad to be back since I got my PhD here 4 years ago. I work in a Microsoft Speech and Dialogue Research Group. Today I will talk about our research progress in task-oriented dialogues. Task-oriented dialogue has a relatively long history, dating back to the early 1990s, where we have the early IVR system, like in AT&T, it collects the user's information using speech and then try to transfer them to different departments. And all the way to today, task-oriented dialogue appear in virtual personal assistants, in, say, customer support or virtual agent. So task-oriented dialogue, the goal is always to help the users to accomplish certain tasks using conversation. For task-oriented dialogue, there's a very popular framework which was proposed by Professor Steve Young back in 2000. This is like the user's utterance is in this form of speech, and then after ASR is translated into text, then the red boxes indicate the language NLP parts. The first module is called language understanding or dialogue state tracking. It determines the intent of the users and do sort of slot filling. So basically it projects the user's utterance into semantic frames. And then the dialogue management part determines, okay, what the system should do given the user's intent. Should the system request for API? Should the virtual assistant ask for more information or give some information? And ultimately, the natural language generation translates the generated semantic frame into natural language. And this part is very crucial as it's user-facing. And finally, the TTS part translates that into speech. So our work in task-oriented dialogue is mostly in the red boxes. Today I will talk about our work in the language understanding and also NLG. Language understanding is also known as dialogue state tracking, or DST. As I've said, DST converts users' natural language utterance into semantic frames, also known as slot values. Here there are two types of slot values. First is called Go. Go indicate the category and also the constraints. Like if, say, the user wants to eat American food, so we have the food American to indicate them. The request refers to the information that the user wants. For example, the user may say, can I have the phone number to a certain restaurant? So it's called a request phone. All these slots and values together comprise a thing called ontology. And this is one part of the input to the system. The other part is the dialogue system's previous round's reply, because definitely the system needs to know what I just asked to parse the output of the user. What we found is that previous DST models' architecture sizes are usually dependent on the dialogue slots. So for example, if there are 10 slots, the model size will be approximately 10 times that of a model in which it can only process one slot. So it makes things not that scalable. Therefore, in this year's SIGDA, we propose a slot-independent neural model, which has a model complexity independent of the number of slots. So the size of the model is constant. Here's an overview of the model. The input to the model has three parts: the user utterance, which is has words in it, and ontology. Ontology is just one slot and one value in terms of also the words. And finally, the system action, the system's previous reply. And then we have word embedding, part of speech, and so on, RNN, CNN, to get contextualized embedding. Then we go over the self-attention and then inter-attention between these three parts. Finally, generate scores. This score tells us about the probability that the system predicts how likely this user is talking about, say, food American. And then we use that to determine a slot that should be triggered. So in this way, the model size is independent of the number of slots. If there are 1,000 slots, the model is still of this size. However, definitely there will be 1,000 slots going through this model. So we actually trade time for space. The data sets we use is the benchmark data set called Wizard of Oz and DSTC2. Both are restaurant reservation tasks. So let's look at the result. Here, the result is judged by the accuracy of the predicted slot and value. As you can see, on WAS, our model achieves the new state of the art. And on DSTC2, we have comparable result with the previous state of the art GLAD. And in terms of model size, we achieve the same result using only 1/4 and 1/5 of the model size. This is reasonable because these two data sets have 4 kinds of slots and 5 kinds of slots, respectively. The reason that we can even beat the previous model's accuracy while having a smaller model size is attributed to the fact that by treating all slots together, we're effectively increasing the size of the training data. Whereas if you have one model per slot, then the amount of training data may not be sufficient. Okay, so that's about the DST work. Now, natural language generation. Natural language generation is the final step in NLP part for the task-oriented dialogue. It is very crucial, as I've said, because its output is directly user-facing, so its readability and also informativeness directly impact users' perception on the system. Readability means like, for this generated sentence, does it look like a sentence from human? We want some natural response. Informativeness is we want to express what we want from the semantic frame. If I want to tell the user some information, I have to put that information into my generated response. Existing methods usually struggle to achieve high fluency and variation, and the generated responses are most of the time rigid, because one of the reasons is it focuses too much on the informativeness, like trying to convey the message, but not focus so much on the form of the language used. So in this year's EMNLP, we propose a way to utilize the language model as an unconditional auxiliary task for co-training. The reason we use language model is that it's a natural way to measure how likely the sentence is from a normal human response. So by training that as a second task, we can boost the performance of the system. Here, let's talk about some definition. Meaning representation is the term we use in NLG, but it's exactly the slot value, what that means in the DST. Dialogue acts, or DA, represent types of system actions, because in some rounds, the system wants to inform the user, say, okay, here I know a restaurant in the south of the city, and request is ask for information from the user and confirmation. Response is the desired output. And if we look at the sequence-to-sequence model previously proposed, we notice that there's in a condition, there's an I. The I is the semantic frame, or this meaning representations. So we propose that this strong conditions may bias this generation to be more towards informativeness instead of readability. Therefore, we propose to have the language model as a probability unconditioned on the input. It just focuses on the language used so that it can learn the language pattern. Both tasks share the decoder parameters and use a linear combination for loss. And here's an overview of the model architecture. If you ignore the bottom right part, that is the state-of-the-art model, where you have the input, which is these semantic frames: inform, name, Wi-Fi ES, and price. Notice that these names are kind of anonymized because we just want to, the content of this name doesn't matter so much. This process is called delexicalization in task-oriented dialogue. And on the right side, we want to generate I found something like in the top, and also using attention. Our new contribution is that while training this objective, we also have an unconditioned language model trying to generate the same sentence but without any information from the input. In this way, we can focus on the language pattern. We tested our model on E2E NLG dataset and also RNN NLG. which are benchmark data sets, including retail, hotel booking, restaurant booking. As this is generation, so we use Blue and NIST for evaluation. As you can see, our model achieves better result than previous models, and also with the language model, we can consistently improve the result. One concern may be that we have one more module to train, which is the language model. But it turns out that as the language model doesn't use attention, which is computationally expensive, by using the language model, we only increase the training time per batch by about 20 to 25%. So that's acceptable. And for inference, it's exactly the same as previous models. Here are some examples. So the first line is mini representations, a name, cricketers, and so on. Without language model, the generated response is rather mundane, like the cricketers is a restaurant providing Chinese food in the high price range. It is located in the riverside. It is near All Bar 1, and so on. With the language model, it kinds of form a clause structure, which is more complex and more resembles what people say. And say that, for example, the last one, inform this hotel and the dogs are allowed. Without language model, say, okay, the Kingston Park Hotel allows dogs, but with the language model, it actually generates the ground truth answer in the test data, which is the hotel is a nice place where dogs are allowed. These are more like a human response. Okay, so in this talk, I introduced our work on task-oriented dialogue system, and we focus on the end-to-end learning capability so that we can increase our model's performance given more data. Any questions? Thanks.
And last we have Abigail, who's a PhD student here in Stanford, and she will discuss what makes a good conversation and how controllable attributes affect human judgments.
Hi everyone, thank you for staying here until the end of the day. I know it's been a lot of presentations. So I'm Abby, and I'm going to tell you about some work I did with some co-authors at Facebook AI Research. So when you think about natural language generation tasks, I imagine them as existing on this task spectrum. So on the left, you have tasks which are relatively less open-ended, such as machine translation. And on the right, you have the tasks which are more open-ended, like chit-chat dialogue. So when I say open-ended, I mean that with machine translation, there's only so many ways you can, in a valid way, translate the given sentence. Whereas with dialogue, there is a much, much larger space of things that you could say that would be a valid response. You could also phrase this as saying that on the left, you have tasks which have more kind of low-level, word-level decisions in order to solve the task. Whereas on the right, you really have to do a lot of high-level decisions to make a good choice. So I know that machine translation does indeed have many high-level decisions, but if you do a kind of word-by-word translation, you do have a kind of working baseline. Whereas with story generation or chit-chat dialogue, you really do even just have a working baseline, make some high-level decisions about how you want to respond, what do you want to talk about, or maybe where the story is going. I think you could also say that at least so far, neural language models have been more successful for the tasks on the left than the right. That's partially because the recent seek-to-seek systems that have been successful have been developed for machine translation, and the community is figuring out how to apply them to other more open-ended tasks. But as things stand right now, I think you can say that seek-to-seek style approaches have been more successful for the left tasks than the tasks on the right. I would argue that control is more important for the tasks on the right. So when I say control, I mean the ability to specify some kind of desired attributes of the output text at test time. So for example, you might want to control in a dialogue agent the kinds of things it talks about, or when it decides to ask questions, or when it decides to change the topic, and so on. And similarly, you can imagine in story generation, you might want to control certain aspects of where the story is going, maybe, you know, kind of overview of the plot. Lastly, I think another big difference between the tasks on the left and the right is that, as we know, evaluation is pretty difficult for all natural language generation. And even in machine translation on the left, evaluation is still totally not trivial. So we use blue, but we know that blue is not perfect and might be getting even more kind of insufficient as the models get better. But on the right, it's an even worse situation. Metrics like blue and rouge aren't even really a good baseline, even for the tasks on the right. So eval is super hard for the tasks on the right, and that's partially what this paper is about. So, you know, after saying how hard all of this is, this paper is in fact about chit-chat dialogue. So we're trying to deal with all of those problems on the right. So the research questions of this paper are, we are going to try to control multiple attributes of the generated text. Remember I said that being able to control aspects of the generated text is important, so we're going to try to do that. And then we're going to use humans to evaluate aspects of the conversational quality. So we're trying to see what's the connection between controlling different aspects of the text and how humans perceive the quality of the conversation. So our first research question is, how effectively can we even control these attributes in the first place? And as a preview of the answer, we find that we can actually do that pretty well, at least for the attributes that we try to control. But we did find that different methods work better for different attributes. Our second research question was, how do these controllable attributes affect the quality of the conversation? So again, we found some strong connections here. And in particular, we found that it was very important to control the level of repetition in the generated text, how specific versus generic it was. And we also found that it was important for the quality of the conversation to control our rate of question asking. Our last research question was, ultimately, can we use this kind of low-level control over the text to make a better chatbot overall? And here, preview of the answer is yes, but we should be careful how we define better overall. So I'll come back to these questions later in the talk. So first I'll introduce the task that we were tackling here. The persona chat task and dataset is a chit-chat dialogue dataset that looks something like this. You have two participants who will assume one is a human and one is a bot, and they each are given at the beginning of the chat a persona, which is a short collection of personal attributes. And then the two are supposed to have a kind of getting to know you style chat in these two personas. So this dataset was collected from Turkers who were asked to do this task, and now our job is to try to build a bot that can talk in this setting. So remember I said that we wanted to control several attributes of the generated text. And here are the 4 things that we try to control. So firstly, we want to control the level of repetition, and our main goal here is to try to reduce the level of unnecessary repetition in our bot. Secondly, we want to control the genericness versus the specificness of what we're saying. So when I say genericness, I mean saying things like, oh, that's cool, which are very generic responses that you can say in many different scenarios. Thirdly, we want to control the response relatedness of our utterances. And this is basically how related is what you're saying to what the user just said. So maybe if you're changing the subject, then that means it's not very strongly related to what the user just said. So here, our main goal, our motivation for doing this is we wanted to try to respond more on topic, more based on what the user said, and don't kind of ignore what the user said and change subject unnecessarily. Lastly, we want to control the rate of how often we ask questions in the dialogue. And really here, we're just trying to find out what is the optimal rate of question asking in this task. So we're controlling these attributes of the text, and then we're also asking humans, Turkers, what they thought of the conversation. So we do a pretty fine-grained evaluation here, and we ask them about the 6 aspects of conversation. So we ask about some pretty obvious stuff, like did the bot repeat itself? That's something which we can try to measure automatically, but there's some more kind of subtle types of repetition that aren't as easily measured. So we ask, did the bot repeat itself? Did you find it interesting to talk to? Did it make sense? Did the bot use English naturally? Did the bot seem to be paying attention to what you said? This one's an interesting one, whether the bot was listening, because listening is quite a hard thing to kind of concretely quantify, like what does listening look like? So in any case, we asked Turkers whether they thought that the bot was paying attention. And then lastly, we asked, did the bot ask an appropriate amount of questions? So after all of this, we finally have 2 overall judgments of overall quality. And the 2 we use here are humanness, aka a kind of Turing test. At the end of the conversation, we say, do you think you just spoke to a person or a bot? And they give, certainly a bot, certainly a human, or probably a bot, probably a human. And then we also asked, was the bot enjoyable to talk to? Okay, so that's our evaluation pipeline. Here are these methods that we use to control the output of the generators. So we used 2 existing general purpose control methods, meaning that these are methods that allow you to control any kind of measurable attribute of the text. So our first method for controlling the text was conditional training. This is pretty simple. The idea is that you want to train the model to generate the text Y, conditioned on the input X. So far that's just seek to seek, but you also want to train it to produce the text Y conditioned on the desired output attribute Z. So the idea is that if you say Z says that, I want you to ask a question, please, then the model will learn to produce something which is a question. And then our second method is weighted decoding. This is more of a kind of late intervention. So the idea is during decoding, that is when you're actually generating the text word by word at the end, you want to increase or decrease the probability of generating words with particular features. So the idea here is that, let's say you want to say something that's more generic or more specific, then you might kind of give, upweights or downweights to certain words because they are more rare or more frequent, or whatever it is you want. So those are the 2 methods we use. And here's how we found they were effective or ineffective to control the attributes of the text. So the first one, conditional training, that's when it's trying to learn to produce the text with the desired attribute. We found that this didn't work great for controlling repetition, because the whole idea of conditional training is you need training data that shows the attribute you want to control. So given that repetition is mainly a problem that happens with the models kind of at test time, we didn't really have the repetitive training data that we needed in the data set as it stood. So that didn't work great. And then we also found that, somewhat disappointingly, it didn't seem to be able to learn very well what it meant to kind of change the subject or say something that was very related to what the user just said. However, we did find that it was pretty effective for controlling the specificity versus genericness of the utterance, and then also whether it was a question or not. That was pretty reliable, and I'll show you examples of that in a minute. For the other method we tried, weighted decoding, that's the one where you kind of increase or decrease the probability of certain words at test time. We found that this doesn't work naturally for controlling question asking, because question asking is more of a kind of, sentence level, utterance level attribute, not really a word by word one. But for the other attributes, we found this worked pretty well. So I know this slide's pretty abstract. Let's look at some examples. So here we are trying to control specificity. So in this scenario, the input, that is what the user just said, they said, I'm studying law at the moment. So our baseline model just says, that sounds like a lot of fun, which is kind of okay, but it's not really that specific. It's a bit generic. So here you can see an example of what it looks like when we control the specificity versus the genericness of our response using this weighted decoding. So when we turn up the specificity knob really high, then the whole thing just gets completely broken and we just output all of the rarest words we know, which is just nonsense. And when we turn it down really low, then we say, oh, and a lot of dots, because that's the most generic thing. But I think the thing in yellow is kind of the best one on this slide. That sounds like a lot of fun. How long have you been studying? Which is a bit more specific. So if you can kind of get the knob just right, then maybe you can get something which is better than what the baseline gave. So that was the top one is the weighted decoding method. And then at the bottom, we have the conditional training method. And then similarly here, we're able to get a range from more generic to more specific. So overall, we found that for these 2 methods, the weighted decoding method, that's when you kind of change the word-by-word probabilities. This gives you a very large range with very different extremes, but the output is pretty nonsensical at the 2 extremes, so you have to be quite careful. Whereas with the conditional training method, that's the one where you're training the model to give something with the desired attribute. It has a smaller range, but it's pretty well formed. It's fairly safe at both ends because it's not going to learn something crazy because it was all based on the actual training data, which was reasonable. As another example, we are controlling here the relatedness of what we're saying to what the user said. So in this example, the user said, do you get coffee often? And the baseline said something that wasn't really very related. I do when I'm not playing the piano. That's probably because the piano was in the persona. So here you can see we're controlling how related what we say is to what the user said. So we can say something super unrelated, I'm a musician, or we can turn it up and say something which is supposed to be very related but doesn't really make sense either. So when we turn it up to very related, we say not often, usually with drinks, espresso, latte, tea, etc. So there it's essentially just trying to maximize the reward that we're giving it by writing as many kind of coffee-related words as it can, which clearly isn't right. But I think the middle-ish response, I do, usually at Starbucks, to do you get coffee often, is actually a good response that's more on topic and more related to what the user said. So our second research question was when we change these attributes of our generated text using control, how does that affect the human's evaluation of the quality of the conversation? So to give a high-level kind of summary of what we found that when we reduced the amount of repetition, this had a good effect on pretty much all of the metrics, and that really tells you more about the baseline, that the baseline was way too repetitive. Secondly, we found that when we increase the specificity, so that is make it less generic, make it more kind of a human level of genericness, then we got better scores for interestingness and apparently how much we seemed to be listening, and then it was also more engaging overall. Although we did find that we got slightly worse scores on making sense and speaking English naturally, probably because we were generally taking more risks with what we were saying, therefore sometimes we went wrong. We also tried increasing the response relatedness, that is saying things that are more on topic for what the user said. Interestingly, this didn't actually work out well for increasing any of our human evaluation results. The main losses were that we, again, got worse making sense and fluency scores and then worse overall judgments of quality. I'm not sure exactly why this is. I think it was that, again, kind of saying things that are more related to what the user said means that you have to take more risks. It kind of raises the bar for saying something that actually makes sense and logically follows on from what they said. So that didn't work out in this study. And then lastly, we tried controlling question asking. So we were able to control whether we asked questions, none of the time or all of the time and several points in between. And then here we found that when we increased our question asking rate to about 66%, and that's more than our baseline, and it's quite a lot more than the humans when they talk to each other, we found that this gave an improvement in several scores. So apparently this was a more appropriate level of question asking, it was voted more interesting and more engaging. So I think maybe the takeaway here is that people like talking about themselves, so if you ask them lots of questions, then they rate that better. Our third research question was, can we use these controls, find the kind of magic combination, to get a better chatbot experience overall? So the first answer is yes. By controlling these, the three attributes that actually gave us improvements, then we get better engagingness, that was the enjoyability metric. We get better engagingness ratings that are kind of approaching the human level. So by that I mean our bar there is close to the yellow bar. However, when we ask people about this humanness metric, are we having conversations that seem more human, then the evaluations were very, very far from the human level. So this means that our bots were almost as engaging as humans, but they were clearly not human. So people weren't really fooled, but they said that it was still a pretty enjoyable experience compared to the other humans. So I'm going to say another thing about this. So I think one thing you have to be careful with here is, what does this human bar mean? This yellow human bar was measured from getting Turkers to talk to each other in this artificial task where they had to take on a persona that wasn't theirs and talk to each other for about 6 to 8 turns in this way. So I think one thing that's interesting is that maybe that's not actually a very engaging task in itself. It's maybe not that enjoyable in the first place, so perhaps humans give each other pretty poor enjoyability ratings simply because they're not actually having a real conversation for fun, they're doing a conversation, for payment. So I think you have to be very careful here when you we could claim victory, right, and say that we're just as engaging as humans as conversationalists, but I think more accurately, we're about as engaging as humans doing this artificial task for payment rather than fun. So I think we have to be careful here and draw that distinction. So in any case, here are the conclusions from this work. So firstly, we found that control seems to be a good idea if you're building a neural sequence generation dialogue system. I'd recommend that controlling for these different attributes and maybe some others could be a pretty sensible and somewhat reliable way to get better results. We found that using some fairly simple control methods and controlling a few fairly simple attributes, we matched the performance of, oh, sorry, this part I took out, but essentially we got some human evaluation metrics that were pretty similar to a model that was trained on a lot more data. Thirdly, this might be obvious, but don't repeat yourself, don't be boring, ask more questions. These seem to be fairly good rules of thumb for having better conversations, whether you're human or a bot. Fourthly, we found that these multi-turn phenomena, like noticing if you're repeating yourself across utterances or how often you're asking questions over the whole conversation, these are all pretty important to conversational quality. So you need to evaluate your chatbot over several turns in order to detect these things. We noticed that engagingness is not the same thing as humanness. Apparently we were quite engaging, but not very human. So you should think carefully about which of these you might use as an overall evaluation metric in your chatbot. Lastly, we think that perhaps paid Turkers talking to each other are not the most engaging conversationalists and maybe not the best judges of engaging conversation either. So perhaps it would be better to try to somehow use humans truly chatting for fun as a better kind of metric or a bar to meet in terms of actual conversational quality. Thank you. Yep.
Did the female bots ask more questions? Because we know males don't never ask for directions.
Did you ask, do the female bots ask more? What does female bots mean? Okay. Okay.
Whether they're more male or female. Like the female ones might ask more questions and be more conversational. Go figure. But seriously, do you actually look at gender in these things when you evaluate these? Would you control gender as a variable?
So I think our main concern here was how do humans, and humans is the humans who were Turkers, perceive the quality of the conversation given the expectations of the task. So no, we definitely didn't have access to data like the gender of the Turkers.
No, the gender of the bot I'm talking about, because it's an attribute you can control, the gender of the bot.
What do you mean? Oh, I see what you mean. Okay, so you're saying like we want a control knob that says what is the gender of the bot.
You hadn't done the experiment yet, but if you had varied the gender of the bot, just speculate or just tell me to go away.
Right. So I can.
There's a lot of opinion about this. People think genders matter.
So you can imagine a scenario in which perhaps we get a bunch of training data from social media where we do know the gender of the people talking, and then we could try to train models that generate text in the style of people who I self-identify as different genders. I would bet that, yeah, those things are perceived differently. But I think it's a kind of a dangerous path to go down to kind of assign genders or gendered personas to bots, and I don't love the current trend where most kind of friendly bots kind of have to be female because people have preconceived notions about how women are more friendly. I think it's a dangerous path to go down when we kind of take that cultural stereotype and then bake it into the bots and thereby kind of perpetuate that cultural stereotype. So we certainly didn't do anything in this experiment, but that's my opinion about that trend in general. Okay. Was there a question here?
Yeah, I was just wondering, the function of W that you're learning, it seems like some of the responses, it is because it doesn't know what words it has already generated. So like coffee questions, it has already generated a lot of coffee words, and the FFW actually does not know that. Mm-hmm. Is there a way to be in the middle ground somewhere where you learn these things for a word but also condition on?
So you're asking about like conditioning on the text that you've already generated so you don't overdo it? Yeah, so there are some more sophisticated kind of text generation control methods, you might call them, sometimes using RL. So I don't understand them super thoroughly, but my understanding is that you have this kind of actor-critic model such that based on the generation so far, you kind of like evaluate how much you've like satisfied the constraints so far, and thereby it guides the rest of the generation. So we didn't try that method. It seems like an interesting one, but also quite a hard one to get right, and maybe it has its own problems as well. Yep.
At the beginning of your talk, you mentioned some of the challenges of being on that side of the spectrum, and one of them was high-level structure. Do you have ideas on how we can have control for such structure? Because I think the attributes you were looking for are sort of very local. Are you repetitive or not? But like, what are you trying to get to a point, or are you trying to have certain semantic coherence? Both of these are things that are hard to control, but seem like fundamental aspects of that.
Right, yes. So I think the reason we ended up controlling these fairly low-level, kind of relatively less ambitious things than the whole structure is because those low-level things were enough of a challenge to control that was quite a challenge. But yeah, as for how are we going to control these high-level things, I think there's been some really interesting papers recently, for example, in story generation, about how you might try to give a kind of a skeleton, a plot summary to a story generation model, and then it generates it. So I think there's kind of a lot of work in how would you get these kind of in-betweeny annotations of like what's the high-level structure as a skeleton before you have the actual natural language. As for like how to do the two-part thing where you generate the skeleton and then you generate the text, I think that's really hard as well. And it seems like part of the challenge is tied up with the question of what exactly should even be the representation of that high-level skeleton. So I guess my answer to your question is like that's hard, but I've read a lot of papers on it. It seems to be a lot of interesting things.
All right. Any more questions? Okay, thank you.
All right, thank you.
Well, that was fun. It's been a long day. There are many, many talks, but they are very, very good talks. And I say, let's give a round of applause to all the speakers who make this day very exciting and interesting and informative for all of us. Thank you for coming, and I would like to invite you to join us down the road here at the reception. It's about a 5-1 talk, that away. All right. Okay, let's go. That's